everyone and welcome to the Penetration Testing full course. Penetration testing or ethical hacking plays a crucial role in protecting organizations from cyber threats by identifying vulnerabilities before attackers can exploit them. It's a hands-on approach to strengthening the security of networks, applications, and systems. In this course, you will learn how to simulate real-world attacks, assess security weaknesses, and implement strategies to safeguard digital assets. You will gain expertise in tools, techniques, and methodologies used by cybersecurity professionals to test systems for flaws and improve defenses. And by the end of this course, you will be equipped with the knowledge and skills to conduct thorough penetration tests and help organizations stay resilient against evolving cyber threats. So before we begin, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's CEH V13 Ethical Hacking course with AI tools in collaboration with EC Council. It offers you the opportunity to earn the globally recognized CEH V13 certification. This comprehensive training program dives deep into AI-powered hacking techniques and cutting-edge GPT-based tools, covering 20 in-depth modules and over 500 advanced attack methods. It is designed to equip you with the skills to identify and mitigate security vulnerabilities, and the course emphasizes real-world application through 221 hands-on labs. Your enrollment includes official EC Council, e-courseware, and an exam voucher helping you prepare confidently for the CEH V13 exam. So check out the course link given in the description box below. Now, let us start by understanding penetration testing. Well, a penetration testing or pen testing is an authorized simulated attack on a computer system designed to elevate its security. In a pen test, security experts employ the same tools, techniques, and procedures as real-world attackers do to identify vulnerabilities and demonstrate the potential business impact of these weaknesses. So this process helps organizations understand where the defenses may be lacking and where improvements are needed. Penetration testing not only reveals vulnerabilities but also offers several key benefits. So let's quickly go over some of these advantages. So first on the list, we have proactive vulnerability identification. It helps you to uncover potential weaknesses before malicious actors can exploit them. Next, risk mitigation, which reduces the likelihood and impact of cyber attacks, safeguarding sensitive data. And the next advantage is regulatory compliance. Meet industry standards and legal requirements, avoiding penalties. Next is the cost savings. Prevent financial losses by addressing issues early and avoiding breaches. And then, enhanced trust. Build and maintain trust with customers and stakeholders by demonstrating robust security practices. And the next advantage is continuous improvement. Gain insights that drive ongoing security enhancements and risk management. Now, let's dive into the phases of penetration testing, each one building on the previous to ensure a thorough security evaluation. And the first phase is planning and reconnaissance. So we start with planning and reconnaissance. In this initial phase, the pen tester defines the scope and goals of the test, identifying which systems will be targeted and outlining the testing methods to be used. It also involves gathering crucial intelligence such as network details, domain names, and mail server information to gain a clear understanding of how the target operates and where its vulnerability might lie. Now, moving on to the next phase, which is scanning. Once the groundwork is laid, the next phase is scanning. Here, the tester examines how the target application responds to various intrusion attempts. So this is achieved through both static and dynamic analysis. Static analysis involves inspecting the application's code to predict its behavior, while dynamic analysis observes the code in a running state, providing real-time insights into its performance and weaknesses. After scanning, the focus shifts to gaining access. So in this stage, testers employ various web application attacks, such as cross-site scripting, SQL injection, and the use of backdoors to exploit discovered vulnerabilities. By escalating privileges, intercepting traffic, or even stealing data, they demonstrate the potential impact these weaknesses could have on the system. So the process then moves to maintaining access. So the aim here is to see if vulnerability can be exploited to establish a persistent presence within the system, mimicking advanced persistent threats. So this phase is critical as it shows how attacker might remain hidden for extended periods, gaining deeper access to sensitive information. And finally, all the findings are brought together in the analysis phase. The tester compiles a detailed report that outlines the specific vulnerability exploited, the sensitive data accessed, and the duration for which they were able to remain undetected. So this comprehensive analysis provides organizations with actionable insights to strengthen their security posture. Here, each phase plays an essential role in ensuring that the penetration testing process is methodical and effective. This ultimately helps organizations secure their systems against potential attacks. Now, let's explore the different methods of penetration testing, each offering a unique perspective and evaluating a system's security posture. And the first method is open box penetration testing. In open box penetration testing, the tester is provided with some information about the target company's security setup. This prior knowledge allows the tester to focus on specific areas of concern and design targeted simulations that validate the effectiveness of existing security measures. On the other hand, closed box penetration testing, often referred to as a single blind test, limits the tester's information to only the target company's name. And this approach challenges the tester to uncover vulnerabilities without any inside clue, and closely replicating the conditions an external attacker would face. And the next method is covert penetration testing. In covert penetration testing, also known as a double-blind test, the situation is taken a step further. Almost no one within the organization, including the IT and security teams, is aware that a test is underway. This method is particularly useful for simulating the stealthy nature of real-world attackers. However, it is essential that the tester has documented details of the scope and rules of engagement to ensure legal and ethical boundaries are maintained. Another distinct method is external penetration testing, where the ethical hacker focuses on the company's outward-facing technology, such as its website and external network servers. In some cases, the tester may not be permitted to enter the company's premises, meaning the attacker is orchestrated remotely or even from a nearby location, mirroring the tactics of a determined outsider. And lastly, internal penetration testing involves conducting the assessment from within the company's own network. This method is invaluable for understanding the potential damage that could be inflicted by an insider threat or an attack who has already bypassed external defenses. By simulating an internal breach, organizations can gauge the effectiveness of their internal controls and response strategies. So each method provides a distinct approach to identify vulnerabilities, ensuring that organizations receive a comprehensive evaluation of their security landscape. Now, there isn't a one tool for penetration testing. Different targets demand specialized approaches for tasks like port scanning, application scanning, Wi-Fi break-ins, or directly breaching a network. Broadly speaking, the tools used in penetration testing fall into 5 main categories. The first category is reconnaissance tools, which are essentially for discovering network hosts and open ports. Tools like Nmap provides a detailed overview of a network's layout, while utilities like Angry IP Scanner help quickly identify live hosts and active services. Next, vulnerability scanners comes into play. These tools are designed to probe network services, web applications, and APIs for potential security issues. Tools like Nessus and OpenVAS scan for known vulnerabilities, offering insights into where defenses might be weak. Then there is a proxy tools, which serve as a specialized web proxies or generic man-in-the-middle proxies. Tools such as Burpsuit is widely used to intercept and analyze traffic, allowing testers to manipulate requests and responses to uncover security flaws in web applications. Exploitation tools form the fourth category. These tools are used to leverage the vulnerabilities uncovered during earlier phases. Metasploit, for example, is a well-known exploitation framework that enables testers to develop and execute exploits and effectively demonstrating how a breach might occur. And finally, post-exploitation tools are crucial once access has been gained. They allow testers to interact with compromised systems, maintain their foothold, and even expand access to further illustrate the potential damage. Tools like Cobalt Strike and Partial Empire exemplified this category, providing functionalities that simulate the persistent threats seen in real-world attacks. And each of these tool categories plays an integral role in the penetration testing process. It ensures that every step, from initial reconnaissance to post-exploitation, is thoroughly executed to evaluate and ultimately strengthen an organization's security posture. Now that we have covered the theory behind penetration testing, so it's time to see it in action. So in this final segment, we will dive into a live demonstration by exploiting a vulnerable application known as Death Note. We will walk you through the exploitation process step by step, showing you exactly how vulnerabilities are identified and leveraged. So first, open your web browser and navigate to www.vulnerhub.com. So once the page loads, locate the search box at the top of the site and type in Death Note before pressing enter. So when the search result appears, click on the Death Note 1, enter to open its dedicated page. And on this page, you will find a download section that includes a mirror download option. So click on the mirror download option, which will immediately start downloading the file named deathnote.ova and allow the download to complete. So now that you have downloaded the Death Note 1 OVA file, so let's set it up in VirtualBox. Step 2. Setting up Death Note 1 in virtual machine. Open VirtualBox and let's click on Import. In the File section dialog, navigate to and select the Death Note 1 OVA file and import it. And once the import is complete, proceed to the virtual machine settings. Next, switch to the network settings and change the network connection type to host only. Now, confirm these changes by clicking OK. And finally, start the virtual machine to launch Death Note 1 and begin your penetration testing demonstration. Now that you have set up the target machine, so let's configure your attacker machine, Kali Linux, to begin the reconnaissance phase. Now, moving on to step 3, booting up our Kali Linux machine. So before booting up your Kali Linux virtual machine, open its settings and add a second network adapter. Now, configure this new adapter to use a host-only connection to ensure proper network isolation for testing. Once done, boot up your Kali Linux machine. Once the system has fully loaded, open a terminal window. To ensure that your machine has the latest packages and security patches, run the following command. With the update complete, your Kali Linux machine is now ready for reconnaissance and further testing. Now, moving on to step 4, exploiting the vulnerable machine. So first, identifying the target IPI address. So for that, open a terminal and run the netdiscover command to find the target machine's IP address. Since we have added another host-only adapter connection on our Kali machine, we are using the second network interface ETH1 instead of ETH0. From the scan results, note that the target IP is 192.168.56.103. And next, we will perform a thorough network scan to detect open ports on our target machine. Now, we are moving on to our next step, which is performing a network scan. So, we will perform a thorough network scan to detect open ports on our target machine. So, for this, we will be using Nmap with the -SS, -SC, -SV and -P switches. So, in the following command, -SS for a TCP SYN scan, which is fast and effective for scanning thousands of ports. And then we have -SC to run a default script scan for additional context. And following that, we have -SV for version detection, which helps identify the services running on each port. And finally, we have -P to ensure that all ports are scanned. So this scan is critical to enumerate the available services and design targeted attacks. Now, by analyzing the output, we notice two open ports. One is the port 22 SSH, which indicates an SSH service is running. If valid credentials are obtained, this could allow login access. And the second port is port 80 HTTP, which indicates that a web server is running and may be hosting a vulnerable website. Now, let's start with examining the web content on port 80. So for that, Open a web browser and navigate to the target IP. Okay, so here we come across an error which says can't connect to the server at detnode.1. This error can occur if the browser can't resolve the hostname because either the URL was mistyped or no hostname was provided. So to resolve the hostname issue, we can edit our local host file, which is located in the etc directory. To do so, open a new tab on your terminal and open the host file within Nano Editor. Here, we will add an entry associating the target IP with the expected hostname. So for that, let us enter the IP 192.168.56.103. Following that, we will enter the hostname, which is detnode.1. And then we will save the changes using Ctrl+X and confirm with enter. Now, we can verify the entry using the cat command to display the content in the host file. So type cat etc host. Now, reload the web page. With the host name properly mapped, the site should load without errors. So once the page loads, examine the URL and page structure. So the website appears to be built using WordPress, which is a common target for vulnerabilities. To gather more details about it, we can use WP Scan to assess the site for known issues. So open a new tab on your terminal and run WP Scan with the -- URL flag followed by the URL. Alright, so the output shows that the WordPress version is secure, but pay attention to other details. The details such as the server is hosted on Apache and XML RPC is enabled, though not immediately useful. And the WordPress README file is accessible and the uploads directory is open, which might have potential hints for further exploitation. So let's go ahead and access the uploads directory. Here we have a directory named 2021. So let's go ahead and see the content inside. Now we have 3 more directories inside. So let's go ahead and check them one by one. So in this 07 directory, we have multiple .jpg files along with the notes.txt and users.txt files. Likewise, we check for the 08 and 09 directories, but we couldn't locate any files within them. Next, we'll be performing directory bursting to uncover hidden directories or pages. So for this, we are using dir search. Although it is not primarily available on Kali Linux, it can be easily installed by simply typing dir search and typing y when prompted. So once it's installed, we will proceed with the directory enumeration by specifying the target URL using the -u flag. As a result, we have got the WordPress admin page, but we cannot log into this as we don't have valid credentials. Now, instead of performing directory enumeration on the WordPress directory, we will perform the same dir search scan on the detnode.1 web page as there might be some hidden or hardly accessible directories on it. So from the results, we can see that there is a robots.txt file present on the detnode.1 web page. Now, let's go ahead and open the robots.txt file by navigating to robots.txt file in our browser. So we will look for any hints or entries that might point to sensitive files. So in this case, we discover a references to an image file named important.jpg that appears to be mistakenly added to the target application. So let's go ahead and open this image file on our browser. Okay, so it says that the image cannot be displayed because it contains errors. So since the image file does not open properly in the browser, we will download it using wget. Alright. Now, let's try to open this image file. So even after downloading the file, we are facing the same error as before. So let's use the file command to determine the type of the file. So let's type file important.jpg. So the result says that this file is in the form of an ASCII text. So We will rename the file extension from .jpg to .txt for easier inspection and open the file. Here, we get a hint that tells us about a login username in the user.txt file. It then asks us to find the password ourselves. So previously, we have seen this user.txt file when we were accessing the uploads directory. We also found a notes.txt file that looks like a word list. So if we try to perform a brute force attack, it can act as a password list. Again, we will use wget to download both .txt files on our systems and perform a brute force attack. Now we have both the word list for username and passwords. So let's go ahead and perform a brute force attack on the SSH service using Hydra. So from the following command, we are using -l flag to load the list of usernames and -p flag to load the list of passwords. And from the result, we got the login username and password for the user to log into the server using SSH. So now, let's try to log into the SSH server using these credentials. Alright, so it will ask if you are sure about connecting. So type yes and then enter the password that for me to continue. And as you can see, we have clearly logged into the SSH server. Now, let's list out the files and directories using the ls command. So here we found the user.txt file and let's go ahead and view the content of this file using the cat command. Okay, so the content inside seems to be encoded. So, in order to identify the type of encryption, we will use the cipher identifier by decode.fr. Now, we will copy the content of the user.txt file and paste it into the cipher to recognize box and press analyze. Now, this will tell you about the encryption method, and when you click on the method name, you will be redirected to the interpreter. Okay, so here we will simply paste the content of the user.txt again and it will decode it for us. So as you can see the screen, the result says that I think you got the shell, but you won't be able to kill me, says Kira. Now, if you go back to the user.txt file we downloaded on our device, we had an entry for the user Kira. So this might be indicating that we have to access the content inside the user Kira to proceed forward. Alright, now let's run the id command to check the current user's privileges. So since user L doesn't have root privileges, we have to identify further information about the target machine, which will help us in gaining the root access. So to identify the rights and privileges of the current user, we will execute the sudo -l command. So now, the output says that, sorry, user L may not run sudo on death note. So this indicates that there might be another user on this machine which might have root privileges to run sudo commands. So to list all the users and check for their privileges, we will go to the home directory and use ls-al to list all the users. So here we have two users, Kira and L. So there's a possibility that the user Kira might have root privileges, but we don't have access to the user Kira. But we can definitely see the files inside it. So we will change to the Kira directory and use ls-al to view hidden files. Alright, so here we can notice that the presence of a file named kira.txt. But when we attempt to open it with the cat command, we receive a permission error, indicating that we are not logged in as Kira. Now, there is a trick to switch to user Kira if there is a loophole while configuring the SSH server. So let's go ahead and check the configuration files present in the .ssh directory of the user Kira. Now this directory contains an authorized keys file. This means this file contains public keys for public key authentication. So let's go ahead and view its content. So let us type cat authorized _keys. So in order to switch to the user Kira, we have to insert the same public keys in the .ssh configuration folder for the user L. So let's go ahead and copy the content in a newly created file named authorized_keys in the user L.ssh folder. Now, let's paste the copied content here and save the file. Next, let's apply executable permission to this newly created authorized keys file. Alright, now with the proper authorized keys in place, let's use SSH to switch to the Kera account. And as you can see, we have successfully logged in as a user Kera in our target machine. Now, let's read the content inside the kera.txt file. So for that, let us type cat kera.txt. So this file contains some binary text that looks like it's encoded using the base64 algorithm. So now, let's head to our browser and use the base64 decoder on decode.fr to decode the content. So copy the content inside the file and paste it into the box and press decode. And the output says, please protect one of the following, the user L or MISA. So let's go ahead and change the directory to OPT directory and list all the files and directories. Here we arrived at the L directory as we saw in the hint. So let's list the content inside the L directory. So here we have two more directories, fake notebook rule and Kera case. So let's go ahead and view the content inside the fake notebook rule first. Here we have two more files, which is case.wav and hint. So here case.wav is a music file and hint as a .txt file. So let's see the hint file first. So let us type cat hint. And it says use Cybersecurity. This means there might be some encoded text hidden inside the case.wav file. So let's check the file type using the file command. So file case.wav. And it says it's an ASCII text file. So let's list the content inside the case.wav file using the cat command. So type cat case.wav. And the text file contains a series of hexadecimal digits which can be decoded using Cybersecurity. So we have head to our browser. Now let us open Cybersecurity. Alright, in Cybersecurity, search for from hex and drag the hexadecimal input into the recipe area and paste the copied hexadecimal content into the input box. So once done, the output we got here looks like it's encrypted with the base64 algorithm. Empty the recipe box and search for from base64 and drop it to the recipe area. And then paste the base64 output we got before it in the input box. Alright, we got the password to the user Kera. And here it is. So with the password for Kera now in hand, let's verify Kera's sudo privileges by running sudo-l and enter the password for Kera. And it says that user Kera has all the permissions. This means we have escalated the highest privileges on the target machine. Now, to obtain the flag that we are looking for, simply change the directory to root directory. And here it says permission denied, but it can be easily fixed by switching into super user. So we have typed sudo su. Now let's switch the directory. So here we have a root.txt file. So let's go ahead and view the content of this file. So type cat root.txt and there you go. We have successfully obtained the root flag.
Before we get into what cybersecurity is, let's first look at why it's so important today. Imagine you wake up and hear that a company has lost millions just because of cyber attack. Talking about such an attack, a few years back on May 7, 2021, Colonial Pipeline, which is a major American oil pipeline system, became the victim of a ransomware attack. Colonial Pipeline is an oil pipeline that was established in 1962. It spans over 5,500 miles from Texas to New Jersey, transporting gasoline, jet fuel, and heating oil. This pipeline is essential in transporting oil products from the Gulf of Mexico to the east coast of the United States. This attack involved multi-stages against Colonial Pipeline IT systems. The pipeline's operational technology systems, which actually move oil, were not directly compromised during the attack. The attack began when a hacker group identified as DarkSide assessed the Colonial Pipeline network. Within a 2-hour window, the attackers stole 100 gigabytes of data. Following the data theft, The attackers affected the Colonial Pipeline IT network with ransomware that affected many computer systems, including billing and accounting. Colonial Pipeline shut down the pipeline to prevent the ransomware from spreading. Security investigation firm Mandiant was then brought in to investigate the attack. The attacker group demanded a ransom of 75 bitcoins, which is worth $4.4 million USD. Colonial Pipeline paid dark-side hackers to get the decryption key, enabling the company's IT staff to regain control of its systems. Although the ransom was paid within hours, but the tool provided to restore their systems was slow and ineffective, which caused further delay and economic loss. The reputational damage was even worse. Now let's see the root cause of the attack. Attackers got into the Colonial Pipeline network through an exposed password for a VPN account. A Colonial Pipeline employee likely used the same password for the VPN in another location. The password was somehow compromised as a part of a different data breach. Password reuse has become a common problem, as many users often use the same password more than once. Here is an attack summary to understand the attack clearly. The date was May 7, 2021. The attack type was a ransomware attack. The attacking group was DarkSide and the loss was of 75 bitcoins, which was around $4.4 million USD. And this wasn't the only major attack. About a decade ago, there was another big attack known as the Sony PlayStation Network outage. Before diving into the attack, let's take a quick look at what Sony PlayStation Network was before 2011. Launched in November 2006, PSN was an online gaming service for PlayStation consoles, offering features like online multiplayer gaming, digital game purchases, and streaming services. By 2011, PSN had grown into a major platform with millions of users worldwide, becoming a central hub for PlayStation gamers to connect, play, and access a wide range of digital content. It was a crucial part of Sony's gaming ecosystem, with a rapidly expanding user base. The PSN was not just a gaming platform. It was also a social network where players could interact with friends, join gaming communities, and share achievements. The network's popularity soared with the success of the PlayStation 3, attracting a diverse and loyal customer base. By early 2011, millions of PlayStation users were regularly logging into the PSN, making it one of the largest online gaming platforms at the time. But then, in April 2011, everything changed. The hacktivist group Anonymous targeted Sony's PlayStation network and brought it down with a distributed denial-of-service attack. The attack was in retaliation for Sony's legal actions against two individuals, George Hodge, known as GeoHot, and Alexander Igoreno, known as Graf Chocolo. These hackers had previously exposed vulnerabilities in Sony's PlayStation 3, enabling users to bypass the console security features. Anonymous warned Sony, stating, "You have victimized your customers merely for possessing and sharing information. Now you will experience the wrath of Anonymous." On April 19, 2011, Sony detected an external intrusion on their system, affecting both PlayStation Network and Curiosity services. By April 20, Sony had taken the PSN servers offline to protect its users, leaving millions without access to online gaming for several weeks. However, the most alarming part of this breach was the exposure of sensitive user data. The personal information of 77 million users, including names, addresses, emails, PlayStation networks, passwords and logins, and even PSN online IDs was compromised. In some cases, users' profile data, including purchase history and billing addresses, may have also been accessed, raising serious concerns about identity theft. The financial damage was immense, costing Sony an estimated $171 million. However, the reputational damage was even worse, as Sony faced significant backlash from its users and multiple lawsuits. Now let's see the root cause of the attack. The attack was fueled by Sony's decision to remove the Other OS feature from the PlayStation 3, which allowed users to install Linux. Hackers motivated by this removal sought to expose vulnerabilities in Sony's system. Anonymous, angered by Sony's legal actions against those hackers, took matters into their own hands, and that led to the attack that crippled Sony's network and exposed the personal data of millions. Here is an attack summary to understand the attack clearly. The date was April 17 to 19, 2011. The attack type was an external intrusion. The attacking group was anonymous and the loss was of $171 million USD. As we have seen from these real-world examples, cyber attacks can have devastating impacts. Now, while these two attacks were significant in their own right, they are just a few examples of many cyber incidents that happen every year. To give you a clearer picture of how cybersecurity vulnerabilities have been increasing over the years, let's take a look at some data. As you can see from this graph, the number of reported vulnerabilities has been rising year after year, from small breaches to massive cyber attacks like the ones we just discussed. The scale of problem is growing. In fact, by 2024, we have seen vulnerabilities reach unprecedented levels, making cybersecurity more critical than ever before. Here is another graph that breaks down the vulnerabilities by type, including some of the most common ones like XSS, CSRF, SSRF, XSE, and denial of service attacks. These vulnerabilities are exploited every day by malicious actors to gain access to sensitive information, disrupt services, or cause financial and reputational damage to companies. Whether it's through exploiting weak spots in systems or using social engineering techniques, these threats are becoming more sophisticated, and it's crucial that we understand them so we can protect against them. Now that we have seen the impact cyber attacks can have and how vulnerabilities continue to rise year after year, it's clear that we need strong defenses in place. So, what exactly is cybersecurity and how does it protect us from such threats? Let's dive in. According to CISA, cybersecurity is the art of safeguarding our networks, devices, and data from criminal use while ensuring confidentiality, integrity, and availability. Let's break that down into three key pillars. First is the confidentiality. It is all about protecting sensitive information from unauthorized access. For instance, only those with the right permissions can access specific data. Then comes the integrity, which ensures that the data remains accurate and unaltered by unauthorized parties. Last is the availability, that makes sure that the information or the service is accessible when needed by authorized users. Now that we have a clear understanding of what cybersecurity is, let's dive deeper into how it's implemented. Think of them as the fundamental rules and guidelines that form the foundation of a strong cybersecurity posture. They act as our trusty guide through the digital wilderness. Moving on to our first principle, that is confidentiality. It is about keeping information private. For example, when you send a message through WhatsApp, it's encrypted, which means only you and the person you are messaging can read it. This keeps the conversation private and no one else can access it, even if they manage to intercept the data. Next comes the integrity, which ensures the information is not changed without permission. Imagine you download a file from the internet and the website provides a unique code to verify the file. Before using the file, you can use this unique code to verify that it hasn't been tampered with and is safe to use. Next is the availability. It's about keeping sure information and systems are always accessible when needed. For example, if you're using Google Drive, Google makes sure your files are available even if one of their servers goes down. They do this by storing your data on multiple servers so you can always access your files. Next is the authorization. Controls what you can do after you log in. For instance, in a company's system, employees might log in with their credentials, but what they can access depends on their role. A regular employee might only see their own files, while a manager can access department-wide data. This ensures that people only access what they're supposed to. Then comes the authentication. This is how you prove who you are when you log into a system. A simple example is when you enter your password to log into your email. To make it more secure, some systems use two-factor authentication, where after entering your password, you might also have to enter a code sent to your phone. This makes sure it's really you logging in. Next is a non-repudiation. Means ensuring that someone cannot deny they did something. A good example is digital signatures. When you sign an online document with a digital signature, it creates a record that proves you signed it. Later, you can't say you didn't sign it because the digital signature is unique to you. Moving on to accountability. Means tracking who does what in a system. For example, in a company's network, all activities like who accessed which files and when are logged. These logs help the companies track actions, making sure that everyone is responsible for what they do. Last is the auditability. It's about keeping records so actions can be reviewed later. Imagine a company uses software to track all changes made to important documents. If something goes wrong, they can review the history to see who made changes and when, helping them figure out what happened. With these principles in mind, you now have a solid understanding of how cybersecurity works at its core. But to truly grasp cybersecurity, we need to also understand the networks we protect. Up next, we'll dive into networking basics, covering everything from network types and components to firewalls and IP addressing. Imagine you are in a large office building. There are hundreds of computers, printers, and other devices, all needing to communicate with each other to share information, resources, and access the internet. This communication is made possible through what we call a computer network. A computer network is essentially a collection of interconnected devices, like computers, servers, and routers, that communicate with each other to share resources and information. This connectivity is crucial for everything from sending an email to accessing cloud services. Without networks, our digital world would be fragmented and isolated. Now that we know what a computer network is, let's explore the different types of networks that exist and how they fit into various scenarios. First, we have LANs, or local area networks. These are networks that cover a small geographic area like a single building or a campus. For example, the network in your home or office is a LAN, connecting your computers, printers, and other devices. Next is a WAN, or wide area network. WANs cover larger geographic areas such as cities, countries, and even continents. The internet itself is the largest WAN, connecting millions of LANs across the world. WANs are essential for businesses with multiple locations, enabling them to share resources and communicate effectively. Then we have MANs, or metropolitan area networks. These networks cover a larger area than the LAN, but are still limited to a specific city or large campus. They are often used by universities or city governments to connect multiple buildings within a specific area. Lastly, we have PANs, or personal area networks. These are the smallest networks, typically covering just a few meters. Think of the Bluetooth connection between your smartphone and your wireless earbuds. That's a PAN. Now that we have seen the different types of networks, let's take a closer look at the key components that make these networks work smoothly. First is a modem. A modem is a device that converts digital data from a computer into a format suitable for a transmission medium, like telephone lines and vice versa. Next comes the network interface card. It is a hardware component inside a computer that enables it to connect to a network. It can be wired or wireless too. Next is a repeater. A repeater is a network device that receives a signal, amplifies it, and retransmits it to extend the range of communication over long distances. Moving on to hub. A hub is a basic network device that connects multiple computers in a local network. It broadcasts the data to all devices connected, regardless to which device the data is meant for. Next comes switch. A switch is a more advanced version of a hub that can direct the data it receives only to the device it is meant for, making it more efficient. Next is a router. A router connects different networks together and routes data between them. It can connect devices within a local area network to the internet. Moving on to bridge. A bridge connects two separate networks, allowing them to function as a single network. It works at the data link layer and helps divide networks into segments to reduce traffic. Last is a gateway. A gateway is a device that connects two different networks that use different protocols, allowing them to communicate with each other. Having covered the essential components that help networks function, let's move on to one of the most crucial defenses in cybersecurity, that is firewall. A firewall is defined as a cybersecurity tool that monitors incoming and outgoing network traffic and permits or blocks data packets based on a set of security rules. Think of a firewall as a gatekeeper for your network. It ensures that unauthorized or harmful data doesn't get into your network and that sensitive data doesn't leak out. Imagine you're sending a request to visit a website. Your request first goes through the firewall, which checks if it's safe. If it is, the request is sent to the internet, where the website server processes it and sends a response back. The firewall checks this response, allowing only legitimate data to reach your device. If the hacker tries to send malicious data, the firewall blocks it, keeping the network safe. Now we understand the basic concept of a firewall and its role in protecting networks. Let's explore the different types of firewalls and how will they offer various levels of security. First, we have the packet firewall. It controls network traffic by inspecting source and destination IP addresses, protocols, and ports without analyzing the state of connection. Next is the stateful inspection firewall. Monitors the full state of active connections and allows traffic only if valid sessions is established, blocking unauthorized packets. Next is the application layer firewall. Inspects traffic at the application layer, blocking malicious or suspicious application level requests, like HTTP, that could harm the network. Moving on to next generation firewall. It provides advanced security by combining traditional firewall capabilities with additional features like intrusion prevention, application control, and cloud threat intelligence. Next is a circuit level gateway. It secures TCP/UDP connections by managing sessions at the OSI model's session layer. Ensures packet exchange is valid between trusted endpoints. Moving on to the software firewall. It protects an individual computer by running as software. notifying users of potential threats from unauthorized access or malicious websites. Then comes the hardware firewall, a physical device that monitors and filters traffic at the network boundary, enforcing access controls and security policies on inbound and outbound traffic. Last is the cloud firewall, a cloud-deployed firewall that filters traffic at the cloud level, offering protection against unauthorized access to private networks without the need for physical infrastructure. Now that we understand the role of firewalls, let's explore how devices in a network communicate with each other using IP addresses. Just like every house on a street needs a postal address, every device on a network needs an address. This is where IP addresses comes in. An IP address or Internet Protocol address is a unique identifier assigned to each device on a network. It allows devices to find and communicate with each other. There are two types of IP addresses. The first is the IPv4, then comes the IPv6. IPv4 is the older version and uses 32-bit address, like 192.168.1.1. However, with the explosion of devices needing IP addresses, the available IPv4 addresses are running out. This is where IPv6 comes in. IPv6 uses a 128-bit address, providing a much larger pool of addresses. This ensures that we won't run out of the addresses anytime soon. IP addresses are like postal addresses in the digital world, ensuring that devices can locate and communicate with each other. Now that we understand how devices are identified and connected, let's dive into how web servers communicate using HTTP status codes. Now let's have a small quiz in what we have studied earlier. Going on to our first question. Which firewall monitors and keeps track of the state of active connections? And the options are A. Next generation firewall, B. Software firewall, C. Stateful inspection firewall, and D. Packet firewall. If you know the correct answer, please comment below. Now that we have discussed IP addressing, let's go ahead and perform a simple demo on how we can find IP addresses of our machines. But before that, we have to install some prerequisites. So let me show you how to install VMware on your personal computer and run a virtual environment like Kali Linux on it. But before that, let's break down what exactly is virtual machine. First, we have the infrastructure. This is your physical computer or the host machine, which provides the hardware resources like CPU, memory, and storage that the virtual machine will use. Examples are cloud servers, databases, and your personal computer. Then we have is a hypervisor, which is a software that lets you run virtual machines on your computer and manages how resources are shared between them. Examples are Oracle VirtualBox and VMware Workstation. Then we have the guest operating system. Now this is operating system that runs on your hypervisor. For us, it's going to be Kali Linux, but other examples are Windows and Ubuntu. With that said, let's get started with the installation. Alright, let's start by getting VMware. First, open up your favorite web browser. Could be Chrome, Firefox, Edge, whatever you like. Now in search bar, just type in VMware Workstation Pro and hit enter. You'll want to click on the very first link that pops up. It should take you directly to the official VMware page. Once you're on the site, you'll see two main options. The first is Workstation Pro and Fusion Pro. Now we are interested in Workstation Pro because that's the one for Windows. Scroll down a bit and you'll find a download button that says VMware Workstation Pro Download. Go ahead and click that. Now this will take you to the Broadcom website. They handle VMware downloads. It used to be much easier before this change. Back then, we could download it directly from VMware without having to log in or create an account. But now, Broadcom requires a login to proceed. It's just an extra step. But it doesn't take long. If you already have an account, just sign in. And if you don't, no worries. Registering is quick and simple. While registering, it's not important to register with your company's email. You can also use your personal email as well. Once you're logged in, you land on the VMware Workstation download page. Now make sure you're downloading the right version. We need the VMware Workstation Pro 17.0 for personal use, that is Windows. Personal use is a key here because we don't want the commercial version. Go to 17.6.1 and click on that. Now agree to the terms and conditions. And on the right hand side, you will see the little download icon. Click on that. And your download should start immediately. Easy, right? Now that we have got VMware, let's move to downloading Kali Linux. Before that, let's talk about Kali Linux. It's a Debian-based operating system that is specially designed for ethical hacking and penetration testing. It comes pre-installed with hundreds of security tools that professionals use for their own day-to-day tasks, like network scanning, vulnerability testing, and password cracking. With that said, let's start with the installation. Head over to your browser again, and this time, type Kali Linux into the address bar. Hit enter, and just like before, click on the first link that pops up. This will take you straight to the official Kali Linux page. Once you're there, you'll see a big download button. Go ahead and click that, and you'll be asked to choose your platform. Since we are setting up this on the virtual machine, you're going to select the option for virtual machines. Now, scroll down a bit, and you'll see several download options. Since we are using VMware, make sure to pick the one specifically for VMware. You'll find the download icon right next to it. Click on that, and your download should start right away. Wait patiently until the download is complete. Now that we have both these files ready and downloaded on our desktop, let's start with the installation process. So first up, we'll install VMware Workstation Pro. Head to the folder where we downloaded the VMware installer file. You should see the file named something like VMware Workstation full.exe. Let's double click on that to start the installation. A prompt will appear asking for permissions to continue. Click yes. After that, the VMware installer window will pop up. Click next to get started, and then you will be shown the license agreement. You know the drill here. Just click on the box that says I accept the terms in the license agreement and hit next. Now you'll see an option asking if you want to add VMware Workstation console tools to your system path. Make sure this box is checked. It's really useful, trust me. Next, you'll see two options related to the user experience. You can uncheck these if you don't want to send usage data to VMware. Totally up to you. If you prefer not to have a desktop shortcut like me, go ahead and uncheck the desktop shortcut option. Once all that's done, hit install and let the magic happen. VMware will install itself on your system. And when it's finished, click Finish. If you have a license key, you can enter it now. But if you don't, no worries. Just click on Finish again. And we have done with the installation of VMware Workstation. Now that VMware is installed, let's move on to setting up Kali Linux. Go to the folder where we downloaded the Kali Linux zip file. Right-click on it and choose Extract All. You can extract it wherever you prefer on your system. Once the extraction is done, open the folder and you will see a bunch of files. What we are interested in is the one with the .vmx extension. That's the virtual machine configuration file. Now just double-click on that .vmx file. This will automatically open VMware Workstation and start the import process for Kali Linux. Once imported, Kali Linux should appear inside VMware Workstation as a new virtual machine. And there you go. Your Kali Linux VM is all set up and ready to run. Alright, now that Kali Linux is imported into VMware, we need to make a few changes before booting it up for the first time. First, click on Edit Virtual Machine Settings. Then we'll open up the setting window. Under the Hardware tab, you'll see an option for memory. Now for smoother operation, I recommend assigning at least 4 GB of RAM to your virtual machine. But if your computer has less available RAM, you can leave it to 2 GB and it should still work fine. Once that's done, click OK to save your settings. Now you're ready to boot up the Kali machine. Click on Power on this virtual machine. This will start up your Kali Linux VM. Once the machine boots up, you'll arrive at the login screen. Here, you'll need to enter the default credentials. The username is Kali And the password is also Kali. Simple enough. You're now inside your Kali Linux virtual machine. Here you go. We have successfully installed the Kali Linux virtual machine. Now let's go ahead and see how we can see the IPv4 and IPv6 address of our Windows host machine and as well as Kali virtual machine. Starting with Windows, open your terminal and type ipconfig. Hit enter. And now you can see the IP Windows configuration on the screen. Now if you scroll down, you will see something like wireless LAN adapter Wi-Fi address. Under that, you can see link local IPv6 address. So this is our IPv6 address. And we also have the IPv4 address. That is 192.168.0.96. This is how we check the IPv address for the Windows machine. Now let's see how to do the same for our Kali machine. Same as we did before, go to your terminal and type ifconfig and hit enter. You can see something like inet 192.168.112.128. This is our IPv4 address. And we can see inet 6, that is the IPv6 address. So this is how we check the IP addresses for Windows and Linux machine. When you interact with the website, the web servers respond with specific status codes that tell you what's happening behind the scenes. First, we have the informational status code starting with 1. Indicates that the request was received and is still being processed. Then we have the success status code starting with 2. Confirms the request was successful like a 200 OK status. Then we have is the redirection status code which starts with 3. Tells the client that further actions is needed to complete the request. Moving on to the client errors status code which starts with 4. Indicates an issue with the client's request. Last we have the server error status code which starts with 5. Shows there is a problem on the server side. Now that we have covered the status codes, let's talk about some of the most common HTTP errors you may encounter and what they mean. First we have the 401 unauthorized. That means the client is not authorized to access the requested resource. Next is the 400 bad request. The server cannot understand the request due to bad syntax. Moving on to 404 not found. The server cannot find the requested resource. Next we have is the 403 forbidden. The client does not have permission to access the resource. Then comes the 500 internal server error. A generic error message indicating the server encountered an unexpected issue. Last is the 503 service unavailable. The server is currently unable to handle the request due to being overloaded or under maintenance. After exploring how web traffic functions and how errors are communicated, it's time to look at the larger picture, how data flows across networks using different models. Let's first break down the OSI model, then the TCP/IP model, and finally we'll compare both to see how they align. The OSI model is a conceptual framework developed by the International Organization for Standardization that is used to understand and implement networking protocols in 7 distinct layers. Each layer serves a specific function and interacts with the layers directly above and below it. The first layer is the physical layer. This is the lowest layer of the OSI model. It deals with the physical connection between devices, including the transmission and reception of raw data bytes over a physical medium such as cables, switches, and hubs. The physical layer is responsible for defining the hardware specifications, transmission rates, and encoding methods. The next layer is the data link layer. This layer establishes, maintains, and decides how data is transferred between directly connected nodes in a network. It ensures that the data reaches its destination without errors. This layer is further divided into 2 sublayers. First is the media access control, which controls how devices on the network gain access to the data and also gives permission to transmit it. Next is the logical link control, which controls frame synchronization, flow control, and error checking. The third layer is the network layer. The network layer is responsible for the logical addressing and routing of data. It decides the path that data should take across the network, often using routers to forward packets to their destination. This layer handles packet forwarding, including routing through different routers. The fourth layer is the transport layer. The transport layer ensures the reliable transmission of data between systems. It controls flow, handles error correction, and ensures that the data is delivered in the correct sequence. It also manages data segmentation and reassembly. This layer supports both TCP, which is connection-oriented, and UDP, which is connectionless. The fifth layer is a session layer. This layer manages sessions or connections between applications. It establishes, manages, and terminates the communication sessions between two systems. It also controls dialog control and synchronization. The sixth layer is a presentation layer. The presentation layer translates data between the application layer and the network. It is responsible for the data format translation, encryption, and compression. This layer ensures that the data sent from the application layer of the one device can be read by the application layer of another device, even if they use different data formats. The last we have is the application layer. The application layer is the closest layer to the end user and is responsible for network services to applications. It directly interacts with a software application that implement a communication component. It provides services like email, file transfer, and network resource sharing. The TCP/IP model, also known as the Internet Protocol Suite, is a simple and more practical framework used to explain how data moves across networks. It has 4 layers, which combine some of the functions found in OSI model's 7 layer. The first layer is the network access layer. This layer combines the functionality of both the physical and data link layers from the OSI model. It handles the hardware components and transmission medium, as well as defining how data is physically transmitted across the network. The second layer is the internet layer. Equivalent to the network layer of the OSI model, the internet layer is responsible for logical addressing and routing data to its destination. It defines protocols for data packet addressing and forwarding through the network. The third layer is the transport layer. Similar to the OSI transport layer, this layer manages data flow control, error checking, and ensures that the data is delivered reliably from one system to another. The primary protocols used are TCP for reliable data transmission and UDP for fast, connectionless communication. The fourth layer is the application layer. This layer combines the functionality of the session, presentation, and application layers of the OSI model. It deals with high-level protocols and services that allow users to interact with the networks. It supports processes like file transfer, email, and web browsing. While the OSI model is more of the theoretical framework, it provides a great foundation for understanding networking and data transmission. The TCP/IP model, on the other hand, is used for real-world networking, especially on the internet. Understanding the basics of networking sets the stage for appreciating how data is transmitted and protected across the internet. Now let's take up a quiz in what we have learnt earlier. And the second question is, in the TCP/IP model, which layer corresponds to the OSI model's network layer? And the options are A. Internet layer, B. Transport layer, C. Application layer, and D. Link layer. If you know the correct answer, comment below. Now let's delve into a crucial aspect of cybersecurity, that is cryptography. This practice ensures that our data remains confidential and secure by transforming it into a format that is unreadable without the correct decryption key. Cryptography is the practice of securing information by transforming it into an unreadable format. This process involves 2 key operations. First is encryption and decryption. Encryption is the process of converting plain text into ciphertext using an algorithm and a key. Decryption is a reverse process, converting ciphertext back into plain text using a key. The purpose of cryptography is to ensure the confidentiality, integrity, and authenticity of data. Now let's explore the different methods of encryption that cryptographers employ to safeguard data. First, we have the symmetric cryptography. Use the same key for both encryption and decryption. It's fast and efficient but requires secure key distribution. Example, AES, that is the Advanced Encryption Standard. Next, we have the asymmetric cryptography. Uses a pair of keys, a public key and a private key. The public key encrypts data and the private key decrypts it. This method is slower but provides a way to securely share keys. Example, the RSA. Having established the 2 main types of encryption, let's dive deeper into specific cryptographic algorithms that implement these methods. First, we have the Advanced Encryption Standard. It uses the same key for encryption and decryption. It is a symmetric block cipher algorithm with block size of 128 bits, 192 bits or 256 bits. Second, we have the Data Encryption Standard. It is used to convert 64-bit plain text data into 48-bit encrypted ciphertext. It uses symmetric keys. Third, we have the RSA. It is an asymmetric cryptographic algorithm which uses 2 different keys for encryption. This algorithm works on a block cipher concept that converts plain text into ciphertext and vice versa. The last type we have is a secure hash algorithm. It is used to generate unique fixed-length digital fingerprints of input data known as the hashes. Its variations such as SHA-2 and SHA-3 are commonly used to ensure data integrity and authenticity. Now let's take up a quiz in which we have learnt earlier. Question number 3. Which of the following is a type of symmetric encryption? And the options are A. RSA, B. AES, option C we have Diffie-Hellman, option D we have L-Gamma. If you know the correct answer, please comment below. Now that we have covered the basics of cryptography and the different types of encryption, let's dive into a practical demonstration. In this demo, we'll encrypt a sample text file, decrypt the encrypted file back to its original form, verify the integrity of the original and decrypted files. This hands-on example will help you see how these cryptographic techniques are applied in real-world scenarios to protect and verify data. Let's get started. We'll focus on symmetric encryption using the AES algorithm and verify data integrity with the SHA-256 hash function. Now let's create a sample text file. In this step, we create a simple text file that contains a message, "Hello World." This file is named as sample.txt. This step sets up the file we'll work with. Now, we will be using OpenSSL to encrypt the sample.txt file using the AES algorithm, along with the 256-bit key in cipher block chaining mode. This command invokes the OpenSSL encryption tool. Here we are specifying the AES algorithm with the 256-bit key and CBC mode. Then, we have added a random salt to strengthen the encryption by preventing attacks on reused passwords. After that, we have specified the input file, that is, the file that we have encrypting. And here we have the output file where the encrypted content will be stored. And also, we have specified a password for our encrypted file, which is Edureka. By running this, we encrypt the sample.txt file and store the result in encrypted.bin. Now let's go ahead and see what we have in our encrypted file. Here we can see that we are presented with a garbage value that's not human readable. So we'll be using the decryption method to make it readable again. This step decrypts the encrypted file back to its original form using the same password, that is Edureka. Each part of this command is similar to the encryption command with the addition of the D flag, which specifies decryption mode. And D stands for decrypt. And we have the input file that is the encrypted.bin, and the output is stored in the decrypted.txt. After running this, it decrypts the file named decrypted.txt that matches the original sample.txt file. Now let's see the content in the decrypted.txt file. This confirms that the decryption worked correctly and restored the file to its original state. In the next step, we will be generating a SHA-256 hash of the original file. In this step, we generate a SHA-256 hash for the original file to create a unique digital fingerprint. The SHA-256 sum command computes the SHA-256 hash, and the output is redirected to the original hash.txt. In the next step, we are going to calculate the SHA-256 hash of the decrypted file. This step calculates the SHA-256 hash of the decrypted file and stores it in decrypted hash.txt. This allows us to compare it with the original hash to check if both files are identical after encryption and decryption. Now let's compare the hashes of both these files. If both hashes match, it means the original and decrypted files are identical, proving that no data was altered during the encryption and decryption process. Now that we have explored how cryptography protects our data through encryption and decryption, it's time to dive into the other side of the equation, the threats and vulnerabilities that cryptography aims to defend against. While encryption can secure information, understanding the types of cyber attacks that can bypass or challenge these defenses is crucial. Let's move on to the various types of attack that pose a risk to our digital world. First we have is a malware. It is a program or code created to harm a computer, network or server. Now let's see the types of malware. First we have the ransomware. Imagine you're working on an important project and suddenly your computer locks you out. A message pops up demanding money to unlock it. That's ransomware. It encrypts your file and demands payment to restore access. Next is a spyware. This sneaky software hides your computer, watching everything you do like a spy. For example, it could record your keystrokes to steal your passwords. Moving on to adware. Have you ever seen those annoying pop-up ads? That's adware. It bombards you with ads, sometimes even redirecting your browser to malicious websites. Next we have the Trojan, like the Trojan horse from history. This malware disguises itself as something harmless. For instance, you might download a game, but it secretly installs a Trojan that lets hackers control your computer. Then we have the worms. Unlike virus, worms don't need to attach to files. They spread by themselves, often through networks. Imagine someone sends an infected email to everyone in your company, and the worm spreads to every computer. Next comes the rootkits. These are tools hackers use to hide their presence. For example, a hacker might install a rootkit to gain administrative control of your system without you knowing. Next comes a keylogger. A keylogger records every keystroke you make. It's like someone looking over your shoulder while you type your passwords or messages. Last is the botnet. A botnet is a network of infected computers controlled by a hacker. These computers are often used to launch large-scale attacks, like sending out massive amounts of spam. The next type of attack we have is a denial-of-service attack. A DOS attack is like flooding a shop with so many customers that real buyers can't get it. In cyber terms, hackers overwhelm a website with traffic, making it unavailable to users. For example, if a DOS attack hits an online store during a big sale, customers might not be able to make purchases. Next type of attack we have is phishing. Phishing is a scam email pretending to be from your bank or asking for your password. Hackers use this technique to trick you into revealing personal information. For instance, you might receive an email that looks like it's from PayPal, but it's actually a fake site designed to steal your login details. Next we have is spoofing. Spoofing is when a hacker pretends to be someone else. Imagine receiving a call from a number that looks like your bank, but it's actually a hacker trying to get your information. In emails, they might spoof the sender's address to make it look legitimate. The next type of attack we have is the code injection based, which involves inserting malicious code into a system or application to manipulate its behavior. Now let's see the different types of code injection based attacks. First we have the SQL injection. Imagine a website with a search bar. A hacker enters malicious code instead of search term, tricking the website into revealing confidential data. This is SQL injection. Then we have the cross-site scripting, that is XSS, which occurs when a hacker injects malicious scripts into a website. For example, they might post a malicious link on a forum that, when clicked, runs harmful code on your browser. The next type of attack we have is the social engineering attacks. Social engineering is all about manipulating people rather than breaking into systems. For example, a hacker might call an employee pretending to be from IT support, asking for their password to fix an issue. The next attack is the insider threat. Sometimes the threat comes from within. An insider threat that could be an employee who misuses their access to steal data or cause harm. For example, an employee with access to sensitive files might leak them to the public. The last type of attack we have is the AI-powered attack. This is like using artificial intelligence to create deceptive content such as deepfake videos to mislead or deceive. Under AI-powered attacks, we have deepfake. Deepfake uses AI to create realistic but fake videos or audio. For example, a hacker might create a deepfake video of a company CEO making a false announcement causing panic. Then we have the AI-generated social engineering. Hackers use AI to craft convincing phishing emails or messages, making them more likely to deceive people. For example, AI could generate a personalized phishing emails that look exactly like a message from your boss. Now that we have discussed the types of cyber attacks that can compromise our digital security, it's essential to understand who is behind these attacks. Not all hackers are same. Some work to protect our systems, while others seek to exploit them. Let's explore the different types of hackers and their motivations. First, we have the black hat hackers. Black hat hackers are the bad guys in the hacking world. They break into systems illegally, often to steal data, install malware, or cause harm. Imagine someone breaking into your house to steal valuables. That's what these hackers do to the computer systems. Next we have is the white hat hackers. These are good guys. They use their hacking skills to find and fix security flaws before the bad guys can exploit them. Think of them as security experts who test locks and doors to make sure your house is safe. Moving on to grey hat hackers. Grey hat hackers are somewhere in between. They might break into systems without permission, but do it to point out flaws, not cause harm. It's like someone breaking into your house to show that your lock is weak, but without asking you first. Next we have the hacktivists. Hacktivists use hacking as a form of protest or to promote a political agenda. They target organizations or governments they disagree with, often to expose information or disrupt operations. It's like someone spray painting a message on a public building to make a statement. Moving on to state-nation-sponsored hackers. These hackers work for governments and are often involved in cyber incidents, stealing sensitive information from other countries or disrupting their operations. Imagine a spy gathering secrets from another country. Last we have the script kiddies. Script kiddies are amateurs in hacking world. They don't have deep knowledge but use existing tools and scripts to carry out attacks. It's like someone with no technical skills using a lockpicking kit they bought online to break into a house. Now that we have identified the different types of hackers and their motivations, it's important to understand how organizations can defend against these threats. One of the most effective ways to do this is through penetration testing, a proactive approach that simulates cyber attacks to uncover vulnerabilities before malicious hackers can exploit them. Let's take up a quiz in what we have learned before. Question number 4. Which type of hacker is known for their malicious intent and seeks to steal sensitive information? And the options are A. Grey hat hacker, B. Black hat hacker, option C. Script kiddie, and option D. Ethical hacker. If you know the correct answer, please comment below. Now let's talk about penetration testing. Penetration testing is a security exercise in which security experts attempt to find and exploit vulnerabilities in a computer system. The purpose of this simulated attack is to identify any weak spots in a system's defenses that attackers could exploit. Penetration testing helps an organization discover vulnerabilities and flaws in their systems that they might not have otherwise be able to find. This can help stop attackers before they start, as organizations can fix these vulnerabilities once they have been identified. Now let's talk about the different types of penetration testing. First we have the open box penetration testing. It is also known as the white box testing. In this type, the tester has full knowledge of the system being tested. This includes access to architecture documents, source code, and network information. The purpose of open box penetration testing is used to simulate an insider threat or a highly knowledgeable attacker who has deep knowledge of the system. The goal is to identify vulnerabilities that may be difficult to spot without inside information. Next, we have the closed box penetration testing, which is also known as the black box testing. Here the tester has no prior knowledge of the system. The only information they have is what a real external attacker would. This means no internal details or documentation. The purpose of closed box penetration testing is to simulate an external attacker's approach, starting from scratch and attempting to gather information and exploit vulnerabilities. Next we have the covert penetration testing. In this scenario, a penetration test is carried out without the knowledge of the IT or security teams, except of the few key individuals. This is sometimes called as double-blind testing. This type of attack aims to test how well the security team responds to a real attack without a prior notice. Next, we have the external penetration testing. External penetration testing focuses on external-facing assets such as web application, servers, and firewalls, which are exposed to the public internet. The tester tries to exploit these from the outside, mimicking an attack from an external threat actor. It accesses how vulnerable an organization's public-facing infrastructure is to attack. Next, we have the internal penetration testing. In internal testing, the tester assumes the role of someone inside the network, such as a rogue employee or the attacker who has already breached the perimeter. It evaluates the security from the inside, identifying what an attacker could access if they gain entry to your internal network. Now that we understand what penetration testing is, let's break down the key phases involved in this process. The first phase is pre-engagement. This is where the scope and goals of the test is defined. The tester and the organization agree on what systems will be tested and under what condition. Next, we have the information gathering. In this step, the tester collects as much data as possible about the target system. including IP addresses, network details, and other valuable information that could help in identifying vulnerabilities. Following that, there is threat modeling. This is where the collected information is used to map potential threats and the areas most likely to be targeted by attackers. Then comes vulnerability analysis. Here the tester identifies weaknesses in the system that could be exploited, such as outdated software or poor security configurations. Once vulnerabilities are found, it's time for exploitation. The tester will attempt to exploit those weaknesses to gain unauthorized access, just like a real attacker would. After that is post-exploitation. This phase involves assessing the impact of the breach. The tester analyzes the extent of access gained and what sensitive data could be exposed or compromised. Finally, there's reporting. In the last phase, the tester documents the findings, including vulnerabilities and recommendations for improving security. But before that, we have a quiz in what we have learnt before. Question number 5. In which phase does the penetration tester attempt to exploit vulnerabilities found during the scanning phase? And the options are A. Reporting, B. Exploitation, C. Post-exploitation, and D. Reconnaissance. If you know the correct answer, please comment below.
Ethical hacking is like having a good guy test your computer or network to find and fix any weak points before bad guy can use them. It's a bit like inviting a friendly detective to check if your digital doors and windows are secure. So instead of causing harm, these ethical hackers help strengthen your online defense, making sure your information stays safe from cyber threats. This way, businesses can stay ahead of potential problems and keep their digital spaces secure and trustworthy. Having an ethical hacker ensures that your computer is safe and secure. So, what exactly is ethical hacking? Ethical hacking is a practice where experts intentionally test computer systems to find and fix security vulnerabilities. The objective is to improve cybersecurity and stop unwanted access, data breaches, and other cyber threats as compared to malicious hacking. Ethical hacking is a proactive strategy used by organizations to protect their digital assets. Maintaining a safe and powerful digital environment, safeguarding important data, and staying one step ahead of hackers all depend on ethical hacking. Now let's explore several reasons why ethical hacking is important. And the first reason is it prevents attacks. It identifies and fixes security weaknesses before a hacker can take advantage of them. Next, strengthens security. Improving overall cybersecurity helps organizations stay ahead of constantly changing cyber threats. The next reason is ensures compliance with industry standards and regularizations related to cybersecurity. And the next reason is protects information. It protects private information while gaining and maintaining the trust of stakeholders and clients. Then, manage risk proactively. It facilitates the early identification and reductions of possible cyber threats and encourages a proactive strategy for cybersecurity. Let us now discuss on the different types of ethical hackers. Basically, there are 3 types of hackers, and they are white hat hacker, black hat hacker, and grey hat hacker. So let's explore a bit deeper into these different types of ethical hackers. So the white hat hackers, also known as ethical hacker, are cybersecurity experts who conduct authorized assessments of systems, networks, and applications. Their primary goal is to identify vulnerabilities and improve security defenses. White hat hackers use their expertise to conduct penetration tests, vulnerability assessments, and security audits. They collaborate closely with organizations to identify and address vulnerabilities before malicious hackers can exploit them. Example, a white hat hacker hired by a financial institution conducts routine security assessments on online banking systems. They identify potential vulnerabilities such as flaws in the website code or configurations and work with the bank's IT team to implement security measures to safeguard customer financial information. The white hat hackers play an important role in the proactive defense against cyber threats, assisting organizations in maintaining the integrity and security of their digital assets. The next type of hacker is black hat hacker. Black hat hackers are people who engage in malicious behavior using vulnerabilities for personal gain, financial gain, or malicious intent. They operate outside the bounds of law and ethical standards. Black hat hackers may steal sensitive data, gain unauthorized access to systems, and launch cyber attacks for financial gain or use ransomware attacks to extort money from victims. For example, an advanced hacker penetrates a company's network, steals customer data, and sells it on the dark web for a profit. In addition, a black hat hacker could launch a distributed denial of service attack on a competitor's website, disrupting their online services. It is important to note that black hat hacking is both illegal and unethical. Black hat hackers' activities represent serious threats to individuals, organizations, and society as a whole. Ethical hacking, as practiced by white hat hackers, seeks to reduce these threats by identifying and addressing vulnerabilities before they are used by malicious actors. The next type of hacker is grey hat hackers. Grey hat hacker falls somewhere between ethical and potentially questionable behavior. They may discover and disclose vulnerabilities without explicit permission, raising ethical concern about responsible disclosure. Grey hat hackers may discover security faults in systems, network, or applications without authorization. While their intentions are good, their actions may not always be consistent with legal and ethical standards. Grey hat hackers discover a software weakness in a widely used application. Instead of immediately informing the company, they publicly disclose the vulnerabilities in order to draw attention to the problem and potentially put pressure on the company to address it. It's important to note that grey hat hacker can be uncertain and isn't always viewed as a responsible or ethical approach to cybersecurity. Responsible disclosure and collaboration with organizations are fundamental principles of ethical hacking practices. Next, let's have a look at the roles and responsibilities of an ethical hacker. First, permission and authorization. Prior to conducting any security testing, obtain proper authorization. Ethical hackers must obtain explicit permission from the organizations or individual in charge of the system they are testing. Next, vulnerability assessment. Determine and evaluate potential security risk in computer systems, networks, and applications. This involves looking into the system's architecture, configurations, and code to identify faults. Next, penetration testing. Penetration testing involves simulating real-world cyber attacks in order to find vulnerabilities and evaluate the effectiveness of existing security measures. This could include attempting to gain unauthorized access, increasing privileges, or manipulating the systems to find weaknesses. Next, network security testing. It evaluates the security of networks, including routers, firewalls, and other network devices to ensure they are properly configured and resistant to potential attacks. Next, application security testing evaluates the security of software applications by reviewing source code, analyzing application behavior, and identifying vulnerabilities that attacks could exploit. Next, wireless network testing. Test the security of wireless network to identify weaknesses in encryption, authentication, and access control. Next, social engineering test. Use social engineering tests to evaluate the human component of security. This may include phishing simulations in which ethical hackers attempt to trick employees into disclosing sensitive information. Moving on, let's discuss the key concepts of ethical hacking. Ethical hacking involves a set of key concepts and principles that guide the practice of security testing within ethical and legal boundaries. And here are some of the key concepts of ethical hacking. First, authorization. Before conducting any security testing, ethical hackers must obtain explicit and legal permission from the organizations or individual owning the system. Unauthorized hacking activities are illegal and can have serious consequences. Next, legal and ethical boundaries. Ethical hackers must adhere to the legal and ethical boundaries set by local laws and professional codes of conduct. They should avoid any activities that violate privacy, confidentiality, or the law. Next, informed consent. Obtain informed consent from stakeholders before conducting any security assessments. This ensures that the organizations or individual being tested is aware of and agrees to the testing activities. Next, purpose of testing. The primary goal of ethical hacking is to identify and address security vulnerabilities, weaknesses, and potential risk within a system. The goal is to improve security, not cause harm or damage. Then we have confidentiality. Ethical hackers must keep all information obtained during security testing strictly confidential. This includes information about vulnerabilities, sensitive data, and anything else relevant to the organization's security posture. Next, what skills and certifications should an ethical hacker obtain? So, the skills are networking knowledge, understanding of networking protocols, architectures, and services. This includes TCP/IP, routing, switching, firewalls, and VPNs. Next, operating system proficiency. Familiarity with various operating systems including Windows, Linux, and Unix is important. Knowledge of system administration tasks is crucial. Next, programming and scripting. Proficiency in programming languages such as Python, C, C++, or scripting languages like Bash. This is important for writing custom scripts and understanding code vulnerabilities. Then, web application knowledge. Understanding of web technologies, web application architecture, and common vulnerabilities such as SQL injection, cross-site scripting, and cross-site request forgery. Next, wireless technologies. Knowledge of wireless networking protocols and security measures, having familiarity with tools used for wireless network penetration testing is very important. Then we have cryptography. Understanding of cryptographic concepts and protocols, as well as the ability to identify and assess cryptographic vulnerabilities. Then, security tools proficiency. Experience with a variety of security tools including vulnerability scanners, network sniffers, and penetration testing frameworks. Now that we have covered the skills required to be an ethical hacker, let's look at the top cybersecurity certifications that can help you become a certified ethical hacker. About the certified ethical hacker. Start your career with the most popular ethical hacking certification in the world, that is, the Certified Ethical Hacker (CEH). This top-notch program offers structured training for aspiring cyber professionals, globally acknowledged and enabling work flexibility. Master the 5 phases of ethical hacking through a comprehensive curriculum, including hands-on experience in CyberQ labs. Also, you can choose between live online or hybrid learning options for a flexible educational journey. Check out the CEH V12 Certified Ethical Hacking course by Edureka in collaboration with EC Council and offers the chance to obtain the CEH V12 certification. This training, which focuses on fundamental cybersecurity skills, certifies knowledge of network security, cryptography, and other areas, transforming participants into certified ethical hackers prepared to tackle cybersecurity issues. The next certification is Certified Information System Security Professional. The CISSP certification is a globally recognized credential for cybersecurity professionals. It validates expertise across various security domains and requires passing an exam, showcasing a high level of competencies in cybersecurity. Check out the highly regarded CISSP certification training course in information security as well. To achieve leadership roles, upskill, and obtain this certification, Edureka offers the best training available. The CISSP certification points to a high level of managerial and technical proficiency for effectively overseeing security frameworks in businesses. The next certification is CompTIA Security Plus. The CompTIA Security Plus certification is recognized worldwide and confirms fundamental skills needed for essential security tasks and for starting a career in IT security. CompTIA Security Plus is your gateway to a cybersecurity career, equipping you with the foundational skills, assessing practical abilities for real-world challenges, and keeping you updated on the latest trends in cybersecurity technology and techniques. Edureka's collaboration with CompTIA Security Plus provides an opportunity to obtain the globally recognized CompTIA Security Plus certification training course. The training, which focuses on critical cybersecurity skills for administrators, validates knowledge of risk management, threat handling, and intrusion detection. This certification enables you to manage security incidents effectively. Now let's talk about how much an ethical hacker typically earns. In India, the average base pay varies from 24,000 rupees to 1 lakh per month, Meanwhile, the average annual salary for an ethical hacker in the United States is $134,000. Salaries for highly skilled professionals with advanced certifications and years of experience may be higher than this range.
So let's get started with the phases. So the first phase is reconnaissance. And also I'll be explaining each phase of ethical hacking with the help of an analogy, so that it's easy for beginners to understand. Suppose you're a beginner, it's the first video you're watching on ethical hacking, or maybe you've watched a little videos and you don't have a lot of understanding of what ethical hacking is, then it'll be easy for you to understand. So let's start with the first phase. Firstly, I'll tell you what this analogy is. So the analogy goes something like this. Suppose there's an enemy layer at a location, and this enemy layer has got a lot of destructive weapons, and you are the army chief who's assigned to attack the enemy layer and take control of this. So my question to you is, if you were actually an army officer, who's assigned to make a surgical strike, you've got a lot of forces, you've got the army, you've got tanks, you've got air force, all at your command. So would you just take all your forces and go attack? I don't think so. Yeah, because first you'll have to create a plan, and before that you'll have to understand the enemy layer. So you'll collect basic information such as the location of the layer, how to get to that location from the army base. You'll collect more information about the building, the number of floors, and the surroundings of the building. So similarly, when it comes to ethical hacking, you cannot just use tools or type something in your computer and just hack the target. So to hack the target, the first thing you have to do is understand the target. So this phase where you understand your target is reconnaissance. So reconnaissance is basically the phase where the ethical hacker collects information about the target so that it's easy for him to understand how to actually hack the target. So some of the basic information you would want to collect are, the first one would be the IP address of the target. Suppose you're trying to hack a particular system in a network, then you would want to know the IP address of the target, because the IP address uniquely identifies the system in the network. The next thing you would want to know is the IP address range. Suppose there's an organization with hundreds of computers and you want to hack the whole network. You don't know which computer or which system has got the lowest security. So to check that, you would need the IP address range of the whole organization or the network. The next thing you would want to know is the network. You would want to know the architecture of the network. And finally, you would want to know about the DNS records. So these are very basic things, very basic information to collect about your target. And depending on what your target is, this information might vary. So now I'll be talking about some of the most popular tools used for reconnaissance. The first tool I'm going to talk about is search engine. So I'm sure you're familiar with Google, Yahoo, and Bing. So I'll give you an example. Okay, imagine yourself in this situation where you're an ethical hacker. You're the best in the city. There's no one else who can compete your skills of ethical hacking. And one day you're at your office and this guy, a CEO of a big organization, comes to you and he hands out the name of a website and he wants you to test for security loopholes or weaknesses on his website. And he just walks away. He doesn't speak a word. He's an introvert, So at this point, you only know the name of the website. You have, no idea of what this application is or what your target is. You only know the name of your website. So what would be the first thing you do? So the first thing you would want to do is use the name of the website into a search engine. So maybe Google the name of the website. There are different search engines you can use. There's Google, there's DuckDuckGo, there's Yahoo, there's Shodan, and a lot of search engines. So you just Google search or use whatever search engine you want to and then find information about your target. So the first thing you'd get is the URL of the target, the URL of the website, using which you can find out other information such as the IP address, the IP address range, and whatever information I told about in the previous slide. So this is the first thing you would do. The next tool you would use, which is one of the most popular tools for reconnaissance, is NSLOOKUP. So NSLOOKUP is a DNS querying tool and it's mainly used to get the domain name and the IP address map of your target. So suppose there's an organization, like maybe you want to collect information about the same website, then you would run a NSLOOKUP search on that and you'd collect information such as the domain name, the IP address map, the range, the IP address range, and such information. The next tool you can use is WhoisLookup. So WhoisLookup is a browser-based query and response tool, and it's mainly used to get the registration and delegation details of your target. So suppose your target application requires a login. So maybe the username is the email ID. And using Whois lookup, you can find out who the website is registered to, the contact information, and many other information. So these information will play a vital role when you're actually trying to hack the application. So these are the most popular tools for reconnaissance. Moving forward to the next phase of ethical hacking. So the next phase is scanning. Now let's come back to the surgical strike example. You found out the location of the enemy layer. You found out the way how you can go from the army base to the enemy layer. And you've also found out about the surroundings. But is this information enough? You found the enemy layer, you found the building, but can you just go attack now? No. You need a strategy. You need a plan. And for this, the main thing you would require to know is which point of the building you can enter from. So basically you scan the whole building to see which points you can enter from and whether these points are blocked or are they open, because obviously there are enemies, they have got destructive weapons. So maybe a door is set up with a bomb, with an explosive. So you have to scan the building so that you can find a safe way to enter the building and attack. Similarly, when it comes to scanning in ethical hacking, you found out the IP address, the IP address range, and many information, but it's not enough. Now it's time to find out those points on your target which has got a weak security and where you can try to hack the target from. So this phase where you find the weak points on the target is scanning. The scanning is basically the phase where you find out points on the target system or the network from where the hacker can try to hack the target. So these are the weak points on your target that you can start the hack from. Some of the information you would want to collect during your scanning are there's active ports and active hosts. So these are basically the ports and the hosts that are live and running on the system. So there's no point if there's an organization and there's a network of 100 computers and 10 computers out of the 100 computers are turned off. There's no point in finding out information about the 10 shut down computers. If you want to hack the network, you would want to hack one of the target that's live and up and running. And that's why you would want to know about the active ports and the active hosts. Then you would want to know about the services being run on your target. So these services could be security services like firewall, intrusion detection, because obviously you wouldn't want your target to know that it's being hacked. So you'd want to be a little careful. So you'd find out services that are being run, and then you would want to collect information about the application and the operating system. So when I say a vulnerable application and operating system, it means the application or the operating system that is being used by the target, which is unpatched or outdated. So most of the time when you are scanning your target, you find out application or operating system that are unpatched, which have got security loopholes. And you can use these weaknesses to hack your target. Now let's see which are the most popular tools used for scanning. The first one is OpenVAS. OpenVAS is an open source framework with several services and tools for vulnerability scanning and management. The next tool is Nikto. Nikto is a command line vulnerability scanner, and this tool scans web servers for dangerous files, CGIs, and outdated services. So like I previously told while finding out information about the vulnerable application or operating system, that if you find outdated services or unpatched services, there's a high chance that you can find out weaknesses on your target. So Nikto is one such tool that will give you information about these outdated services. The next tool I'm going to talk about is Wireshark. Wireshark is a tool especially used for wireless networks. Suppose there's a Wi-Fi network and you want to scan this network, then you can use Wireshark. And this is an open source packet analyzer and gives a lot of information about the wireless network. The next tool and my most favorite tool is Nessus. Nessus is a very powerful tool that provides high performance data capture. And the reason I like Nessus is it provides various types of scans. So depending on what information you want about the target or what type of target is your system or the network, you can select different scans. So each scan will give you different results using which you can hack the target. So these are some of the most popular tools used for scanning. So moving on to the next phase, that is exploitation. So now you've collected enough information about your target, your plan's ready, you know where to enter the building from, you know how to attack. It's time to attack. So now you call your force, your tanks, your army, and then lead the attack and then gain control of the enemy layer. Similarly, when it comes to ethical hacking, you use different exploitation tools because your tools are like your force, like your army, and you use these exploitation tools to hack the target. So this is the phase where the hack actually happens. So exploitation is a phase where the hacker takes advantage of the weakness and loopholes found on the target system or the network and then runs appropriate tools to hack the target. So there are different steps for using exploitation. The first thing is selecting the right attack. So not every attack is applicable to every target. So depending on how your target is, depending on what weaknesses you found on the target, you will have to select the appropriate attack. Then you will have to launch the attack on your target, and finally you will gain access of your target. So some of the most popular tools used for exploitation are, the first one is Beef. Beef is a tool mainly used for penetration testing, and it's a tool that leverages browser vulnerabilities. The next tool is one of my most favorite, and this is the tool that I mostly use. It's Metasploit. It's one of the most popular exploitation tools, and this tool has got hundreds of scripts to hack. The next tool I'm going to talk about is SQL Map. SQL Map is a tool that automates detection and exploitation of SQL injection flaws. So I'm sure if you're a beginner, you don't know what SQL injection is, but stay tuned, you'll be learning about SQL injection and a lot of different hacking methods in the coming up videos. So this tool is mainly used to take over database servers. Moving on to the next phase, it is maintaining access. So now the surgical strike is done. Will you just leave from the enemy layer? No, you wouldn't. Now you would take actions to maintain, the control over the enemy layer. Because you wouldn't want your enemies to occupy the layer again and then store destructive weapons. Because if they did, if you just left and the enemies came back, you would have to carry out another surgical strike to gain control over your enemy layer. So this is maintaining access when it comes to surgical strike. So when it comes to maintaining access in ethical hacking, the hacker maintains a connection between the target so that if he wants to use a target later in time, he doesn't have to start the attack right from the scratch. He just directly accesses the target. So this phase is maintaining access. So maintaining access is a phase where the hacker installs softwares or makes changes on the target system after the target has been hacked so that he can access the target later in time directly without having to hack the target right from the scratch. So some of the ways are doing this are, there are different ways, but I've listed down some of the most efficient or the most popular ways. So the first one is installing backdoors. So backdoors are basically used to bypass login or authentication. Then the next way is creating new users. Suppose your target requires you to log in to do something on your target. Then you would create a new user with a new username and password. And later in time, when you want to access the target, you would use this username and password to log into your target. Another thing you can do is escalate the privileges. Suppose you want to run certain system commands on your target or certain system services on your target. And to run these system services, you need super user privileges. Then what you would do is make a normal user a super user and then use this user to run system services on your target. The next thing you can do is install rootkits. Rootkits are softwares used to enable access on your target. And finally, you can use Trojans. So let's see which are some of the most popular tools used for maintaining access. The first tool is Powersploit. Powersploit is a tool mainly used for Windows operating system. And this tool is used to connect to the victim's PowerShell. So if you've used the Windows operating system, you should know that a PowerShell is a place where you can run system commands from. So when you're a hacker and you hack a Windows operating system and you want to do something on that system, maybe delete the files, copy the files, or run any services, which actually you shouldn't do. You shouldn't be deleting the files or anything because you're on the track of being an ethical hacker. But I'm just telling you, for example, if you want to do any such thing, then having access to the victim's PowerShell will be really useful. The next tool I'm going to talk about is Weebly. Weebly is a PHP web shell that can be used to install stealth backdoors or to manage web accounts. And then you can use DNS to TCP. DNS to TCP is a network tool that relays TCP connections through DNS traffic. You probably don't understand a lot when I'm trying to explain about these tools, but given time when you're learning, maybe watching the next videos, I'm sure you'll understand all these topics. So for now, just know about these tools, and yeah, that's all. So let's move on to the next phase, that is covering tracks. So you're done with the surgical strike and you've got control over the enemy layer. So the main thing you would want to do is keep your strategy, your plan confidential, because you wouldn't want the enemies or any unauthorized person to know what your strategy, your plan, or any information about your surgical strike. So you erase all the details regarding this. But when it comes to ethical hacking, it's a little different. A hacker erases all the details, all the information regarding his identity, and also how he carried out the exploit, so that the target doesn't know that someone has hacked the target, first of all, and if at all he knows that his system was hacked, then he shouldn't be able to trace back who this hacker was. So covering tracks is a phase where the hacker hides his identity and also the way the exploit has happened. So he wouldn't want the target to know how he was hacked. There are different ways of doing this. Some of the most common ways are clearing the cache and cookies. Then you would want to tamper the log file. Suppose, like I told you in one of the slides, if your target requires you to log in using a username and password, and you've done that, you've logged in using a username and password, then you would want to delete these log files so that the target doesn't know that some other user had logged into his system. Then you can close the ports that you might have started or stop the services that you might have started in order to install backdoors, rootkits, or whatever purpose you did it for. So this is covering tracks, and the final phase of ethical hacking is reporting. Now you're done with the surgical strike, you've cleared all the evidence, all the clues, all the information, and now you have to inform your higher officer on what actually happened. So you would inform him how you found the layer, what was your strategy, what was your plan, what weaknesses you found on the enemy layer, and how did you actually gain control of the enemy layer. So you create a documentation of it. Similarly, when it comes to ethical hacking, instead of reporting to your higher officer, you report to the target organization. You tell them what weaknesses you found on the target, which weaknesses the target was vulnerable for, and which attacks you used to hack the target. So reporting is basically a phase where the hacker creates documentation of the weaknesses and loopholes found on the target, the way he used these weaknesses and loopholes to hack the target, and also mentions certain precautions that the target can take to make this security better. So like I told you earlier, this is the phase that differentiates a malicious hacker from an ethical hacker. I'll tell you why now, because as an ethical hacker, you know what you should do. You should tell the target organization about the information found, the way you hack the target, and also tell them how they can make the security better. But a malicious hacker wouldn't do this. A malicious hacker would hack the target, would hide his identity, and whatever purpose he hacked the target for, he just do it and vanish. So this is the phase that differentiates a malicious hacker from an ethical hacker. So these are the 6 phases of ethical hacking. So if you want to hack a target successfully and efficiently, I suggest you follow these steps. And maybe while you're practicing, you think reporting is not really that important because you have your own target, you're trying to hack it, you hack it successfully. You might think, why should I create a report for this? But let me tell you, make a habit of creating reports right from the beginning so that when you actually are working for an organization, it's pretty simple. You know what details to include and it'll be very helpful. So, don't take any of these phases lightly. Practice each phase, with dedication. Now, let me tell you about some of the great hacks that have happened over time. I made a list of 4 hacks. I know there are hundreds of great hacks that have happened, but I've made a list of 4 hacks just to give you the idea of how powerful a hacker can be. So the first hack I'm going to talk about is the FBI hack. So in 2016, the entire database of FBI was hacked and the identities of all undercover FBI and Homeland Security agents was made public, due to which a lot of lives were in danger. The next hack is the NASA hack. A hacker hacked into NASA and downloaded the source code used to run the International Space Station. And to fix this issue, NASA had to shut down its network for 3 weeks. So just imagine how powerful you'd be if you have the source code to run the International Space Station on your system. So this is how powerful you can be as a hacker. But You can only do this when you've got enough skills. Let's move on to the next hack, that is the commercial sites hack. A student of a university launched a DOS attack with 70 plus computers on 50 plus networks, which affected a lot of commercial websites such as eBay, Amazon, etc. Due to which these commercial sites face a lot of business loss. And the final hack I'm going to talk about in this session is the noble hack. So a hacker hacked into different banks around the world and then stole money from these banks, and instead of using it for his own self, he donated this money to the countries living below the poverty line. So his intention was noble, and that's why I've named this the noble hack. Though his intention was noble, what he did was illegal. And all of these hacks, the 4 hacks I spoke about, was just to give you an idea of how powerful you can be. But all of these hacks were made for illegal purpose. As an ethical hacker, you should not be involved in any such illegal activities because that's not what ethical hackers do. As an ethical hacker, you should always contribute to make the security of the system, the network, basically any digital, appliance or digital device, the security of these digital devices better.
So first, let us understand what is cyber kill chain. Well, the cyber kill chain is a concept borrowed from the military's key chain, adapted to cybersecurity by Lockheed Martin in 2011. And it's a step-by-step framework that helps organizations identify and stop cyber attacks at different stages. And this model is particularly useful for defending against advanced persistent threats, which are sophisticated attacks that involve reconnaissance, malware, social engineering, and more. The cyber kill chain is all about understanding the attacker's process so that you can detect, prevent, and respond to threats effectively. Now that we know what the cyber kill chain is, so let's break it down into 7 stages that make up this framework. Here, each stage plays a critical role in an attack. So let's take a closer look. Now, let's break down the 7 stages of the cyber kill chain and see what happens at each stage. Stage 1 is reconnaissance. Attackers gather information about the target, and this includes collecting publicly available data, scanning for vulnerabilities with tools, and identifying potential entry points. Stage 2 is weaponization. Here, attackers create malicious payloads tailored to the target's vulnerabilities, and they may develop new malware, modify existing tools to bypass defenses. Stage 3 is delivery. This is when the malicious payload reaches the target through methods like phishing emails, exploiting hardware or software vulnerabilities. Stage 4 is exploitation. The payload is activated and then the attacker exploits vulnerabilities to gain access. This often includes a lateral movement across the network. Stage 5 is installation. Here, attackers install malware or backdoors to establish persistent access. Examples include Trojan horses, command line interfaces. Stage 6 is command and control. Attackers establish a remote connection to monitor and guide their attack, and often using obfuscation techniques to evade detection. Stage 7 is actions on objectives, and this is the final stage where attackers achieve their goal, such as data theft, encrypting files for ransom, and compromising supply chains. While the cyber kill chain provides a strong foundation, it's not only the framework out there. One of the most popular comparison is with the MITRE attack framework. So, how do they stack up? So let's compare. So here, we are going to compare the cyber kill chain versus MITRE attack. The cyber kill chain is often compared to the MITRE attack framework, but there are some key differences. First, in terms of structure. The cyber kill chain has the linear structure with 7 stages, while the MITRE attack is more flexible and focuses on tactics and techniques in no specific order. Next, in terms of focus, the cyber kill chain provides a high-level overview, whereas MITRE attack examines the granular details of attack execution. Now, both are valuable, but the choice depends on your organization's need and threat landscape. As cyber threats have grown more sophisticated, the cyber kill chain has evolved to stay relevant. But what changes have been made, and how has it adapted to modern challenges? Let's explore its evolution. Since its introduction in 2011, the cyber kill chain has evolved to address modern threats. However, attackers have become more sophisticated, often skipping or combining stages. For example, file-less malware and AI-driven attacks don't always follow traditional patterns. Here, attackers exploit newer technologies like IoT, cloud computing, and cryptocurrency. This evolution has challenged defenders to adapt and integrate more dynamic frameworks like MITRE ATT&CK. Even with its strength, the cyberkill chain isn't perfect. It has some limitations that cybersecurity professionals need to consider. So what are these weaknesses and how do they impact its effectiveness? So let us see the weaknesses in cyberkill chain. While the cyberkill chain is a powerful tool, it has some limitations, such as limited detection, and it focuses heavily on malware but struggles with newer threats like fileless attacks and insider threats. Next is the rigid structure. Not all attacks follow the linear 7-stage process. Next is the emerging threats. Advanced techniques like deepfake phishing and AI-driven attacks require more flexible defenses. And to overcome these weaknesses, organizations should complement the cyberkill chain with other frameworks and advanced technologies. Despite its limitations, the cyberkill chain remains a valuable tool in the fight against cyber threats. So let's wrap things up by understanding how it contributes to strengthening cybersecurity strategies today. So here are the roles of cyberkill chain in cybersecurity. So, as I said, despite its limitation, the cyberkill chain remains an essential tool for understanding and combating cyber attacks, such as provides a clear roadmap for identifying threats, then helps organizations to design proactive defenses, and encourages a mindset of active threat hunting rather than passive defense. Moving on, let us understand what is phishing. Well, phishing is a social engineering attack where cybercriminals pretend themselves as a trustworthy entity to deceive people into revealing confidential information, such as passwords, credit card numbers, or financial details. Unlike traditional cyber attacks that exploit software vulnerabilities, phishing relies on human error, which makes it one of the most dangerous and effective cybercrime tactics. A hacker could pretend to be your bank, a well-known company, or even your boss, sending a convincing email, text, or call urging you to take immediate action. So clicking a malicious link, downloading an attachment, or simply entering your login credentials could put you at risk. So now, let's break down some common phishing techniques you need to watch out for. So first on the list, we have bulk email phishing. So imagine getting an email from your favorite online store saying your account has been compromised. Click here to secure it now. Sounds urgent, right? So this is bulk email phishing, where hackers send out thousands of emails hoping someone takes the bait. They often spoof emails to look like they are from legitimate companies, complete with logos and realistic messages. So if you click on the link, you are taken to a fake website designed to steal your credentials. So always check the sender's email and hover over the link before clicking. The next type of phishing attack is spear phishing. So unlike bulk phishing, spear phishing is highly targeted. Hackers study their victims and craft personalized messages. So let's say you're a financial manager and you receive an urgent email from CEO saying that transfer $10,000 to your new vendor immediately. Would you comply? If yes, you have just fallen for spear phishing. Hackers gather personal details from social media, LinkedIn, and company website to make their attack more believable. And when they go after high-profile individuals like CEOs, CFOs, or government officials, it's called whale phishing. Next on the list, we have business email compromise, which is BEC. So this is one of the costliest phishing attacks. Hackers take over a legitimate business email account and use it to send fake invoices or request confidential data. So Facebook and Google once lost over $100 million to a single BEC scam. So if you ever receive a suspicious email requesting funds, always verify the source through a different communication channel. Next on our list, we have smishing and wishing. Phishing isn't just limited to emails. Smishing, which is SMS phishing, and wishing, which is voice phishing, are on the rise. So if you ever receive a text from your bank saying your account will be suspended, click here to verify your details. That's smishing. Similarly, wishing attacks involve scammers called victims, often spoofing caller IDs to make it seem like they are from official sources such as the IRS or your bank or tech support. Alright, next moving on to the next type, which is social media phishing. Here, the hackers now exploit social media platforms to gain access to personal and business accounts. So they send messages like, "Hey, I lost access to my account. Can you help?" So tricking users into revealing login credentials, and if you use the same password across multiple accounts, one successful phishing attempt can lead to a chain reaction of breaches. So I hope types of phishing attacks is clear now. Now, let us move on to how to identify a phishing attack. So, how can you spot a phishing attempt before it's too late? So here are some red flags. So first, we have urgency and pressure tactics, where messages that demand immediate actions like pay now or lose access. The next is the request for sensitive information. No legitimate organization will ask for your password via email or text, so remember this. Next is the poor grammar and spelling mistakes. So many phishing emails come from international fraudsters, leading to awkward phrasing or typos. Next is the generic greetings. They might greet you like "dear customer" instead of your actual name. So this can be a major red flag. Next is the fake URLs and email addresses. So when you look closely here, this is not exactly this, right? So this is not a Microsoft.com. So always hover over the links before clicking. Alright. Now that you know how phishing works, right? So let's talk about how you can protect yourself and your organizations. So always remember to enable multi-factor authentication. So even if hackers steal your password, they can't access your account without this second authentication step. Next, verify before clicking. So if you ever receive an email about a bank issue or overdue invoices, don't click on the link. Go directly to the website yourself. Next, educate yourself and others. Well, organizations should conduct security awareness training to help employees recognize phishing attempts. Next, always make sure to use the security tools. You need to install anti-phishing filters, spam blockers, and endpoint security solutions to detect and block malicious emails. And finally, report suspicious messages. So if you receive a phishing email, report it to your IT department, or you can even use your email provider's report phishing option. So that's it. So phishing attacks are evolving every day, but awareness is your best defense. So now that you know how to identify and prevent phishing scams, and you're one step closer to keeping your data secure. Did you hear about the recent crypto heist that happened a few days back? Bybit, a leading cryptocurrency exchange, experienced the largest crypto heist in history. Hackers stole approximately $1.5 billion in digital assets by compromising Bybit's cold wallet, a secure offline storage system designed to safeguard digital assets. Once inside, the attackers swiftly transformed the stolen funds across multiple wallets and liquidated them through various platforms. Blockchain analytics firms such as Elliptic and Arkham Intelligence tracked the stolen crypto and linked the heist to North Korea's Lazarus Group, a state-sponsored collective known for orchestrating high-profile crypto thefts. This branch not only sent shockwave through the crypto industry, but also triggered a sudden rush of withdrawals from Bybit as users feared for the security of their funds. However, Bybit's CEO, Ben Chow, reassured customers via social media that all other cold wallets remain secure and confirmed that the company had secured a bridge loan from undisclosed partners to cover any potential losses. Just like this heist, there are countless other ways attackers can compromise systems or steal sensitive information. And in today's video, we will walk you through the top 10 hacking techniques that everyone should be aware of. But before we begin, make sure to subscribe to the Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, if you're aiming to boost your career in cybersecurity, make sure to check out Edureka's Certified Ethical Hacking course, CEH V13 AI, in partnership with EC Council. This comprehensive course covers 20 modules featuring 500 plus attack techniques enhanced by AI GPT tools, 221 hands-on labs, and round-the-clock support from the certified professionals. Plus, you will get access to official e-courseware and an exam voucher from EC Council, ensuring you're fully equipped to earn your globally recognized CEH certification. So enroll today and step into the ever-evolving world of cybersecurity, safeguarding the digital field and advancing your career to new heights. Now, let's dive right into and explore the top 10 hacking techniques you should know. First up on our list is phishing. Phishing involves sending fake emails or messages that appear to be from trusted sources. These messages typically contain links to counterfeit websites crafted to capture sensitive information, such as usernames, passwords, and credit card numbers. For example, you might receive an email that seems to be from your bank, asking you to verify your account details. However, clicking the link would lead you to a fraudulent site. Always verify the sender's email address, check for grammatical errors, and avoid clicking on suspicious links. Next, let's look at SQL injection. SQL injection happens when attackers insert malicious SQL code into input fields to exploit vulnerabilities in an application's database software. So these techniques can allow unauthorized access or even manipulations of databases. For example, entering something like drop table users into a login form could potentially delete an entire user table if the input isn't properly sanitized. To prevent SQL injection, always use parameterized queries, prepared statements, and thorough input validation. Moving on, we have cross-site scripting. XSS involves injecting malicious scripts into content from otherwise trusted websites. These scripts can steal cookies, session tokens, or other sensitive data from users. A common scenario is when a website allows users to post comments without proper input validation, giving attackers a chance to insert harmful scripts. Mitigate this risk by implementing robust input validation, correctly escaping data, and using content security policy headers. Our next focus is on denial of service or distributed denial of service attacks. DOS attacks aim to make a network or service unavailable by overwhelming it with a flood of illegitimate requests. In DDoS attacks, multiple compromised systems target a single system simultaneously, causing it to crash or become inaccessible to legitimate users. So protect your systems by using firewalls, rate limiting, and dedicated DOS mitigation services to filter and manage incoming traffic. Next, let's talk about man-in-the-middle attacks. In a man-in-the-middle attacks, an attacker secretly intercepts and relays messages between two parties who believe they are communicating directly. This interception allows the attackers to capture and possibly alter the information being exchanged, such as data transmitted over unsecured Wi-Fi networks. So protect against man-in-the-middle attacks by using encryption protocols like HTTPS and employing strong authentication mechanism and avoiding unsecured networks for sensitive communications. Next, let's discuss password attacks. Password attacks involves attempting to gain unauthorized access by cracking or guessing passwords. Techniques include brute force attacks, dictionary attacks, and keylogging. A brute force attack systematically tries every possible character combination until the correct password is discovered. Counter these threats by using strong, unique password for each account, enabling multi-factor authentication, and using password manager to generate and securely store complex passwords. Next on our list is social engineering. Social engineering exploits human psychological rather than technical vulnerabilities. Attackers manipulate individuals into diverging confidential information or performing actions that compromise security. Like for example, an attacker might pose as an IT support technician to trick an employee into revealing their login credentials. Prevent these attacks by educating employees on social engineering tactics, establishing strict verification protocols, and maintaining a healthy skepticism towards unsolidated requests for sensitive information. Another major threat we need to cover is ransomware. Ransomware is a type of malware that encrypts the victim's files, rendering them inaccessible until a ransom is paid to the attacker. Even if the ransom is paid, there is no guarantee that the files will be restored. A notorious example is the WannaCry attack, which encrypted files on infected computers and demanded Bitcoin payments for decryptions. To protect against ransomware, regularly back up your data, keep your software updated, and use reputable antivirus and anti-malware solutions. Moving forward, let's examine malware. Malware is any software intentionally designed to cause harm to a computer system's server or network. It includes viruses, worms, trojans, and spyware. A Trojan, for example, disguises itself as legitimate program but once executed, grants unauthorized access to your system. And to avoid malware infections, ensure your antivirus software is up to date, download software only from trusted sources, and be cautious with email attachments and links. Finally, let's talk about zero-day exploits. A zero-day exploit targets a previously unknown vulnerabilities in software or hardware, leaving developers with 0 days to fix it before attackers take advantage. Imagine an attacker discovering a flaw in a popular web browser that lets them execute arbitrary code on users' systems before a patch is issued. Stay protected by keeping all your software updated, using security tools to detect unusual behavior, and participating in bug bounty programs that help uncover vulnerabilities.
Now, what exactly is a penetration testing? Penetration testing, before that, what exactly is a requirement to have penetration testing? Now, once you're going to guys have an application, the applications, of course, can have different type of vulnerabilities. Now, what exactly is a vulnerability? Your vulnerability is a loophole. It's a bug. It's a weakness in the application that you're going to have. So your application can have different type of vulnerabilities, and your penetration testing is used just to make sure that whatever the different type of vulnerabilities that you're going to have within the given environment, those vulnerabilities can be, like remediated. So entire end goal of penetration testing is to make sure that, whatever the kind of vulnerabilities, whatever the kind of weakness that you're going to have, those vulnerabilities or those weakness can easily be, you can find it out and you can confirm that that is actually a weakness. Like, for example, guys, if I'm going to say that in your application, there is a weakness, if someone is going to try username as one, password as one, it's going to work. Now, that's a weakness that you have. As a penetration testing, what I will do is I will perform the exploitation on that weakness, where if I'm going to supply password as username as one, password as one, I will be able to perform the exploitation. So that basically happens in the case of PT, which is penetration testing, wherein whatever the weakness that you're going to have in the application, you are going to exploit that weakness out. So the entire end goal of penetration testing is to discover the vulnerabilities and to make sure that you are informing your staff that this is actually a vulnerability and what kind of complications, repercussions you can have if this vulnerability is not being remediated, and you are going to test for the security compliance. Now, talking about what are different phases of penetration testing. There are different type of phases that we are going to have for penetration testing. The first is the planning and reconnaissance. Whenever we are going to perform penetration testing, we are going to plan the phase out. Like, when you are going to gather the information about your target, you are going to plan it properly. Once that is done, then you're going to, perform a scanning and discovery, wherein you're just going to scan the environment and you're going to perform the discovery on the entire system. Once that is done, then you're going to perform exploitation. And after that, once that is done, then you're going to have risk analysis, and then you're going to ask for the suggestions. And last but not the least, you're going to have a report generation. Clear? Now moving on and understanding this phase one by one. Starting with the planning phase, guys. Like I said, in the case of planning, what you're going to do is you're going to perform information gathering. Like where you're going to perform information gathering, you will try to get information about your target, and based on that, you're going to make the attack happen. So here in this case, you're going to use different type of testing methods that you want to use, your goals to test. You're just going to get the information about your target. Once that is done, then you're going to move on in the scanning phase. You are going to perform static analysis or dynamic. In the case of static analysis, you are not going to run the application. You are going to have the source code. You are going to have internal architecture. You are going to have entire information about the environment, and based on information, you are going to perform exploitation, but you will not run the application. Dynamic is just reverse of it. In the case of dynamic, consider this like a black box testing, where in this case, you are not going to have internal information. You will have zero information about the source code, internal analysis, every information. You have a zero information on that. So here in this case, you're going to inspect the application code by running it, but you're not going to have any internal architecture details. So it's going to be completely dependable on running of the application. Now talking about execution phase. So this is very important phase where the actual damage is going to be done. And the next one you're going to have is the analysis phase, where the activities are going to be involved in this phase. And the last is basically the output phase. So the result of penetration testing are going to be compiled into the detailed report in this phase. The reporting is very important factor in this case, so that later on we can know that what kind of harm it has been done. Now moving on, talking about penetration testing types. Now, penetration testing can be of different types. There are different ways through which the penetration testing can be there. So the first is network services. So in the case of network services, like you are going to have internal application, and in the case of network services, you are going to have like the different networks and all that you're going to scan. Second is a web application where you're going to scan the web application, and once the application is going to be scanned, then you're going to have the entire result. Third is a wireless where you're going to scan the wireless components like the Bluetooth, your Wi-Fi's and all in order to find out the vulnerabilities. Next is social engineering that you're going to scan the environment to find out the weakness, and last is the client side. Now there are different type of penetration testing. So now you have a black box testing. Black box testing is a testing wherein you are not going to have any knowledge about the internal environment. You don't know the source code. You don't know the internal architecture. You have a zero information about it. So black box testing is a testing where you are going to have zero knowledge about the given environment on which you have to perform a test. Wherein in the case of white box, you are going to have complete information about the target. The source code, you're going to have every information about the target. Just white box testing is generally done by those people who are working internally in the organization. And the last one that you are going to have is a gray box. So gray box testing is testing which is going to, is a testing where you're going to have a partial knowledge. So you are not going to be like that where you have zero knowledge. It's not going to be like that you have full knowledge, but you are going to have partial knowledge. Now, moving on, different type of penetration testing like we discussed. For these different type of penetration testing that we are going to have, it requires different type of penetration testing strategies that we require. Like for example, like for wireless, we are going to have different strategies because we can't use the similar kind of strategies for all different type of application. Different application will require different use case and different strategies for that. So like if you are going to perform external penetration testing or internal, the approaches are going to be different because in the case of external, you are going to have external domain facing. In the case of internal, we are going to have this, facing in the internal way, and you can have different type of tools available for that. Like we have various tools like Nessus, which is basically a scanner which will help you to find out the vulnerabilities. Nessus, Qualys, different type of tools. For scanning, if I talk about Nmap, Zenmap is a GUI version of it. OpenSSL, which is an open source, with the help of which you can do a key generation and all. You have Wireshark, which is a packet capture tool with the help of which you can just you can capture the packet. Clear? Let me just show you one small example, guys. Small demonstration, which will give you more clarity. Now, this is basically a website wherein you can just simply generate the different type of keys. Like here in this case, let's say I'm a hacker, so I was able to see that what exactly is the key that you have generated. So here in this case, if I want to perform an encryption, so in order to perform an encryption, I'm going to use the public key. So like I'm going to enter the data which I have to encrypt. Like for example, I have to encrypt my bank account number, and this is the expiry, and this is the CVV. So I'm going to get this encrypted with the public key, and here we go, the encrypted output. Once that is done, let's say the hacker was able to eavesdrop your communication, so hacker will be able to simply put the ciphertext, and he will be able to decrypt the entire data with the key that you are going to have. And here is the original data which is being produced, which is being decrypted. So that's the way the hacker can try to, break the entire security, and he will be able to see the entire data in between, and he will be able to change any kind of data or sensitive data that you're going to have.
Now, one of the most commonly used tool for penetration testing is called Metasploit. And when we talk about Metasploit, so the reason that tool is so common is because it's one of the most advanced tools available in the market. If you want to get started with Metasploit, you can simply Google Metasploit, and you can find the tool, the Metasploit framework available. It can easily be downloaded from the platform. It's a computer security project that provides information about security vulnerabilities and aids in penetration testing. So you can just click on it, and basically it's an open source project owned by a security company called Rapid7. which basically licenses full featured versions of Metasploit software. It's a great tool if you know how to use it properly. And the skilled attacker, he can, as I mentioned earlier, he can generate payloads, shell codes, he can gain access and perform privilege escalation attacks by use of these tools. And as you can see, there are different ways you can access Metasploit. So there's something called as the arbitrage. Where did it go? I think I'm on the wrong link over here. So I don't see arbitrage over here. Basically, arbitrage it's the fantastic Java-based graphical user interface for Metasploit framework that you can use, and it's a command line way of accessing Metasploit. So if you want to use it on Windows, there's also a download option available over here. You can simply download it and make it available for yourself. If you they have some a free version as well, and if you want certain advanced features, extra features, then you can go for the Metasploit Pro and get access to those features. Now, if you want to know what these extra features are, you can simply follow the links and you can learn more about those features once you have a good understanding of cybersecurity. Now, before you move forward in this world of cybersecurity, as I had mentioned earlier as well, a minor warning to you guys that do not try performing penetration testing on any application that you feel is vulnerable or any network which are available out there. It's not allowed to do that. And there are separate softwares and applications which are created specially to experiment in order to learn these different pen testing tools. So if you want to perform a web application penetration testing or a penetration testing in general, you need to set up an environment. And for that, you can download a virtual machine. It's called the Kali Linux. It's a virtual operating system to perform penetration testing. So you can just search Kali Linux, and you can go ahead and use that. So it's spelled this way, Kali Linux. Basically, this Kali Linux, it's a virtual operating system which contains different, actually, I think so it's 600 plus tools to perform penetration testing, and 4 and 6 in cybersecurity or ethical hacking. So, like if you want to use Kali Linux, you can simply go to their link, and under downloads here also you'll find the different versions that are available for you to download. So based on your computer and your operating system, you can get the 64 or 32-bit version. And if you're using VMware or virtualization software like VirtualBox, then you have a separate image for that as well. So while Kali Linux installation process is about 7 to 8 minutes, it's not a lengthy process. But if you want to know from step 1 to the last step, it's better that you download some ISO image depending on the operating system that you're using. But if you want to just avoid all that, and if you want to just use the image, you can go ahead and download this image for a VirtualBox or a VMware as well. Again, depending on the kind of operating system that you're using. So those are, the different options that are available in order to learn these things. Of course, the detailed course talks more about cybersecurity and the various processes that you can follow. But this is just at a high level. One more thing is that we need some sort of vulnerable application or server to actually perform penetration testing. So for that, you can use something called as the Metasploitable. There is if you just Google Metasploitable, you can find that, and you can make use of that to take a look at how you can run your Metasploit tool on that particular application. So these are, some high-level concepts, some high-level things around penetration testing. This is what penetration testing is all about.
Let's begin with understanding what Nmap is. Nmap, which stands for Network Mapper, is a free and open source utility used for network discovery and security auditing. It's a tool that's popular among network administrators and security professionals because it helps them gain insight into their network structures and also security. In fact, Nmap is so powerful that it's not only useful for security auditing, but it also helps with tasks like network inventory, managing service upgrades, and monitoring the uptime of hosts and services. Now let's dive into the key uses of Nmap. First, it's widely used for network discovery, which means finding devices and hosts in a network. It also helps in security auditing by identifying vulnerabilities and weaknesses in the network. Administrators use it for things like network inventory, tracking all the devices on their network, and also for managing service upgrade schedules. Nmap is also handy for monitoring host and service uptime, ensuring that critical services are running smoothly. Moving on, let's talk about the features of Nmap. What makes Nmap so effective is that it uses a raw IP packets into unique ways to get valuable information. For example, it can tell you what hosts are available on the network, meaning which devices are actively connected. But it doesn't stop there. It also identifies what services those hosts are offering, including the details like the application name and version. Nmap can even figure out the operating systems and versions running on those devices. Additionally, it helps in detecting the type of firewalls and packet filters in the place. So, Nmap is an extremely versatile tool that provides a wealth of information about the network you're scanning. Another great feature of Nmap is its compatibility. It's not restricted to just one operating system. It works across all major platforms. Official binary packages are available for Linux, Windows, and Mac OS X. So, regardless of what you are using, you can run Nmap and take advantage of its powerful features. It's a truly cross-platform tool. Finally, let's take a look at the Nmap suite. Nmap is not just about the basic command line tool. It comes with several additional tools that make it even more powerful. One of these is Nmap, which provides a graphical user interface, making it easier for those who prefer not to use the command line. Then there's Ncat, a flexible tool for data transfer, redirection, and debugging, which is great for network tasks. Ndiff is another useful tool in the suite, which helps you compare scan results over time. And finally, Nping is used for packet generation and response analysis, allowing you to analyze how your network responds to certain packets. One of the most exciting aspects of Nmap is its variety of scanning techniques, which we call modes of operations. These modes allow Nmap to explore networks in different ways, depending on the requirements of the task or the level of stealth needed. Let's break them down now. First, we have the ping sweep. This mode is used for network discovery. Nmap sends ICMP echo requests to check which hosts on the network are alive and reachable. It's like saying, "Hey, are you there?" and waiting for a reply. Next, we have the SYN scan, which is also known as the half-open scan. This method sends SYN packets to a host and waits for a response. If the target sends back a SYNAC, it means the port is open. What makes it half-open is the connection isn't fully established, making it faster and less likely to be detected. The next is TCP Connect Scan. The TCP Connect Scan is a simpler and more direct method. It fully establishes a TCP connection with the host. This is useful when you don't have the privileges to perform a SYN scan but can be slow or more detectable. Then we have the idle scan. The idle scan is a stealthy technique that uses another machine as a decoy. This way, it hides your IP address during the scan, making it highly discreet but also more complex. Then we have the RPC scan. This mode specifically targets RPC services on the network. Nmap sends requests to identify which remote procedure call services are running and collects details about them. Next is the Windows scan. The Windows scan is tailored to identify open TCP ports on Windows machines. It uses specific TCP flag combinations to bypass traditional detection mechanisms. Then we have the bounce scan. The bounce scan exploits FTP servers that support proxy FTP connections. It uses the FTP server to scan a network, hiding your IP address in the process. This method is rarely used today but can be effective in certain scenarios. Then is the UDP scan. Unlike TCP scans, the UDP scan is used to discover open UDP ports. Since UDP doesn't require handshake like TCP, this method can be slower but is crucial for detecting services like DNS or SNMP. The next we have is the fin scan. The fin scan sends TCP packets with the fin flag, which typically signals the end of the connection. Many firewalls and systems don't log these packets, making it a stealthy approach to identify open ports. Next comes the null scan. In this mode, no flags are set in the TCP packets. This unconventional technique helps bypass some intrusion detection systems by not following standard protocols. Then we have the Xmas scan. This creatively named scan sets multiple TCP flags simultaneously, reassembling the lights of a Christmas tree. It's designed to probe and identify open ports but is less common today due to its higher detectability. Next comes the ACK scan. The ACK scan doesn't identify open ports directly, but instead checks for the presence of the firewall or filtering rules. It's more of a reconnaissance tool than a direct port scanner. Next is a version detection. Nmap can also perform service version detection, which probes ports to determine the application and version running on them. This is crucial for identifying outdated and vulnerable services. The last we have is the OS detection. With OS detection, Nmap identifies the target's operating system and its version by analyzing details in response packets. This information can guide further scanning and security assessments. With these modes, Nmap offers flexibility for various scenarios, from basic host discovery to stealthy scans and detailed service analysis. Each mode has its strengths and is suited for specific network setups or objectives. While Nmap is a powerful tool for network scanning and security auditing, there are several alternatives that offer unique features and compatibilities. Let's explore some of them. The first we have is the Nmap. Nmap is an official graphical user interface for Nmap. It provides an intuitive interface for users who prefer not to work directly with command line tools. Nmap retains all the functionalities of Nmap, making it accessible for both beginners and advanced users. The next comes the Port Spider. Port Spider is a security tool designed to scan network ranges and identify open ports. Its primary goal is to detect vulnerable services across multiple machines simultaneously, making it useful for comprehensive network assessments. The next is the MASCAN. MASCAN is renowned for its high performance capabilities, allowing it to scan vast number of IP addresses rapidly. It's optimized for asynchronous transmissions, enabling it to scan the entire IPv4 internet in a matter of minutes. However, MASCAN provides less detailed information compared to Nmap, focusing primarily on identifying open ports. The next we have is the Angry IP Scanner. Angry IP Scanner is an open source, cross-platform network scanner that is simple to use. It pings IP addresses to check if they are active and can resolve host names, determine MAC addresses, and scan ports. Its ease to use makes it a popular choice for quick network assessments. The last we have is the Fing. Fing is a mobile and desktop application that provides network scanning and device discovery. It's user-friendly and offers features like device recognition, network security assessments, and Wi-Fi troubleshooting, making it suitable for both home and professional use. Now that we have covered the theory behind Nmap, it's time to see it in action. In this section, we'll go hands-on with 3 key aspects of using Nmap. That is, installation, running scans, and applying scan filters. We'll start by demonstrating how to install Nmap on different operating systems, including Windows and Linux. The installation process is straightforward, and by the end of the segment, you'll have Nmap ready to use on your systems. First, we'll start by installing Nmap on Windows. Visit the official Nmap website at nmap.org. Then, go to Download section and select the appropriate Windows installer. We'll wait for it to get downloaded. Next, run the installer and follow the prompts to complete the installation. Now, click on I agree, tick all the checkboxes, and click on Next. Choose the destination folder that you prefer. Click on Install. Wait for it to get installed. Click on I agree again. Install. Now click on Next. Finish. Let's minimize this. Now let's again click on Next. For me, I will be unchecking the desktop icons. Click on Next. Finish. So now we have the Nmap installed on our system. Once installed, you can open Command Prompt or PowerShell and type Nmap to verify that it's working. There you go. You can see that it's successfully working. Now let's install Nmap on Linux. Open your terminal first. To install Nmap, type the following command. So now let's type sudo apt-get install Nmap. Hit enter and enter your password. Anyways, it's already pre-installed. After the installation finishes, you can verify it by typing Nmap in the terminal to see the Nmap version and usage instructions. There you go. Next, we'll move on to running scans using Nmap. Here, we'll explore how to perform basic network discovery and more advanced scans to gather detailed information about hosts and services. Before we dive into running Nmap commands, let's understand the key components that make up a scan. Nmap scans are systematic and structured, ensuring you get precise and actionable results. Here's a step-by-step breakdown. First we have is the scan type. Nmap supports various scan types like a SYN scan, UDP scan, or a full connect scan. Each type serves a different purpose and is tailored to specific scenarios. The next we have is the port number. This specifies which port you want to scan. By default, Nmap scans the most common 1000 ports, but you can customize this based on your requirements. Next is the scan timing. This determines how aggressive or stealthy your scan will be. Nmap offers timing templates ranging from very slow and stealthy scans to fast, aggressive ones. The next is the output types. Finally, you can decide how to save or view the results. Nmap supports multiple output formats, including standard output, XML, and even a greppable format for advanced processing. The last is a target IP. This is one of the most critical and mandatory piece of information. Without a target, Nmap does not know where to look. The target can be a single IP, a range of IPs, or even a host name. By understanding these elements, you'll have a complete control over your scans, tailoring them to meet your exact needs. Before getting into Nmap IP scanning, let's quickly talk about the cheat sheets available for Nmap. These cheat sheets are the great source of saving time and help you run commands efficiently. If we open a browser and type Nmap cheat sheet, in the search bar, you'll find several options. Two popular ones are Station X Nmap cheat sheet and the other one is Comparitech Nmap cheat sheet. Talking about the Station X Nmap cheat sheet, this is my go-to cheat sheet because it's interactive. It allows you to search for specific commands and copy them directly, making it super easy to use. The other one we have is a Comparitech Nmap cheat sheet. This one is available in PDF format, which is handy for offline reference. It's well organized and provides a quick overview of commonly used commands. While both are useful, I prefer the Station X cheat sheet for its simplicity and ease of navigation. These resources make learning and using Nmap much easier, so keep them in mind as we proceed. Let's start with Nmap IP scanning first. Nmap gives you multiple ways to define your targets, making it a highly flexible tool for scanning networks. Let's break it down. First, let's start with single IP. So let's type the command. This is the simplest way to target a single device by specifying its IP address. This method is great for focused scans on a specific machine. There you go. Here we have the results. Now let's see the subnet range. Here we specify an entire subnet using CIDR notation. This is ideal for scanning all devices in a network range, such as a small office network. Next, let's search for an IP range. Let's type the command for it. If you need to scan a specific range of IPs, you can use a hyphen to define the range. This is useful when you know the range of active devices you want to scan. Next, let's search for the specific IPs. Sometimes you might want to scan multiple non-sequential IPs. You can list them directly, separated by spaces. Next, let's try searching with a text file. For this, we'll open our editor So we'll enter some random IP that we want to search. Now let's save this on the desktop with the name targets.txt. Now we'll minimize this. Now let's go to our desktop directory on our terminal. Now let's enter the command. For larger or predefined target lists, you can save the IPs in a text file and use the IL flag to load them. This method is perfect for batch scanning without manually entering IPs. Next, let's search for a domain. Instead of using IP addresses, you can directly scan a domain name. Nmap will resolve the domain to its corresponding IP address and scan it. This is especially useful for web servers and hosted services. So we have the results here for edureka.co. Next, let's learn Nmap port scanning. Now that we have covered how to specify targets, let's talk about ports. Ports are crucial in understanding the services running on a host, and Nmap offers several ways to scan them based on your needs. Let's break them down with examples. First, let's start with the single port scanning. Let's type the command for it. If you're interested in a specific port, like port 80 for HTTP services, you can use the P flag, followed by port number. This is perfect for focus scans. Next, let's search for the sequential ports. This scans a range of ports sequentially, like ports 20 through 25. It's useful when you want to check multiple consecutive ports. Next, let's search for the distributed ports only. You can also scan non-sequential ports by listing them with commas. This allows you to focus on ports of interest, such as SSH, HTTP, and HTTPS. Next, let's find the specific services. Let's type the command for it. Sometimes you might want to target a specific service running on a port. Using scripts like HTTP title with the P flag focuses on identifying specific service details, such as web servers. Next, let's search for the protocol-specific ports. Nmap allows you to scan ports for specific protocols. For instance, scanning port 53 with SU flags targets UDP traffic, which is commonly used for DNS servers. Next, let's search for all the ports. If you're unsure about which port are in use, you can scan all 65,535 ports with -P flag. This provides a comprehensive view of host open ports. So if you hit enter, it will show us the status of the scan. So here you can see that the status is 39.66%. And the estimated time for the completion of the scan is 13:15. That is 1:15 p.m. We'll cancel this and move on to the next scan. Now we will scan for the top 100 ports. To save time, you can scan the most commonly used ports using the top ports option. For example, scanning the top 100 ports gives a quick snapshot of the most relevant ones. Now that we have covered how to specify targets and scan ports, let's dive into the different scan types Nmap offers. Each scan type serves a specific purpose, allowing you to choose the most appropriate method depending on your goals. Let's go through each of them. First, we will begin with a simple ping scan. Let's type the command. A ping scan is the simplest form of scanning, used to determine if a host is up or down. It doesn't scan ports but sends ICMP echo requests to see if the target responds. Next, let's move on to the SYN scan, better known as the stealth scan. The SYN scan is the most popular and stealthy scan. It sends a SYN packet to a target port and waits for a response. If the port is open, it replies with a SYN ARC. The scan doesn't complete the TCP handshake, making it stealthier and harder to detect. Next, let's talk about the TCP Connect scan. The TCP Connect scan is the most straightforward approach. It completes a TCP handshake by sending a SYN, receiving a SYN ACK, and then sending an ACK. While it's easier to detect, it's useful when a SYN scan is blocked or unavailable. Next, let's search for the UDP scan. Unlike TCP, UDP doesn't have a handshake, making it more challenging to scan. The UDP scan sends a datagram to the target port and waits for a response. If there is no response, the port is open or filtered. Next, let's do a fin scan. A fin scan sends a fin packet to the target port, which typically indicates that the sender has finished communicating. This scan can be useful to bypass certain firewalls and packet filters because it doesn't behave like a typical connection request. Next, let's search for the null scan. A null scan sends a packet with no flag set, essentially making it appear like an empty packet. This can sometimes bypass firewalls that only look for established connections but may be more likely to get blocked by modern firewalls. Next, let's perform an XMS scan. The XMS scan sends a packet with the fin, PHS and also an URG flag sets. It's called the XMS scan because the flags are set like lights on a Christmas tree. It's another stealthy scan type that can bypass certain types of filtering systems. Next, let's perform an ACK scan. An ACK scan is primarily used to map out firewall rule sets rather than identifying open ports. It sends ACK packets to the target ports and analyzes the responses to determine if the ports are filtered or not. Next, let's perform a window scan. Let's type the command for it. The window scan is similar to an ACK scan but uses the TCP window size to determine the state of the ports. It's useful for mapping firewall rules and bypassing certain filtering systems. Next, let's perform an idle scan. The idle scan is one of the stealthiest scans. It uses third-party device to send packets to the target, making it difficult to trace the scan back to the attacker. This type of scan is often used to avoid detection. Next, let's perform the remote procedure call scan. The RPC scan is specifically designed to identify services that use the remote procedure call protocol. This is useful for scanning systems running services like NFS or SMB. Next, let's perform an OS detection scan. By using the O flag, Nmap tries to identify the operating system and OS version of the target host. This scan relies on TCP IP stack fingerprinting to determine the OS based on how the target responds to various network probes. Lastly, let's do a version detection scan. A version detection scan identifies the version of the services running and open ports. This is useful for discovering vulnerabilities specific to certain software versions. Next, let's talk about scan timing in Nmap. When you run a scan, the speed and intensity of the scan can be adjusted using different timing options. Nmap offers a range of timing from T0 to T5 to help you balance speed, stealth, and accuracy. Let's break down each one. First, let's start with the T0, that is also known as a paranoid scan. Let's type the command for it. T0 is the slowest timing option and is used for extremely stealthy scans. It's designed to minimize detection by firewalls and intrusion detection systems by making the scan extremely slow. This option is great for situations where you need to be as discreet as possible, but it may take a long time to complete. Now, let's cancel this and move on to our next scan type, because this might take a longer time. The next scan we have is T1, that is also known as a sneaky scan. T1 is still slow but a bit faster than T0. It's often called a sneaky scan because it is designed to avoid detection while still being faster than a T0 scan. It's useful for reconnaissance when you need to remain hidden but don't have time for a T0 scan. Let's cancel this and move on to our next scan type. Let's see the T2 scan, that is also known as the polite scan. T2 is a polite scan. It's still slow but avoids overwhelming the target network or host with too many requests at once. This scan type is useful when you don't want to create too much traffic or disrupt the network. Similarly, we have another scan, that is a T3 scan. T3 is the default setting for Nmap and provides a good balance between speed and stealth. It's called a normal scan and it's the best option when you don't need to be overly stealthy or slow. It's a great option to most general use cases and should be used when speed and accuracy are more important than being undetected. Now let's move on to the T4 scan, that is the aggressive scan. T4 is an aggressive scan. It scans faster by sending more packets at once, which can lead to quicker results but also increase the chance of detection by firewalls and intrusion detection systems. This option is useful when you need quickly gather information and don't mind being noticed by the target machine. Lastly, let's move on to the T5 scan, which is the insane scan. T5 is the fastest and most aggressive scan. It's called an insane scan because it attempts to scan as quickly as possible, which makes it highly detectable. It sends a high volume of requests in a short time. So, while it may provide very fast results, it can also overwhelm the network and alert security systems. Use this only when you need fast results and when stealth is not a priority. Now, to summarize, here are the different timing options and their characteristics. First, we have the T0, which is very slow and stealthy. Then the T1, which is slow and sneaky. Next comes the T2, which is slow and polite. T3, which is normal and balanced as well. Then is the T4, which is fast and aggressive. The last is T5, which is very fast and insane. Now, let's take a look at the output types available in Nmap. Nmap offers several formats for saving the results of your scan, which can be useful for analysis, automation, and reporting. Let's go through each of them. First, we have is a normal text format output. Let's type the command for it. The normal text format is the default and simplest output format. It generates a human-readable report with basic information about the scan results such as open ports, services, and other details. This format is great for quick, easy-to-read reports and is the most common format used by most Nmap users. Next is the XML format output. The XML format is used when you need to process the scan results further and integrate them with other tools. It generates a structured XML file that contains all the details of the scan, including host information, open ports, and service details. This format is ideal for automation and scripting, especially when you want to parse the results with other programs. Next is the greppable format output. The greppable format is designed for easy searching and parsing using tools like grep. It outputs scan results in a simple, line-by-line text format that makes it easy to filter or search for specific data. Although it's not the most human-friendly, it's useful for quickly extracting certain details from large scan results. However, Nmap does not recommend this format for serious analysis, as it can sometimes omit important details and isn't as structured as other formats. The next is the script kiddie format output. The script kiddie format is a very basic format designed primarily for people who aren't familiar with Nmap's detailed output. It gives minimal information in a simple format, and while it's not commonly used by experienced users, it may be useful for beginners or for quick checks. However, it's not recommended for professional or detailed analysis due to its lack of depth. Finally, let's talk about the Nmap script engine. NSE is a powerful feature of Nmap that allows you to extend its functionality with custom scripts. These scripts are written in Lua and can automate a variety of tasks, helping with network discovery and security auditing. NSE scripts can be used for a range of purposes, such as firewall bypass, which helps bypass firewalls, or IDS, IPS systems to avoid detection during scans. Next is the FTP enumeration. Gathers information about FTP servers, including user accounts and shared directories. Then comes the DNS enumeration. Extracts DNS records and identifies potential misconfiguration in DNS servers. Last is the HTTP enumeration. Identifies web applications and hidden directories on HTTP servers, potentially exposing vulnerabilities. These scripts are located in the scripts directory of Nmap's installation. For example, on Parrot OS, you can find them at, type the command for it. As you can see, here we have all the scripts. The NSE scripts are incredibly useful for penetration testing and network analysis. They help automate complex tasks and provide deeper insights during security assessments.
What exactly is John the Ripper? Well, John the Ripper is an open source password security auditing and password recovery tool. It's a favorite among security professionals, ethical hackers, and penetration testers because it helps them identify weak passwords by cracking them. John the Ripper is available for multiple operating systems like Linux, Windows, and Mac OS, making it a versatile tool for different platforms. The reason it's so widely used is because it supports an enormous variety of password hashes and encryption methods. John doesn't just stop at cracking simple passwords. It's capable of cracking hundreds of hash and cipher types. Whether it's user passwords from Unix-based systems like Linux, password hashes from Windows, or encrypted files like zip and RAR archives, John the Ripper can handle it all. So let me elaborate a bit more. John the Ripper is incredibly versatile in terms of the range of tasks it can perform. It supports password hashes from web applications including WordPress, encrypted private keys such as SSH, JPG, and cryptocurrency wallets, network traffic captures like Wi-Fi, and even documents such as PDFs and Microsoft Office files. Now, before we get into the topics, let's talk about what makes John the Ripper such a popular tool in cybersecurity. So here are the key features of John the Ripper. First, the cross-platform compatibility. It works seamlessly across multiple operating systems such as Linux, Mac OS, and Windows, making it suitable for a range of environments. Next, customizable attacks. You can fine-tune the cracking process by using custom word lists and creating rules to target specific types of passwords. Next is the versatile cracking modes. John supports directory-based attacks, brute force, and even hybrid attacks, allowing you to choose the most effective approach for different scenarios. Next, the wide range of hash and cipher support. John the Ripper supports a wide range of formats, from Unix and Windows hashes to encrypted files and network traffic captures. And next, we have efficiency. John is optimized to crack passwords quickly, taking advantage of different CPU architectures to maximize performance. Now, when it comes to cybersecurity applications, John the Ripper shines in both offensive and defensive roles. Offensive security experts use John to assess the strength of passwords during penetration testing and security audits. By identifying weak passwords, they help organizations improve their security posture and enforce better password policies. On the other hand, John can also help recover forgotten passwords. If someone has lost access to a system or file, John can help crack the password and restore access. So, whether you're conducting a security audit or recovering lost credentials, John the Ripper is a critical tool in cybersecurity. Now that we have got a basic understanding of John the Ripper, so let's dive into one of the most important concepts when it comes to password cracking, that is hashing. So, what exactly is a hash? A hash is like a digital fingerprint of a piece of data like a password. So imagine you're taking a picture of a unique object with a camera. The picture or image represents that object, but it's not the object itself. You can't reverse the image to get back to the object. Similarly, a hash takes a piece of data like a password and turns into a fixed length of string of characters, and this string is the hash. Now, why do we use hashes in password storage? So in simple terms, strong plain text passwords would be a huge security risk. So if a hacker gains access to a database, they will see the passwords in their original form. But when passwords are hashed, even if somebody steals the hashed value, it's incredibly hard to reverse the process and retrieve the original password. So here's where the John the Ripper comes into play. It helps to crack these hashes, meaning it tries to guess what the original password might have been based on the hash. Now, there are several types of hashing algorithms that are used for storing passwords. So let us take a look at few of the most common ones. So here we have MD5. Once widely used, MD5 generates a 128-bit hash value. However, it is now considered insecure because it's vulnerable to collisions, and this means two different inputs can produce the same hash value. Next, SHA-256. This is the part of the SHA-2 family, which is more secure than MD5. It generates a 256-bit hash and it is used in many modern security applications, including Bitcoin wallets. Next, we have bcrypt. This is another popular hash function designed for password hashing. It's much lower than MD5 or SHA-256, which makes it more resistant to brute force attacks. So, why is cracking these hashes important for security testing? Well, when security professionals run tests on systems, they want to check how easily an attacker could crack the hashes of stolen passwords. By doing this, they can identify weaknesses in the system and suggest stronger, more secure password policies. Alright, now that we have got a good understanding of what John the Ripper is and how hashes work, so let's get started with installing it. I will show you how to set up John the Ripper in CLI mode for those who prefer working with the command line, and also in GUI mode using Johnny for those who want a user-friendly interface. So first, let's talk about installing the CLI version of John the Ripper. So if you're using Kali Linux, John the Ripper usually comes pre-installed with the system. Now, to check if it's already installed, just type John in the terminal. If it's not installed, you can easily install it by running the following command. This command will install the John the Ripper on your system. Once it's installed, you can verify it by typing apt show John or John-help in the terminal, which should give you the version of John the Ripper. Now, let's move on to the GUI mode using Johnny. So Johnny is a graphical interface for the John the Ripper that makes it easier for beginners to use. So here's how to set it up. Step 1 is open the terminal and add the repository for Johnny. So here, let us type sudo apt install Johnny. Next, step 2 is launch Johnny. So simply type Johnny in the terminal to open the graphical user interface. So this is how you can install John the Ripper in both CLI and GUI form. Now that we have installed John the Ripper and it's time to explore one of its core features, the modes it uses to crack passwords. John the Ripper supports several cracking modes, each designed for specific scenarios. So understanding these modes will help you to decide which one to use based on your objective. So let's break them down one by one. First, single mode. The single mode is the simplest and fastest cracking mode in John. This mode uses the username and other related information from the password file as potential guesses. And this mode is ideal for quick checks or when you suspect that users might have used simple password based on their username or profile data. Like for example, if a username is something like this mode might try Vinith, Chaturvedi or combinations like Vinith123. Next is the word list mode, one of the most commonly used modes. And this mode takes a predefined list of passwords like a word list and tests each one against the hash. And this is perfect if you already have a word list of common or likely passwords such as the popular rocku.txt file which is on our Kali machine. For example, imagine you're testing the strength of an MD5 hash such as this one. So using a word list, John will compare each password in the list, hash it and match it against the target hash. Next, incremental mode. The incremental mode is the most powerful and exhaustive option. This mode tries every possible combination of characters, starting with shorter ones and gradually increasing in length. So this mode is useful when you have no idea what the password might be, but keep in mind that it can be very time consuming. So let's say you have a hash for a password, but you know it's only 4 characters long. So using incremental mode, John will systematically try combinations something like this as you can see on the screen. So if the password is Q2MAT, incremental mode will eventually identify it even though it does not rely on a predefined word list. However, due to the sheer number of possible combinations, the time required increases significantly as the password length increases. Finally, we have the external mode which is highly customizable. And this mode allows you to write custom cracking rules using a built-in programming language. And this lets you to create specific patterns or sequences for password testing. Here, select this mode when the regular option does not meet your requirements and you want to customize the cracking process for a specific situation. So let's say you're testing passwords for a company and you suspect employees use a specific pattern such as the company name followed by a year. For example, password might look something like this as you can see on the screen and so on. So using external mode, you can write a rule to test variations of this pattern, increment the year or try different case combinations. something like this. John will then handle the process systematically following your custom rules. Now that we have explored the various modes in John the Ripper, let's explore them further and see how rules can enhance these modes to make password cracking even more efficient. So what are rules in John? Rules allow you to modify or enhance word lists dynamically. Instead of using a static list of passwords, John can tweak each entry in multiple ways to try different variations, such as adding numbers, changing cases, or substituting characters. And by default, John comes with pre-configured rules designed to make word list more effective. So some of these default rules include appending numbers, which adds numbers to the end of words, like changing password to password 123. Next, capitalization variants, which tries password something like this. Next, least speaks substitution, which replaces characters with common substitutions like turning password into this, as you can see on the screen. Next, moving on to customizing rules. John also allows you to set your own rules through its configuration file. You can customize these rules for particular cracking situations or to mirror the patterns you think users may use. Now, let's create a simple rule. Imagine you suspect passwords include a common suffix like 2025. So here's how you can add a rule to test this. First, log in as a super user. Next, go to John's native directory, which is cd/etc/John. Then, open John's configuration file, which is john.config using Nano editor. Now, let us search for list.rules section. So as you can see, this is the rule that we are using, and this rule appends digits to the end of each word in your word list. Next, save the file. And this is how you can add your custom rule to the configuration file. But why are rules important? Rules significantly expand the effectiveness of cracking attempts without the need for massive word lists. And they allow you to adapt to real-world password patterns such as adding birth years or common suffixes, switching between uppercase and lowercase letters, and then handling specific password policies. And with the flexibility of default and custom rules, John the Ripper becomes a powerful tool for tackling even complex passwords. Now that we have covered the basics of John the Ripper and the modes it supports, so let's start with cracking passwords using John the Ripper, focusing on the complete setup and exploitation process. Now, we will walk you through cracking passwords with different modes as well as some advanced use cases to handle more complex scenarios. Step 1. Prepare the hash file. First, we need a hash file to work with. So this file contains the encrypted passwords we are trying to crack. Like for example, so let's assume we have a hash file called hashfile.txt, which contains various password hashes. Now, you can get these hashes from different sources such as password dumps or testing environments. Step 2 is to prepare the word list file. Next, we will need a word list file, and this file is used for the word list mode, where John tries various combination of words from a list against the hash file to crack the password. For this, prepare a file called wordlist.txt, and it will contain commonly used passwords or words that are likely to be the password. Now, instead of creating our custom word list, we can use the popular rocku.txt word list that comes pre-installed on Kali Linux. This massive word list contains millions of commonly used passwords, which can significantly increase our chances of cracking a password. However, the rocku.txt file is compressed, so you will need to unzip it first. So how to unzip the rocku.txt word list? Step 1. Open your terminal in Kali Linux. In step 2, navigate to the directory where the word list is located. In step 3, unzip the rocku.txt file. And this will unzip the file and give you access to the rocku.txt word list. And once unzipped, you can now use the rocku.txt word list in your cracking attempts. Now, there are few things that we need to talk about before we begin with cracking passwords. Firstly, let's quickly examine the various hash formats that John the Ripper supports. And this is important because knowing the format of the hash you are working with is essential for effective password cracking. So John supports a wide variety of formats like MD5, SHA-1, SHA-256, NTLM, bcrypt, and many others. And to see all the supported formats, you will use the following command in our terminal. And the command is John --list equal to formats. So you will see a list of formats that John can handle, categorized by type. And this include common formats like raw MD5, bcrypt and SHA-512, as well as more specialized formats like zip and shadow. Now, we also need to discuss John the Ripper's basic syntax. So understanding the syntax will make it easier to use John effectively in different scenarios. So let's try to understand the basic syntax with an example. So the syntax is John #file.txt -- format equal to raw MD5. Well, John runs the John the Ripper program. Next, #file.txt specifies the file that contains the hashes we want to crack. Then -- format equal to raw MD5 specifies the hash format as a raw MD5, and this ensures John knows what type of hashes it's working with. Now, moving on to step 3, cracking passwords with John the Ripper. Now that we have everything set up and our basics are clear, so let's jump into the actual password cracking process. We will start with a single mode and work with the #file.txt, which currently contains just one hashed password. So if we take a look at our hashed password, so as you can see on the screen, Vinith is the username, and this is the hashed password in the MD5 format, and these are the placeholders or separators typically used to accommodate additional informations like salt or metadata. Now, to crack this password, we will use a single mode. Since we know the hash type is MD5, we will explicitly specify the format using the following command. So this is the command John --single #file.txt -- format equal to raw -MD5. Here, John, this invokes the John the Ripper. Then --single specifies that we want to use the single mode, where John will try simple password based on patterns like the username or its variations. Next, #file.txt. This is the file containing our hash entry. And next, -- format equal to raw -MD5. This explicitly tells John to treat the hash as MD5. Now, once we run this command, John will attempt to crack the password using variations of the username Vinith and other simple patterns. Now, as you can see, the password Vinith123 is successfully cracked in single mode. Now, before we move on to the word list mode, let's add a few more entries to our #file.txt to make things more interesting. So, each of these entries represent a username and an MD5 hashed password. Now, to crack this password, we will need a word list like the one we have created by the name of wordlist.txt. Okay, before that, let us save this. And now, let us open the wordlist.txt in our nano editor. So, as you can see the screen, here we have added some random passwords. Now, we will use word list mode to crack these passwords. So, let us type the command John --wordlist equal to wordlist.txt #file.txt -- format equal to raw -MD5. So here, the -- wordlist equal to wordlist.txt specifies the word list we want to use. Next, the #file.txt. This is our input file containing the hashed password. Also, followed by we have -- format equal to raw -MD5, which tells the format of the hashes in the file. So when you run the above command, you will see something like this. So here's what happening. John reads each hash from #file.txt, and then it tries every password from the wordlist.txt against each hash, and once it finds a match, it reveals the password next to the username. Now, let's see all cracked password after this session. So for that, let us type the command John --show #file.txt -- format equal to raw -MD5. Here, the --show option tells the John to output the cracked password in the readable format, showing the usernames along with the plain text passwords. So as you can see, all passwords have been successfully cracked. So before we move ahead and use incremental mode, we will modify our hashfile.txt with updated hash values for each user. And these hashes correspond to the new password that include mixed caching. Now here we have updated the hash file. And let us save this. Now, before we move ahead and use incremental mode to crack these passwords, let's quickly go over the rules we discussed earlier. And these rules are going to be super helpful here. So the key rule we will be using here is the shift toggle rule, which is one of the most common rules in the John the Ripper. And this rule applies changes like alternating the case of characters in the word list, switching lowercase to uppercase and vice versa. So we will also modify our wordlist.txt file to contain just the usernames, since we these usernames with variations like shifting the case. So these are the users' name that we have updated. Now let us save this. Now, let's use this shift toggle rule to see the possible variation of these usernames. And this rule toggles the case of each letter. So for this, let us type the command John -- rules equal to shift toggle -- word list equal to wordlist.txt -- stdout. Next, pipe more. Now here, the John, this is the command to invoke John the Ripper. Next, the -- rules equal to shift toggle. This tells John to apply the shift toggle rule while processing the word list. Followed by which we have -- word list equal to wordlist.txt. And this specifies the input word list file that contains the username that we want to process. Next, the -- stdout, this tells John to print the generated word list variation after applying the shift toggle rule to the screen instead of attempting to crack passwords. And finally, we have the pipe more. This is used to view the output one page at a time. So if you have a large number of variations, you can scroll them in a manageable way. Now, in this way, we can generate a variety of password candidates that might match the hashed password. Now, we will move on to using the incremental mode with the shift toggle rule to crack these passwords. Alright. Since we have a limited number of passwords and don't want to specify every possible variation manually, incremental mode will automatically attempt every combination of characters and words. So now let us type the command John -- rules equal to shift toggle. Next, -- word list equal to wordlist.txt, followed by hashfile.txt, then -- format equal to raw-md5. So in this command, the -- rules equal to shift toggle specifies the shift toggle rule that we are using during password generation. Next, -- word list equal to wordlist.txt tells John to use the file wordlist.txt as the source of potential passwords. Next, hashfile.txt specifies the file containing the hashes you are trying to crack. And then we also have the -- format equal to raw-md5. This indicates the type of hash used in the hashfile.txt. Now, let the cracking process run. And depending on the complexity of the password and your system's performance, this could take a while. And after the process is completed, let's try to view the passwords. So for that, let us type the command John -- show hashfile.txt -- format equal to raw-md5. As you can see, John has successfully cracked the hash passwords in our hashfile.txt file. Now, let's move on to cracking multiple files together. And this is useful when you need to crack different types of hashes such as MD5, SHA-1, etc. simultaneously. Now, before that, we will modify the wordlist.txt with the possible passwords. So as you can see the screen, these are the passwords that I have updated. Next, we're going to create 3 files which will contain the hashed passwords. Alright. Now we have created the files. Next, we're going to specify the hashed passwords like this. And we are going to do similarly for the next 2 files. Now, let's try to crack all these files together. So for this, let us type the command John -- word list equal to wordlist.txt -- format equal to raw-md5. And followed by this, we will specify the file names. Okay, so when the above command runs, John will begin cracking the hashes in these files using the specified word list. After John completes the cracking process, you can view the cracked passwords. So for this, let us type the command john -show -- format equal to raw-md5 and then followed by specify the file names. Alright, so this command will display the cracked password for each hash in the files. Now, let's move on to cracking a shadow file. But first, let's understand what a shadow file is. So the shadow file is a system file in Unix-based operating systems such as Linux that stores the password hashes for all the system accounts. So unlike the etc/password file, which is readable by all users, the etc/shadow file is only accessible by the root user to ensure security. And this file contains password hashes and other related information. So in order to crack these password hashes, John the Ripper requires a combined format of both the etc/password and etc/shadow files. However, these files are stored separately, so we need to unshadow them before we can use them with John. So now, let us follow the steps. Step 1 is to unshadow the files. So the first step is to unshadow the etc/password and etc/shadow files. And the unshadow command helps us to combine both the files into a format that John the Ripper can understand. So make sure you're logged in as a super user for this process. So let's go ahead and unshadow these files. So type unshadow/etc/password/etc/shadow. Now we will be saving these files in our desktop using the file name unshadow.txt. So this will combine the contents of both the files into a single file called unshadow.txt. But why we need to unshadow? So the reason we need to unshadow the files is that John the Ripper requires both the user information and the password hashes in a single file for cracking. So when we unshadow the files, we get a combined file where each line contains both the username and its corresponding password hash in a format John can process. So without unshadowing, the hashes from etc/shadow would be separated from the usernames in etc/password, making it impossible for John to know which hash belongs to which username. Next, moving on to step 2, adding the custom user entry. So for that, open the unshadow.txt file in a text editor and add the user entry at the end. So this is how we need to do, and then save and close the file. Now that we have the unshadow.txt file, we can use John the Ripper to start cracking the password hashes. We will use the wordlist.txt word list to crack the shadow file, and you can also use the rawq.txt word list. So for that, let us type the command john --wordlist equal to wordlist.txt -- format equal to raw-md5 unshadow.txt. So in this command, the --wordlist equal to wordlist.txt specifies the wordlist file to use for cracking. Next, the -- format equal to raw-md5. This tells John to interpret the hashes as a raw MD5 hashes. Next, the unshadow.txt. This is the input file containing the password hashes you want to crack. So once the cracking process is completed, this might take some time depending on the system performance and the complexity of the passwords, and then you can review the cracked passwords. So to review the cracked passwords, let us type john --show --format equal to raw-md5 unshadow.txt. And this method efficiently cracks hashes from shadow files on Linux system. Lastly, we are going to see how we can crack the password of a zip file using John the Ripper. First, we have a file called hashfile.txt, and it contains some hashed passwords for users. To demonstrate, we will zip this file into a password-protected archive named hashfile.zip, and the password is Edureka. But we are going to pretend we don't know that, and we will use the John the Ripper to crack it. So let us follow the steps. Step 1, let's start by protecting the file. So for that, let us type zip -- password Edureka #file.zip #file.txt. Now the file is locked and we are ready to generate its hash. Next, moving on to step 2. The next step is generating a hash that John the Ripper can understand. So for this, we will use the zip2john tool that comes with the John the Ripper. Let us type the command zip2john #file.zip, and next we will store this file in zip hash.txt. And this will extract the hash of the zip file and save it in zip hash.txt. Next, step 3. Now let's crack the password. So we will use the John the Ripper and the wordlist.txt file to do this. Type John --wordlist equal to wordlist.txt followed by zip hash.txt. So here, John will now try all possible combination from the word list to match the hash. And there you go. John has cracked the password and it says that the password for the zip file is Edureka. Now, let's take a look at the Johnny GUI, which is the graphical user interface for John the Ripper. So using Johnny is a great way to make the password cracking process more initiative, especially for those who prefer a GUI over the command line interface. So, Johnny simplifies the entire process by providing a user-friendly interface for John the Ripper. So instead of manually entering commands, you can simply point, click and run your cracking task with just a few easy steps. So let us follow the steps. In step 1, launching Johnny. So to start, open Johnny on your Kali Linux machine. You can do this by searching for Johnny in the application menu, or you can run it in the following command in the terminal. So this will open up the Johnny GUI. Next, step 2 is loading the hash file. So once Johnny is open, the first thing you will want to do is load the hash file.txt that we have been using in our demo. Now, moving on to step 3, loading the word list. Next, we need to load the wordlist.txt or rocku.txt if you are using that to start cracking the password. So click on the word list button in the interface and select the word list you want to use. And in this case, you can either use wordlist.txt or rocku.txt. Next, step 4, starting the crack. Now, we are ready to begin cracking the hashes. So click on the start button to begin the password cracking process. Well, Johnny will start running the selected cracking methods such as wordlist mode against the hashes in your hash file using the wordlist.txt or rocku.txt. And you will see the progress as Johnny tries different password combinations. If it successfully cracks any password, the result will be displayed in the interface. Step 5 is reviewing results. So once the cracking process is complete, Johnny will show you the cracked password along with the hashes to which they correspond. So you can review the result directly within the Johnny UI, making it easy to analyze the output. Now, you might be wondering which one should I use, Johnny GUI or the CLI mode of John the Ripper. So let's quickly compare the two. First, let us talk about CLI mode. The advantages include ideal for advanced users who prefer to work in a terminal, and it is more flexible with complex options and customization, and also it's faster and more efficient for bulk cracking tasks. Talking about disadvantages, it requires you to manually type out commands which might be overwhelming for beginners, and it is also less visually initiative compared to Johnny. Next, Johnny GUI mode. So let us talk about the advantages. It is great for beginners and users who prefer a visual interface, and it is easier to use with drag and drop functionality. Also, it provides a real-time view of the cracking progress. Disadvantages are slightly less flexible for advanced configuration, and it may not be fast as CLI mode for large-scale cracking tasks.
The top 10 web applications vulnerabilities are: the first one, SQL injection. SQL injection A.2 broken authentication. It's simply an insecure or inaccurate authentication method. In web application, authentication and authorization and session management are more important. So when we miss the basics, this is the very fundamental of building a web application. When we miss on to it, your application is no longer yours. Anytime it can be taken by someone else. And also the exposure of sensitive data. your server configuration file is so secure. So if it's exposed, anyone can know the configuration of a server so that we can use the misconfiguration or sensitive data, we can make use of it. So XML external entities, this is a newly added vulnerability on 2017. External XML vulnerabilities are, so what is XML? XML is a hypertext markup language which is unique. I mean, mainly this is used to structure the data in the web application. Even a JSON does the same task. XML is just to structure your data appropriately and to parse the data on a proper manner. Instead of sending the data insecure on in order or everything, there is a common standard called DTD, document type description, under which the XML, I'll show you some example of it. XSC vulnerability, and when we search for an image, similarly, this is how looks like. What external entity is XML environment? So nowadays, everyone will know that you can log into your Facebook automatically, or when you try to log in, you can use your Facebook credential or a Gmail account to log into the site. Only thing you need to click on allow access. So automatically the new site will fetch information from your Facebook account or Google account on your username, email address, and other status as well. So what exactly I does is I'll create a fake website and I'll try to get you into my website and make you to log in. I will make you register using your existing Google or Facebook web page. And actually the Facebook is more secure and Facebook will not be giving the complete information of Facebook interface or Facebook infrastructure. Instead, I'll be just including a system entry, the file, the password.xml, the password.entries, etc., wherein I will be making the Facebook retrieve data on the local information, but it will not parse to the exact user. Even the user browser will not notify it is reading the password data or reading the system configuration or reading it the information from it. But as a error message, the error message will be logged on my server where I host the fake website. On the error logs, the information what I requested will be obviously available. So this is like tricking something similar to the cross-site for forgery, and it's somewhat added newly as we integrated most of the OAuth tokens or SAML authentication. We, I mean, take advantage of these kind of open security token authentications. And again, the A5 would be the broken access control. Broken access control is simply it's not giving the permanent or right access to the right person. Sometimes if a standard user gains access to admin user account, or if admin user account were sometimes not able to perform his activity and his rights were limited. These are a few examples of it. Security misconfiguration. Security misconfiguration is obviously happening on all the environment because we need to understand any and every manufacturer of a product. It may be hardware, it may be a software, or it may be any application or any server, freeware or paid software, anything in any, it may be. It will be designed in having the mind for general public, I mean general enterprise. Once we purchase an application or we purchase an infrastructure, we need to configure, we need to alter it as per the requirement of our business and nature of our business. All the configuration, all the settings are open and freely available. So when we have the unnecessary services and unnecessary configurations open, it's obviously a way for attacker to come into your place and gain more access into it. When you install a web server, you need to install the right components, only the required components, and to provide right configuration. It likes goes to the same operating system. It goes to the web application firewall and also the network firewall. Anything and everything needs a proper configuration. A not configuring is also a misconfiguration. If you just installed everything and you did not configure username and password, anybody can log in. Even not configuring considered as a misconfiguration. So it always persists. Even from 2010 and before, still 2017, it happens. It is a lack of knowledge or lack of responsibility, or they missing the fundamentals, giving the cause for it. Again, the cross-site scripting. What is a cross-site scripting? Cross-site scripting is inputting values in username field or password field. So when I use a username and password, this is how example looks like. For example, I go to vanillaforms.org. What I do? Please take a note of this web page. This is a freely available website where you can log into This site is available for you to practice hacking. Okay, web hacking means that this is a poorly designed site. We need to find the vulnerability and identify the vulnerability, and we can test our hacking skills step by step. So I'm trying to register as a new user. So I'm just signing up. You can also sign up in the site in the meantime. Exploiting a vulnerability, for identifying a vulnerability, we do not require high stuff. I mean, we don't need some complex tools or paid professional tools. With built-in features or add-ons from Firefox and Chrome, we can easily manipulate things, and we can bypass the security of any web page. Edureka test was my username. Login. When you log into it, you will be getting basic missions, mission number 1, mission number 2. So when you keep on progress, you can go beyond to the next level. For example, I'll go to the basic level. This gives me a form. This level is called, it is for an idiot test. I mean, just to ensure that whether I'm an idiot or not, it's testing, giving me this basic simple task. I just need to enter a password to pass through to the next session. So what I would need, I need to understand the source code. What is a source code and how it was written? In Chrome and Firefox, we have an option to inspect the elements or view the source code. So by using the shortcut key Control+U, it takes you to the source code. When you need to particularly work on a particular element in a web page, anything and everything is called as an element. So if I mention this element, we inspect an element. This is called a text field. This is a button, submit button. Where is the form? Okay. So when I click on, this is the post method. When I enter the form and it goes to that. Okay, this is also tells me the first level are extremely easy. The password is here. It's mentioned on a comment. Let us try this, whether we'll be able to go on. Fortunately, I show this site. I'm not an idiot. I'm able to break into the very basic level and going on the next level. This is a scenario. Network security Sam set up a password protected script. He made it load the real password from an unencrypted file and compare to the password that enters. Okay. So Sam is creating a secure password, but he stores the username and password on an unsecure text file. So we need to identify where the unsecured text file locates. Similarly, we go for the domain. Okay. Passes to the mission basic index. This is the form it's submitting. So it obviously takes some time for us to identify where exactly any clue in the web page, where it obviously takes to. Okay. However, he neglected to upload the file. Let me try basic 1=1 combination. Error message. So why don't I try a blank password? The simple basic mistakes. I mean, it's just an example. When application owner does not upload the exact document, what happens is it's easy for anyone, because initially we'll be trying the level, what is the password and how was the mechanism works on it, where the actually password is getting fetched. But in this scenario, the actual person does not upload it. Just for us to think something, well, let's go on for a third thing. This time network security Sam remembered to upload the file, but there were deeper problem in that. Okay, somehow the site creator uploaded a file, the password file, which is obviously stored on the same location or some other location. We need to identify. Let me go to the source and also go for the inspection of what exactly it goes to. Okay, right now in previous value, it goes to your password.php. Okay. Obviously, we will not be getting anything as password.php, but at least some clue in it. Okay, let me try accessing it. Oh, perfect. When I tried password.php to try opening as a source code, I get some code here. What is this? Shall I try it? So this is how pathetic few websites would be. I'm not a genius enough to break into the site. I just used logic. When I check into the inspect object, it went to your password.php, something which is new. When I tried to open it, it gave me the password. So we do not expect all the sites would be extremely easy enough or extremely breakable, but sometimes logically thinking on it. For fourth example, this time Sam hard coded the password into a script. However, the password is no longer complex and Sam is often forgetful. So he wrote a script that would email him password to his okay. So this time what happens is usually password was written. I mean, we can enter an email to retrieve the password. Let us check how it works. Let me inspect. He wrote a script. This is a clue. Let us find what was it. What he does, I think the script is not embedded here, but I do see a value sam@hackthisite.com. What is the application logic is, it's simple example, Sam wrote a script. Whenever he forgets password, he clicks on the send password to Sam. It triggers an email. So in the input field, a hidden value field, I found an email address named Sam. This is the email address which I got from this. Any element on a web application can be modified during runtime, real time. Every element, text box, the submit button, input field, everything and anything on a web page or web application element can be manipulated. I'll try a dummy mail first. Okay, I modified the value to dummy@dummy.com. I'm sending the email. The password reminder successfully sent to. Okay, if this is not your email address, then it will not be successfully sent. Perfect. So we have one more way. We try that. So I can understand the logic that a script can verify whether it's Sam or not. So initially it might also verify whether Sam or not. Let me try one more thing. I'm using a comma because usually there is a option or feature available. We can add a comma separating multiple email addresses and send. So let me try to trick this application sometime. So let me get in my email address and try whether it's now working or not. Simc. Okay, let me check whether I'm receiving it or not. I got the password. Simple. Let me log into my Gmail account. This is an email from Sam. So this is the password I received from him. 986. Let me type. So I received the password as 986120079. So when I submit, what happens? That's so simple. So this is how easy for us to bypass the basic authentication. So it's easy for us. You can use this site, hackthisite.com, to learn. Attack vector 8 is insecure decentralized serialization. So it is also similar to the misconfiguration, etc. Due to this, it is multiple vectors, multiple possibilities of getting remote code execution. What is remote code execution? Attacker running a script or running a code or running a system function on your web server, which performs regular tasks, but which is not intended for the web service or web application. And the particular task will give some gain or profit or any good things to the user. Using components with known vulnerabilities. This is also one more important thing. Whenever we install a software, whenever we install applications, even Microsoft Windows or Mac operating system are not. WorldDB is one such site we go for. Then NIST vulnerability database. So you can go for multiple sites. There are even the NIST is so trusted, so you can search for it. You can search for the product wise. What we call Apple. Okay, search. So when we search for Apple components, we get multiple CVE. CVE stands for Common Vulnerabilities and Exploits, following by a number, CVE number. It's 2018 and it was released, and this was the vulnerability ID 3214. You can see the scoring. It's 5.3 medium, 5.0 medium. CVSS stands for Common Vulnerability Scoring System. So you can try researching for any known vulnerabilities and try to avoid the vulnerable components in developing your applications. So these are the top 10 vulnerabilities available on OWASP top 10.
So let's start by understanding SSRF or server-side request forgery. SSRF is a security flaw that occurs when an attacker manipulates a web application or API to request internal resources. These internal resources could include sensitive data, private systems, or even services that are not meant to be accessible externally. And by exploiting these vulnerabilities, Attackers can gain unauthorized access, expose sensitive data, compromise systems, and even execute malicious code remotely. Now that we know what SSRF is, let's dive into how this vulnerability works. Imagine a web application that allows users to import data from a URL, publish data to a URL, or fetch data from a remote resource. But what if the application doesn't validate or sanitize the user-provided URLs? So the application becomes vulnerable to an SSRF attack. So here's how it works. The attacker finds an input field, form, or parameter in the application where they can specify a URL. And instead of providing a legitimate URL, the attacker crafts a malicious one. So this URL could point to internal systems, private APIs, or even metadata services in cloud environments. For example, a common target is the metadata service in cloud servers, which can be accessed via this. Then these services often store sensitive information such as configuration details or authentication keys. The server, trusting the user's input, processes this malicious URL, and it makes a server-side request to a specified resource, unknowingly carrying out the attacker's commands. So through this manipulation, an attacker can access sensitive internal resources such as private database or REST APIs. Next, exploit resources that assume all requests from the server are trustworthy. Then, scan internal systems to identify weaknesses or open ports. Then extract sensitive data and exfiltrate it to an external location they control. SSRF has become so prominent that it is listed among the OWASP's top 10 vulnerabilities, a widely recognized list of the most critical web application security risks. This highlights just how severe and common SSRF attacks are. Now that we understand how SSRF works, let's explore the real-world impacts these attacks can have on organizations and their systems. A successful SSRF attack can have far-reaching consequences. First, here we have unauthorized access. Attackers can gain access to sensitive configuration such as server files, cloud metadata, or even open ports. For example, they might extract credentials or manipulate configurations to further exploit the system. Next, internal port scanning. With SSRF, attackers can perform internal network scans, identifying weak or unprotected services. This reconnaissance helps them plan more advanced attacks. Next, exploit chaining. SSRF vulnerabilities are often a stepping stone to more severe exploits, like remote code execution or reflected XSS attacks. This means a simple SSRF vulnerability can lead to a complete system compromise. And then we have malicious onward attacks. Attackers can exploit SSRF to launch malicious requests to external systems. These requests appear to originate from the victim organization, leading to reputational damage. Now, let's talk about a real-world examples of the devastating impact SSRF can have. In early 2024, a critical SSRF vulnerability, CVE 2024-21893, in Ivanti Connect Secure and Policy Secure products was massively exploited. This flaw allowed attackers to bypass authentication and access restricted resources. And if we talk about its impact, over 170 unique IPs were used for attacks aiming to establish reverse shells and extract sensitive data. Threat actors chained this vulnerability with others, achieving unauthenticated remote code execution. And over 28,000 Ivanti devices were identified as exploited across 145 countries, with hundreds confirmed compromised. Organizations including the European Union issued urgent advices to mitigate the risk. So this incident highlights the massive risk SSRF poses, especially in today's interconnected systems and cloud environments. So now that we have explored the impact of SSRF attacks, let's see their different types. Understanding these categories will help you grasp the various ways attackers exploit this vulnerability. So here are the types of SSRF attacks. SSRF can manifest in different ways, depending on what the attacker is targeting. So we will explore three primary types. First, attacks targeting the server itself. Next, cross-site port attacks. And finally, metadata exploitation in AWS, Azure, and Oracle cloud environments. First, we will talk about SSRF attacks where the server itself becomes the target. So accessing restricted URLs. So imagine a web application that lets user load content from a URL. Now, if there is no proper validation, an attacker could change the URL to something internal like this. Okay, so this could expose sensitive data or admin panels. Next, reading files on the server. So sometimes attackers use SSRF to access local files on the server. For example, they could craft a request to something like this. This might give them a list of system users, which is a valuable first step in hacking. Then, using uncommon protocols. SSRF can also abuse less common protocols like FTP or Gopher. For example, an attacker could send emails or interact with internal APIs using payloads like this. Next, let's examine cross-site port attacks or XSPA. So in this type of attack, SSRF scans open ports or services inside a network. So first we have scanning ports. An attacker could make the server check if the ports are open on the network, such as this. Next we have probing private IPs. They might even scan private IP range like this. Here, as you can see on the screen. So this helps them map out the network and find services to target. Finally, we have exploitations of cloud metadata endpoints. This endpoint stores sensitive information like access keys, configurations, and instance details. Now, let's see how this works for AWS Cloud. In AWS, there is a special endpoint that stores metadata. It's always available at this. So if attackers exploit SSRF to hit this endpoint, they can extract instance details like the server's host name or IP address. Also, IAM role credentials, which can look like this. So with these credentials, attackers might access AWS services or steal data. Now that we have explored different types of SSRF attacks, let's take it a step further and examine blind SSRF vulnerability, which is a bit more challenging but equally fascinating. So now we will explore blind SSRF and its potential impact and how attackers find and exploit these vulnerabilities. Plus, we will talk about some advanced techniques used to elevate blind SSRF attacks. So let's get into it. So first, what is blind SSRF? Blind SSRF occurs when a server processes a backend HTTP request based on an attacker's URL, but the response isn't visible to the attackers in the front end. So you can make the server send requests to other systems but can't directly see the result. Now, let's talk about the impact. At the first glance, the impact of blind SSRF might seem lower compared to regular SSRF because you can't directly retrieve sensitive data. However, it's still dangerous because attackers can probe internal systems or hidden applications, and they might uncover vulnerabilities like shell shock or exploit servers that haven't been patched. And in external cases, they could even achieve remote code execution, gaining complete control over the server. While it's not always as direct, blind SSRF still poses a serious risk. So now comes the interesting part. How to find and exploit blind SSRF vulnerabilities. So first is using out-of-brand techniques. The most effective way to detect blind SSRF is by using out-of-brand techniques, also known as OAST. And here's how it works. You can create unique domain name that point to a system you control. Next, send these domain names in your payloads to the vulnerable application. And if the application is vulnerable, it will make an HTTP request to your domain and you will detect that interaction. So this way, even though the server's response isn't visible to you, you can confirm its behavior indirectly. Next is using Burp Collaborator. The easiest tool for performing OAST testing is Burp Collaborator. And here's how you can use it. First, generate a unique domain name in Burp Collaborator. Then, inject this domain name into your payload and send it to the application. Next, monitor for interactions like DNS, lookups, or HTTP requests from the application to your domain. So if you detect any interaction, then congratulations, you have found a blind SSRF vulnerability. Now that we have explored blind SSRF vulnerabilities and their potential impact, let's talk about the techniques to prevent SSRF attacks effectively. Preventing SSRF attacks require a multi-layered approach. since attackers can use creative ways to bypass simple defenses. And here are some of the best practices to mitigate SSRF risk. First, we have avoid blacklist and use whitelist instead. So blacklist rely on blocking specific inputs, but attackers can easily bypass them using wildcard DNS services, HTTP redirects, or alternate IP encodings. While whitelist only allows access to trusted IP addresses or DNS names that the application needs. So this limits the scope of potentially malicious requests. Next preventing attack is validate and sanitize user input. So ensure that the user provided URLs are thoroughly validated. Also, reject requests to private IP addresses or disallowed domains. The next way to prevent attack is by handling server responses carefully. Never forward raw response bodies received from server-initiated requests directly to the client. Instead, filter the responses and only rely expected data to prevent leaking sensitive server information to attackers. Next, restrict URL schemas. Allow only the necessary URL schemas such as HTTP and HTTPS. Then, unused schemas like file, gopher or dictionary to block attackers from exploiting these protocols. Next, secure internal services. Many internal services, for example, Redis, MongoDB, or Elasticsearch, don't require authentication by default. Enforce authentication for all services, even those operating within local networks. Next, monitor and log requests. Implement logging for outgoing requests initiated by the server. Analyze logs regularly to identify abnormal patterns that might indicate SSRF attempts. Next, leverage security tools and frameworks. Use web application firewalls or SSRF detection plugins to detect and block potential attacks in real time. And by combining these measures, you can significantly reduce the chances of SSRF vulnerabilities being exploited, making your applications more resilient against potential threats.
Let's start by understanding where we are right now. Cyber criminals are no longer just using basic malware or simple phishing scams. Today's threat landscape includes ransomware, DDoS attacks, and data breaching targeting everyone, from global enterprises to small businesses. Traditional defenses like firewalls and antivirus software still play a role, but they struggle to keep up with the pace of emerging threats. This is where AI steps in, offering speed, scalability, and precision. AI can analyze massive amounts of data in real time, detect anomalies, and even predict potential attacks before they occur. But there's another side where attackers are also leveraging AI to create smarter, more adaptive threats. As you can see, the cybersecurity world is evolving at an incredible pace. This is exactly where AI steps in to reshape the way we defend against threats. Let's explore how. AI is a game changer in cybersecurity for several reasons. First is scalability. Imagine a system that processes billions of data points in seconds. AI does just that, making it ideal for large networks. Then is the behavioral analytics. AI can flag unusual behavior, like a sudden change in login locations, and act instantly. Then, predictive capabilities. By analyzing patterns, AI can spot vulnerabilities and help businesses fix them before they are exploited. Then is the automation. From responding to low-level alerts to applying patches, AI automates repetitive tasks, saving IT teams time. Last is reducing human error. Mistakes like clicking on phishing emails or forgetting updates are common. AI minimizes such risks by being immune to human flaws. But let's not forget that AI isn't perfect. It works best when paired with human oversight and expertise. Now that we know what makes AI so powerful, let's focus on one of its most exciting applications: real-time threat detection. Here's AI's standout capability. Real-time threat detection. Unlike traditional methods that rely on known malware signatures, AI uses behavioral analysis. For example, first is phishing detection. AI scans email content and flags suspicious links or attachments. Then is the intrusion detection. It monitors network traffic and spots anomalies like unusual spikes in data transfer. Last is the endpoint security. AI can isolate compromised devices before malware spreads across the network. This kind of proactive detection keeps organizations safer and faster in their response. Identifying threats is just the first step. What happens next is where AI truly shines. Automating responses to minimize damage and improve security. Time is everything in cybersecurity. A delay in response can lead to massive losses. AI solves this by automating responses. It can isolate infected devices, automatically apply patches, and also encrypt sensitive data at the first sign of danger. These swift actions reduce damage and give IT teams more room to handle complex issues. While these advancements are exciting, we can't ignore the challenges and risks that come with relying on AI. Let's take a closer look. As promising as AI is, it comes with its challenges. Firstly, AI-powered attacks. Cybercriminals now use AI to create malware that evolves, making it harder to detect. Then, data dependency. AI models rely on quality data. Poor data can lead to false positives. Next, over-reliance on data. Humans still provide the intuition and strategy AI lacks. Last is the cost and expertise. For smaller businesses, AI solutions may seem expensive and hard to implement. While AI is powerful, it's not a silver bullet. A balanced approach combining AI with human intelligence is key. Speaking of risks, there's also a darker side to AI when it's weaponized by cybercriminals. Let me show you how this works. The same tools we use to defend can also be weaponized. For instance, deepfake attacks. Imagine an AI-generated video of your CEO instructing a fraudulent money transfer. Then, adaptive malware. Malware that changes its behavior to avoid detection. Last is the automated phishing. AI can create highly personalized phishing emails, fooling even the most cautious users. This makes staying ahead of attackers more challenging than ever. It's clear that AI can both defend and attack. So, how do we prepare for a future where AI is a key player on both sides? Let's discuss. The future is AI-driven, and preparations is critical. So start with investing in AI tools. Organizations must adopt AI-powered security solutions. Then upskill IT teams. Continuous learning about AI trends ensures effective collaboration between humans and machines. Lastly, collaborate with better defense. Businesses, governments, and security experts must work together to establish best practices. By embracing AI responsibly, businesses can secure themselves against ever-evolving threats. So, what do we conclude from this? AI is transforming cybersecurity, boosting threat detection and response. While it brings its challenges, combining AI with human expertise, ensuring stronger defenses against evolving cyber threats.
Now, let us understand what's the importance of AI in ethical hacking. Ethical hacking is all about finding vulnerabilities before the attackers do. But in today's digital landscape, the threat volume is staggering. So traditional manual methods can sometimes miss subtle and emerging threats. So this is where the AI comes into play. Rather than replacing human expertise, AI is here to amplify our capabilities. With machine learning and deep learning, AI can analyze massive amounts of data, quickly spot anomalies, and even predict potential attackers before they occur. So imagine having a digital assistant that never sleeps and continuously monitors your network for suspicious patterns. That's the power of AI in ethical hacking. With its significance clear, let's dive into the innovative AI-driven tools and techniques that empower our defenses. And the first tool on the list is Sentinel AI by Darktrace. This tool uses unsupervised machine learning to detect real-time anomalies in network traffic. It can flag zero-day exploits even before signatures are available. Next on the list is Pentera automated pen testing. Pentera mimics real hacker behavior to scan for vulnerabilities automatically. It's like having a virtual penetration tester that works 24/7. Next is the IBM QRadar Advisor with Watson. This tool leverages natural language processing to help parse threat intelligence reports and suggest precise remediation steps during incidents. Next, we have is CrowdStrike Falcon, an AI-powered platform that provides endpoint protection by detecting and preventing malware, ransomware, and advanced persistent threats. It offers real-time monitoring, behavior analysis, and incident response capabilities, making it ideal for enterprise environments. Next is the Silence Protect. Utilizes AI and machine learning algorithms to prevent cyber attacks, including malware and ransomware. By analyzing files and behaviors before execution, it blocks malicious activity before it affects systems. Next is the platforms like HackerOne AI and Cynet 360 Auto XDR. These tools enhance bug bounty programs and offer integrated security solutions for smaller teams. Each of these tools automates parts of the vulnerability assessment process, reducing the time it takes to detect and respond to threats, so thereby significantly boosting the efficiency and accuracy of ethical hacking. Now, having examined these cutting-edge solutions, let's see how they translate into real-world success stories. So consider the example of a fintech startup that was struggling with traditional vulnerability scans, which took days to pinpoint issues. And by integrating AI-driven penetration tools, the startup was able to uncover a critical SQL injection flow in just a few hours, saving them both time and millions of dollars. So this isn't an isolated case. Industries worldwide are embracing AI to strengthen their security. From large-scale events like Microsoft's Zero-Day Quest, which incentivizes AI-focused vulnerability research, to smaller enterprises deploying AI-enhanced defenses. The trend is clear. AI is becoming a game changer in ethical hacking. After seeing tangible results in action, it's time to address the ethical considerations and challenges associated with leveraging AI. While AI tools dramatically enhances our ability to detect and respond to threats, they can also be exploited by malicious attackers if they fall into the wrong hands. This dual-use dilemma calls for strong ethical frameworks and regulatory oversight. As ethical hackers, we must ensure that these tools are used responsibly, with continuous human oversight and rigorous training. Now, looking ahead, the future of ethical hacking is both exciting and challenging. Emerging trends include AI red teams, autonomous systems that simulate advanced persistent threats to test your security posture. Next is the zero trust security models, ensuring no one inside or outside your network is trusted by default. Next, integrations with cloud and IoT security. As more services move online, AI will be key to monitoring complex multi-cloud environments and IoT devices. Next, quantum-resistant encryption. Preparing for a future where quantum computing might challenge current encryption standards. This innovation undergoes the need for a proactive and forward-thinking approach to cybersecurity. As we continue to harness AI, staying ahead of the curve with continuous learning and adaptation will be critical.
So now let's jump in. Now, cyber attacks are taking place all the time. Even as we speak, the security of some organization, big or small, is being compromised. For example, if you visit this site out here that is ThreatCloud, you can actually view all the cyber attacks that are actually happening right now. Let me just give you a quick demonstration of how that looks like. Okay, so as you guys can see out here, these are all the places that are being compromised right now. The red parts actually show us the part that is being compromised, and the yellow places actually show us from where it's being compromised from. Okay, as you guys can see now that someone from the Netherlands is actually attacking this place and someone from USA was attacking Mexico. It's a pretty interesting site and actually gives you a scale of how many cyber attacks are actually happening all the time in the world. Okay, now getting back, I think looking at all these types of cyber attacks, it's only necessary that we educate ourselves about all the types of cyber threats that we have. So these are the 8 cyber threats that we're going to be discussing today. Firstly, we're going to start with malware. So malware is an all-encompassing term for a variety of cyber attacks, including Trojans, viruses, and worms. Malware is simply defined as code with malicious intent that typically steals data or destroys something on the computer. The way malware goes about doing its damage can be helpful in categorizing what kind of malware you're dealing with. So let's discuss it. So first of all, viruses. Like their biological namesakes, viruses attach themselves to clean files and infect other clean files, and they can spread uncontrollably, damaging a system's core functionality and deleting or corrupting files. They usually appear as executable files that you might have downloaded from the internet. Then there are also Trojans. Now, this kind of malware disguises itself as legitimate software or is included in legitimate software that can be tampered with. It tends to act discreetly and creates backdoors in your security to let other malwares in. Then we have worms. Worms infect entire networks of devices, either local or across the internet, by using the network's interfaces. It uses each consecutive infected machine to infect more. And then we have botnets and such, where botnets are networks of infected computers that are made to work together under the controller of an attacker. So basically, you can encounter malware if you have some OS vulnerabilities, or if you download some illegitimate software from somewhere, or you have some other email attachment that was compromised with. Okay, so how exactly do you remove malware, or how exactly do you fight against it? Well, each form of malware has its own way of infecting and damaging computers and data, and so each one requires a different malware removal method. The best way to prevent malware is to avoid clicking on links or downloading attachments from unknown senders, and this is sometimes done by deploying a robust and updated firewall, which prevents the transfer of large data files over the network in a hope to weed out attachments that may contain malware. It's also important to make sure your computer's operating system, whether it be Windows, Mac OS, Linux, uses the most up-to-date security updates. And software programmers update programs frequently to address any holes or weak points. And it's important to install all these updates as well as to decrease your own system weaknesses. So next up on our list of cyber threats, we have phishing. So what exactly is phishing? Well, often posing as a request for data from a trusted third party, phishing attacks are sent via email and ask users to click on a link and enter their personal data. Phishing emails have gotten much more sophisticated in recent years and making it difficult for some people to discern a legitimate request for information from a false one. Now, phishing emails often fall into the same category as spam, but are way more harmful than just a simple ad. So, how exactly does phishing work? Well, most people associate phishing with email messages that spoof or mimic bank, credit card companies, or other businesses like Amazon, eBay, and Facebook. These messages look authentic and attempt to get victims to reveal their personal information. But email messages are only one small piece of a phishing scam. From beginning to end, the process involves 5 steps. The first step is planning. The phisher must decide which business to target and determine how to get email addresses for the customers of that business. Then they must go through the setup phase. Once they know which business to spoof and who their victims are, phishers create methods for delivering the messages and collecting the data. Then they have to execute the attack, and this is the step most people are familiar with. That is, the phisher sends a phony message that appears to be from a reputable source. After that, the phisher records the information the victims enter into the web page or pop-up windows. And in the last step, which is basically identity theft and fraud, the phishers use the information they've gathered to make illegal purchases or otherwise commit fraud. And as many as a fourth of the victims never fully recover. So how exactly can you be actually preventing yourself from getting phished? Well, the only thing that you can do is being aware of how phishing emails actually work. So first of all, a phishing email has some very specific properties. So firstly, you will have something like a very generalized way of addressing someone, like dear client. Then your message will not be actually from a very reputable source. So out here, as you can see, it's written as Amazon on the label, but if you actually inspect the email address that it came from, it's from management@maisoncanada.ca, which is not exactly a legitimate Amazon address. Third, you can actually hover over the redirect links and see where they actually redirect you to. Now, this redirects me to www.fakeamazon.com, as you can see out here. So basically, you know this is actually a phishing email, and you should actually report this email to your administrators or anybody else that you think is supposed to be concerned with this. Also, let me give you guys a quick demonstration on how phishing actually works from the perspective of an attacker. So first of all, I have actually created a phishing website for harvesting Facebook credentials. I simply just took the source code of the Facebook login page and pasted it, and then made a backend code in PHP, which makes a log file of all the Facebook passwords that get actually entered onto the phishing page. Now, I've also sent myself an email as to make sure this looks legitimate, but this is only for spreading awareness, so please don't use this method for actually harvesting credentials. That's actually a very illegal thing to do. So let's get started. First of all, you'll go to your email and see that you'll get some email saying your Facebook credentials have been compromised. So when you open it, it looks pretty legit, Well, I haven't made it look all that legit. It should look legit, but the point out here is to actually make you aware of how this works. So as you guys can see, it says, "Dear client, we have strong reasons to believe that your credentials may have been compromised and might have been used by someone else. We have locked your Facebook account. Please click here to unlock. Sincerely, Facebook Associate Team." So if we actually click here, we are actually redirected to a nice looking Facebook page, which is exactly how Facebook looks like when you're logging in. Now, suppose I were to actually log into my Facebook account, which I won't, I'll just use some random ID, like this is an email @gmail.com, and let's put password as admin123, and we click login. Now, since my Facebook is actually already logged in, it'll just redirect to facebook.com, and you might just see me logged in. But on a normal computer, it'll just redirect you to www.facebook.com, which should just show this site again. Okay, so once I click login out here, all that the backend code that I've written in PHP out here will do is that it's gonna take all the parameters that I've entered into this website, that is my email address and the password, and just generate a log file about it. So let's just hit login and see what happens. So as you guys can see, I've been redirected to the original Facebook page that is not meant for phishing. And on my system out here, I have a log file, and this log file will show exactly, as you can see, I've fished out the email address. This is an email @gmail.com, and it's also showed the password, that is admin123. So this is how exactly phishing works. You enter an email address, and you're entering the email address on a phishing website, and then it just redirects you to the original site. But by this time, you've already compromised your credentials. So always be careful when dealing with such emails. So now jumping back to our session, the next type of cyber attacks we're going to discuss is password attacks. So an attempt to obtain or decrypt a user's password for illegal use is exactly what a password attack is. Hackers can use cracking programs, dictionary attacks, and password sniffers in password attacks. Password cracking refers to various measures used to discover computer passwords. This is usually accomplished by recovering passwords from data stored in or transported from a computer system. Password cracking is done by either repeatedly guessing the password, usually through a computer algorithm in which the computer tries numerous combinations until the password is successfully discovered. Now, password attacks can be done for several reasons, but the most malicious reason is in order to gain unauthorized access to a computer with the computer's owner's awareness not being in place. Now, this results in cybercrime, such as stealing passwords for the purpose of accessing bank information. Now today, there are three common methods used to break into a password-protected system. The first is a brute force attack. A hacker uses a computer program or script to try to log in with possible password combinations, usually starting with the easiest to guess password. So just think, if a hacker has a company list, he or she can easily guess usernames. If even one of the users has a password 123, he will quickly be able to get in. The next are dictionary attacks. Now a hacker uses a program or script to try to log in by cycling through the combinations of common words. In contrast with brute force attacks, where a large proportion key space is searched systematically, a dictionary attack tries only those possibilities which are most likely to succeed, typically derived from a list of words, for example, a dictionary. Generally, dictionary attacks succeed because most people have a tendency to choose passwords which are short or such as single words found in the dictionaries, or simple, easy predicted variations on words such as appending a digit or so. Now, the last kind of password attacks are used by keylogger attacks. A hacker uses a program to track all of the user's keystrokes. So at the end of the day, everything the user has typed, including the login IDs and passwords, have been recorded. A keylogger attack is different than a brute force or dictionary attack in many ways, not the least of which the key logging program used is a malware that must first make it onto the user's device. And the keylogger attacks are also different because stronger passwords don't provide much protection against them, which is one reason that multi-factor authentication is becoming a must-have for all businesses and organizations. Now, the only way to stop yourself from getting killed in the whole password attack conundrum is by actually practicing the best practices that are being discussed in the whole industry about passwords. So basically, you should update your password regularly. You should use alphanumerics in your password. And you should never use words that are actually in the dictionary. It's always advisable to use garbage words that make no sense for passwords, as they just increase your security. So moving on, we're going to discuss DDoS attacks. So what exactly is a DDoS or a DOS attack? Well, first of all, it stands for Distributed Denial of Service, and a DOS attack focuses on disrupting the service to a network, as the name suggests. Attackers send high volume of data of traffic through the network until the network becomes overloaded and can no longer function. So there are a few different ways attackers can achieve DOS attack, but the most common is the Distributed Denial of Service attack. This involves the attacker using multiple computers to send the traffic or data that will overload the system. In many instances, a person may not even realize that his or her computer has been hijacked and is contributing to the DOS attack. Now, disrupting services can have serious consequences relating to security and online access. Many instances of large-scale DOS attacks have been implemented as a single sign of protest towards governments or individuals and have led to severe punishment, including major jail time. So, how can you prevent DOS attacks against yourself? Well, firstly, unless your company is huge, it's rare that you would be even targeted by an outside group or attackers for a DOS attack. Your site or network could still fall victim to one, however, if another organization on your network is targeted. Now, the best way to prevent an additional breach is to keep your system as secure as possible with regular software updates, online security monitoring, and monitoring of your data flow to identify any unusual or threatening spikes in traffic before they become a problem. DOS attacks can also be perpetrated by simply cutting a table or dislodging a plug that connects your website server to the internet. So due diligence in physically monitoring your connections is recommended as well. Okay, so next up on our list is man-in-the-middle attacks. So by impersonating the endpoints in an online information exchange, the man-in-the-middle attack can obtain information from the end user and the entity he or she is communicating with. For example, if you are banking online, the man in the middle would communicate with you by impersonating your bank and communicate with the bank by impersonating you. The man in the middle would then receive all of the information transferred between both parties, which could include sensitive data such as bank accounts and personal information. So how does it exactly work? Normally, an MITM gains access through a non-encrypted wireless access point, which is basically one that doesn't use WAP, WPA, or any of the other security measures. Then they would have to access all of the information being transferred between both parties by actually spoofing something called Address Resolution Protocol. That is the protocol that is used when you are actually connecting to your gateway from your computer. So how can you exactly prevent MITM attacks from happening against you? So firstly, you have to use an encrypted WAP, that is an encrypted wireless access point. Next, you should always check the security of your connection, because when somebody is actually trying to compromise your security, he will try to actually strip down the HTTPS or HSTS that is being injected in the website, which is basically the security protocols. So if something like this HTTPS is not appearing in your website, you're on an insecure website where your credentials or your information can be compromised. And the last and final measure that you can actually use is by investing in a virtual private network, which spoofs your entire IP, and you can just browse the internet with perfect comfort. Next up on our list is drive-by downloads. So gone are the days where you had to click to accept a download or install a software update in order to become infected. Now just opening a compromised web page could allow dangerous code to install on your device. You just need to visit or drive by a web page without stopping, or to click accept any software, and the malicious code can download in the background to your device. A drive-by download refers to the unintentional download of a virus or malicious software onto your computer or mobile device. A drive-by download will usually take advantage or exploit a browser or app or operating system that is out of date and has security flaws. This initial code that is downloaded is often very small, and since its job is often simply to contact another computer where it can pull down the rest of the code onto your smartphone, tablet, or other computers. Often, a web page will contain several different types of malicious code in hopes that one of them will match a weakness on your computer. So how does this exactly work? Well, first you visit the site, and during the three-way handshake connection of the TCP/IP protocol, a backend script is triggered. As soon as a connection is made while the last ACK packet is sent, a download is also triggered, and the malware is basically injected into your system. Now, the best advice I can share about avoiding drive-by downloads is to avoid visiting websites that could be considered dangerous or malicious. This includes adult content, file-sharing websites, or anything that offers you a free trip to the Bahamas. Now, some other tips to stay protected include keep your internet browser and operating system up to date, use a safe search protocol that warns you when to navigate to a malicious site, and use comprehensive security software on all your devices like McAfee All Access and keeping it up to date. Okay, so that was it about drive-by downloads. Next up is maladvertising or malvertising. So malvertising is the name we in the security industry give to criminally controlled advertisements which intentionally infect people and businesses. These can be any ad on any site, often ones which you use as a part of your everyday internet usage, and it is a growing problem, as is evident by a recent US Senate report and the establishment of bodies like Trust in Ads. Now, whilst the technology being used in the background is very advanced, the way it presents to the person being infected is simple. To all intents and purposes, the advertisement looks the same as any other, but has been placed by a criminal. Like you can see the Mint ad out here, it's really out of place, so you could say it's been made by a criminal. Now, without your knowledge, a tiny piece of code hidden deep in the advertisement is making your computer go to the criminal servers. These then catalog details about your computer and its location before choosing which piece of malware to send you. And this doesn't need a new browser window and you won't know about it. So basically, you're redirected to some criminal server, the malware injection takes place, and voila, you're infected. It's a pretty dangerous thing to be in. So how exactly can you stop malvertising? Well, first of all, you need to use an ad blocker, which is a very must in this day and age. You can have ad blocker extensions installed on your browser, whether it be Chrome, Safari, or Mozilla. Also, regular software updates of your browser and other softwares that work peripheral to your browser always help. And next is some common sense. Any advertisement that is about a lottery that's offering you free money is probably going to scam you and inject a malware too. So never click on those ads. So the last kind of cyber attacks we are going to discover today and discuss about is rogue software. So rogue security software is a form of malicious software and internet fraud that misleads users into believing that there is a virus on their computer and manipulates them into paying money for a fake malware removal tool. It is a form of scareware that manipulates users through fear and a form of ransomware. Rogue security software has been a serious security threat in desktop computing since 2008. So now, how does a rogue security software work? These scams manipulating users into download the program through a variety of techniques. Some of these methods include ads offering free or trial versions of security programs, often pricey upgrades, or encouraging the purchase of the deluxe versions. Then also pop-ups warning that your computer is infected with a virus, which encourages you to clean it by clicking on the program. And then manipulated SEO rankings that put infected website as the top hits when you search. These links then redirect you to a landing page that claims your machine is infected and encourages you a free trial of the rogue security program. Now, once the scareware is installed, it can steal all your information, slow your computer, corrupt your files, disable updates for legitimate antivirus softwares, or even prevent you from visiting legitimate security software vendor sites. Well, talking about prevention, the best defense is a good offense. And in this case, an updated firewall makes sure that you have a working one in your office that protects you and your employees from these type of attacks. It is also a good idea to install a trusted antivirus or anti-spyware software program that can detect threats like these. And also a general level of distrust on the internet and not actually believing anything right off the bat is the way to go.
Let's now dive into the top 10 antivirus solution for cybersecurity that offers complete protection for both individuals and businesses. So first on the list we have Norton 360. So this is the best antivirus for Windows, Android and iOS. Norton 360 approved by experts are the choice of most people. It boasts a 100% malware detection rate. So here's what makes it stand out. So some of the key features include AI-based scanner, VPN, secure firewall, password manager, phishing protection with a private browser, dark web monitoring, identity theft protections, optimization tools, parental controls, Wi-Fi security alerts for Android and iOS, cloud solution up to 500 GB, ransomware protection, and much more. So when we talk about devices and compatibility, it protects up to 10 devices and works across all major operating systems. Then The money back guarantee is 60 days risk-free. Now, let's talk about pricing. So the basic protection for one device with Antivirus Plus is at Rs 799 per year. Next, 360 Deluxe is a favorite at 1199 rupees per year for 3 devices, including VPN, dark web monitoring and cloud storage. And for complete identity theft protection, Norton's LifeLock subscription starts at Rs 7718 per year. Norton 360 utilizes a unique scanning engine powered by heuristic analysis and machine learning, constantly outperforming built-in antiviruses like Microsoft Defender. Its additional features such as the secure firewall, parental controls, and even a free browser called Private Browser makes it a comprehensive security suite. Next up, we have Bitdefender Total Security, which also delivers a 100% malware detection rate. This antivirus uses a massive malware database, machine learning, and artificial intelligence to detect threats more effectively than almost any competitor. So here are some of the key features, such as cloud-based scanner that minimizes system strain, web protection, vulnerability scanner, system optimizer, VPN, parental controls, password manager, webcam protection, ransomware protection, identity theft protections, and much more. And when we talk about performance, during full system scans, it averages 21% CPU usage, dropping to less than 1% when running in the background. Next, let us talk about the devices and compatibility. So it covers up to 10 devices across major operating systems. And money back guarantee is for 30-day risk-free. Now, let us have a look at the pricing. So Bitdefender Antivirus Plus for one device starts at Rs 1199 per year. Bitdefender Internet Security for up to 3 Windows is available at Rs 1799 per year. The Bitdefender Total Security Plan covers 5 licenses for Windows, Mac OS, Android, and iOS at Rs 2499 per year. However, Bitdefender Premium Security at Rs 2999 per year offers unlimited VPN usage and additional features. Its cloud-based scanning not only keeps your system running smoothly, but also provides extensive cybersecurity tools, making it an excellent value for anyone looking for a comprehensive protection suite. And for those seeking simplicity without compromising on protection, Total AV is an outstanding choice with a 99.60% malware detection rate. So here's why Total AV is perfect for beginners and advanced users alike. So the key features include an intuitive dashboard, fast and reliable antivirus scanner, Web Shield for blocking dangerous websites, Total Browser for secure browsing that alerts you if a page was involved in a data breach, and a performance optimizer that cleans up unnecessary files. So let's have a look at the additional tools. Total AV's VPN is secure and compatible with popular streaming sites, while its password manager offers auto-saving, auto-filling, and customizable generator and cross-device synchronization. So when we talk about devices and compatibility, it supports up to 8 devices and it is compatible with all major operating systems, including Chromebooks and even Kindle Fire tablets. So when we talk about money back guarantee, then it is 30-day risk-free. So let us have a look at the pricing. Total AV's Total Security for up to 8 devices at Rs 4202 per year. For budget users, Total AV's premium covers up to 3 devices at Rs 2487 per year. So with its powerful antivirus engine and user-friendly interface, Total AV is a perfect all-rounder for those new to cybersecurity. McAfee Total Protection is next on our list, delivering a flawless 100% malware detection rate and a suite of features ideal for families. And the key features include comprehensive malware protection, anti-phishing, a password manager, VPN, identity theft monitoring, and even an app for Chromebooks. Its anti-phishing protection reliably blocks dangerous websites, and its scam protection warns you about risky links across emails, text, and browsers. And family features include advanced parental controls with accurate location tracking, makes it one of the best choices for family safety. So when we talk about devices and compatibility, it offers protection for an unlimited number of devices. Money back guarantee is up to 30-day risk-free. Now, let us have a look at the pricing. So the basic plan is at rupees 799 per year for one device, and the premium family package at rupees 1699 per year offers unlimited device coverage plus enhanced features. And advanced and unlimited plans provide even more protection, including identity theft coverage. So despite a slightly heavier impact on system performance during full scan, McAfee's robust protection and extensive features makes it a top contender for comprehensive online security. So if you're a Mac user, Intego is the antivirus built just for you, delivering a 100% malware detection rate for both Mac OS and even PC-based malware. So some of the key features include real-time malware protection, Mac optimization and cleaning tools, advanced backup options, network security, and parental controls. Its fast scanning engine can scan over 8 lakh files in under 2 hours, with subsequent scans taking just minutes, and it's all because of its file caching system. So unique features include Intego's customizable firewall monitors both incoming and outgoing network connections, automatically adjusting its setting based on your environments. So when we talk about devices and compatibility, it protects up to 5 Macs with an additional Windows product also available. So money back guarantee is for 30-day risk-free. Now let's have a look at the pricing. So the Mac Premium Bundle X9 includes all features at a competitive price starting at rupees 5,715 per year. So Intego not only enhances Apple's built-in security but also ensures your devices are optimized and protected, making it the best choice for the Mac OS users. Next on the list, we have Panda Dome. Panda Dome offers flexible pricing and an advanced virus scanner with a 95% malware detection rate. It stands out with its versatile range of plans and extras. So key features includes web protections, optimization tools, VPN, firewall, parental controls, password manager, dark web monitoring, file encryptor, and even a free bootable antivirus rescue kit. Now let's have a look at the flexible plans. Panda Free provides basic real-time protection for Windows, an app scanner for Android, a rescue kit, and a limited VPN. The Essential plan is at rupees 2,134 per year, adds a firewall and a Wi-Fi protection. The Advanced plan is at rupees 2,834 per year and adds a ransomware protection. The complete package includes a password manager and optimization tools. Panda Dome Premium offers an unlimited data VPN and 24/7 support at 5,999 rupees per year. And also, it supports unlimited devices and money-back guarantee is for 30-day risk-free. Panda Dome's variety of plans let you choose the exact features you need, making it a highly adaptable solution for every user's cybersecurity requirements. The next antivirus on our list we have Kaspersky Premium. Kaspersky Premium is our next pick, offering excellent antivirus protection with a 100% malware detection rate and specialized features for online shopping and banking. So some of the key features include robust antivirus engine, anti-phishing, parental controls, webcam protection, a safe browser for online transaction, VPN with unlimited data, password manager, and even a smart home monitor to oversee your connected devices. So additional benefits includes its safety money feature creates a sandbox browser window that's secure for handling payments, while the virtual keyboard helps avoid keyloggers. So when we talk about devices and compatibility, it covers up to 20 devices and money-back guarantee for 30-day risk-free. Now, let us have a look at the pricing. Kaspersky Premium is available at rupees 899 per year for the best value plan and with options to cover 1, 3, 5, 10 or 20 devices. Despite current restrictions for United States users due to regulatory bans, Kaspersky remains GDPR compliant, SOC 2 audited, and is a trusted choice globally for secure online transactions. So the next antivirus on our list is Avira Prime. Avira Prime combines a powerful antivirus engine consistently scoring a 100% detection rate with advanced system optimization tools. It's perfect if you need both robust protection and performance improvements. So some of the key features include privacy optimization, system optimization tools such as Startup Optimizer, saving up to 2 minutes on boost time, a game booster, a junk file cleaner, a duplicate file finder, and a streamlined deliver updater. So it also includes a VPN with unlimited data and a password manager. Performance advantages are its antivirus engine operates entirely in the cloud, minimizing the impact on system performance, which is ideal for older and slower PCs. And when we talk about devices and compatibility, it protects up to 5 devices across all major operating systems. And money back guarantee for 60 days risk-free. Now, let us have a look at the pricing. Avira Prime is offered at 2,031 rupees per year for 5 devices, with our cheaper plans such as Avira Internet Security are available for 1,202 rupees per year for 1 device. Avira Prime is an excellent all-in-one solution for those who not only need security but also want to optimize their device's performance. Next on the list, we have Trend Micro. Trend Micro delivers solid protection with a 97% malware detection rate and excels in ensuring secure web browsing. So some of the key features include its anti-malware engine, enhanced with a robust browser extension, blocks online scams, unsafe websites, scam links, malicious code, and even misinformation. It also comes with a password manager secured by 256-bit AES encryption and an ad blocker. Now, let us talk about the web protection. Trend Micro's browser extension outperforms those built into Chrome, Firefox, or Safari in detecting phishing and scam sites. So when we talk about devices and compatibility, it protects up to 10 devices across various operating systems. Money back guarantee for 30-day risk-free. Now, let us talk about pricing. So it is starting at Rs 1,386 per year with the maximum security plan covering up to 1 device and the premium security suite at Rs 4,710 per year for 10 devices. It is offering additional identity theft protection and a fully featured VPN. Trend Micro's excellent web protection features makes it a strong contender for those who prioritize secure browsing. Now, rounding out our list is Malwarebytes, also known for its simplicity and ease of use while providing a 95% malware detection rate. So some of the key features include a secure browser extension that blocks ads, trackers, phishing sites, and other potential scams. It also offers exploit protections that are highly customizable and effective against zero-day threats. Now, let us talk about additional benefits. So it comes bundled with a VPN offering unlimited data and servers in 45 plus countries, along with identity theft protection available as an add-on. So when we talk about devices and compatibility, it covers up to 20 devices and works seamlessly across all major operating systems, including Chromebooks. So money back guarantee for 60 days risk-free. Now, let us have a look at the pricing. Malwarebytes starts at Rs 3,855 per year, making it a solid choice for those who need basic and reliable protection without a plethora of extra features. So despite its minimalist approach, Malwarebytes remains a dependable option for everyday antivirus protection. So that wraps up our comprehensive review of the top 10 antivirus for cybersecurity. Each of these products brings its strength from Norton's robust all-round security to Avira's system optimization and Malwarebytes' strength-forward protection. Whether you're a home user, a family, or a dedicated professional, there's a solution here to meet your needs. Now that you are all caught up on what's ahead, so let's dive into the core of our discussion. That is technical skills. These are the building blocks that not only protect our systems, but also lay the foundation for every other defensive measure in cybersecurity. So first on our list, we have network security. In today's interconnected world, network security is the foundation for any robust cybersecurity strategy. It involves configuring and monitoring firewalls, implementing intrusion detection systems, and safeguarding network communications. So just as a sturdy wall defends a fortress, a well-secured network prevents unauthorized access and data breaches, ensuring that every digital channel is fortified against evolving threats. Next on the list, we have incident response and risk management. Cyber incidents are inevitable. What matters is how swiftly and effectively you respond. incident response isn't only about reacting to breaches. It's also about preparing in advance through rigorous risk management practices. This means having clear protocols, regular drills, and comprehensive plans in place, so that when a threat emerges, you're ready to mitigate the damage and secure the environment with minimal disruption. The next skill that we are going to discuss is advanced threat analysis. Advanced threats are on the rise, and cybersecurity experts need the skills to analyze and counter them. So attackers are using sophisticated tactics, often leveraging technologies like artificial intelligence to launch complex attacks. In-depth threat analysis enables you to understand these tactics, predict potential vulnerabilities, and implement countermeasures that neutralize emerging risks before they escalate into full-blown breaches. The next skill on our list is ethical hacking and penetration testing. So to build truly secure systems, you must sometimes think like the enemy. Ethical hacking and penetration testing empower you to identify weaknesses within your infrastructure. And by simulating real-world attacks in a controlled setting, you can uncover hidden vulnerabilities and address them proactively, ensuring that your defenses remain robust against adversaries. The next cybersecurity skill is artificial intelligence and machine learning. Cybersecurity experts of the future will need to leverage AI and ML not only to understand threats but also to forecast potential attacks. And these technologies allow you to develop predictive models that continuously learn from new data patterns, making it possible to detect anomalies and swiftly respond to threats as they evolve, keeping you one step ahead of cybercriminals. Next, programming and scripting. The backbone of modern cybersecurity relies on the ability to customize, automate, and innovate. Strong programming and scripting skills let you create automated defense mechanisms, manage threat intelligence feeds, and develop tailored solutions to complex security challenges. This technical proficiency empowers you to build and modify your tools in real time as new threats emerge. And the next technical skill is cryptography. Cryptography is essential to protect the confidentiality and integrity of data. And by mastering encryption techniques, you can secure sensitive information both in transit and at rest. In today's digital world, robust cryptographic practices are the invisible shield that prevents unauthorized access and data manipulation, ensuring that critical information remains confidential even in the most hostile environments. The next technical skill on our list is digital forensics. When breaches occur, digital forensic provides the investigate lens needed to trace back every move on the attacker. So it involves meticulously collecting, preserving, and analyzing digital evidence to uncover how an intrusion happened. So these critical skills not only assist in understanding and remedying breaches, but also fortifies future defense strategies by learning from past incidents. The next skill on our list is operating systems. A thorough understanding of various operating systems from Windows to Linux and Mac OS is vital. Each system has unique vulnerabilities and security configurations, and proficiency across these platforms allows cybersecurity experts to secure endpoints, manage permissions, and troubleshoot system-specific issues effectively. Mastery over operating systems means you are well prepared to handle any digital environment. The next skill is governance, risk management, and compliance. Cybersecurity extends beyond technology. It involves aligning technical measures with policies, processes, and legal standards. So experts must navigate complex regulatory environments, ensuring that security controls not only protect data, but also comply with governance and risk management protocols. This holistic approach guarantees that security practices support both technological and organizational integrity. Now moving on to the soft skills. While technical expertise provides the backbone for our cyber defenses, there is another equally crucial side to this coin. Next up are the soft skills that empower cybersecurity professionals to communicate, adapt, and think critically in high-pressure situations. So first, we will discuss on communication skills. Cybersecurity isn't just about firewalls and scripting. It's also about people. Effective communication is crucial, especially when you need to explain technical issues to non-technical stakeholders or coordinate a rapid incident response. So clear, concise communication ensures that everyone is on the same page, making collective problem solving more efficient during both planned operations and crisis scenarios. The next soft skill, which is important, is adaptability. With the cybersecurity landscape changing at a lightning speed, the ability to adapt is key, whether it's a new threat vector or an emerging technology. So being able to shift gears, learn on the fly, and modify strategies quickly is critical. So adapting is a quality that keeps your defense resilient to no matter what unexpected challenges arise. The next soft skill is critical thinking. So in the world of cybersecurity, every piece of the data can be a clue. So critical thinking lets you shift through layers of complex information, challenge assumptions, and formulate innovative solutions. This strategic mindset is essential for tackling sophisticated threats hand-on and ensuring that every security measure is both rational and effective. Next skill on our list is problem solving. So every cybersecurity incident is a problem waiting to be solved. Strong problem-solving skills enable you to diagnose the root cause of vulnerabilities, devise strategic remedies, and implement practical solutions even under pressure. This skill transforms challenges into opportunities for improvement, bolstering your overall defense mechanism. And the next soft skill is continuous learning. The cyber threat landscape evolves every day, and so must your skills. A commitment to continuous learning means staying updated with the latest tools, methodologies, and threats. It's this drive for constant improvement that ensures you're always prepared to defend against the unexpected, making lifelong learning a cornerstone of your professional journey. By now, we have explored a holistic range of skills, both technical and soft skills, that are essential for navigating today's ever-evolving threat landscape. So from securing networks and analyzing advanced threats to communicating complex concepts with clarity, every skill plays a pivotal role in safeguarding our digital lives.
What exactly is cybersecurity career? Well, a cybersecurity career revolves around protecting technology from unauthorized or criminal use. The idea is to ensure that information stays secure and confidential, but also accessible when it needs to be. As a cybersecurity professional, you're not just sitting behind a screen all day. You'll need to understand how technology works, computers, networks, software, and actively look for weaknesses in systems. You're essentially the one of the front line, identifying and fixing problems before they cause damage. Sounds pretty cool, right? In cybersecurity career, you should play a part in several areas. First, keep all IT systems with regular updates and software and system patches. Then, educate employees about cyber threats, that is, social engineering, weak passwords. After that, monitor network traffic to identify potential threats. Then block unauthorized access. Maintain compliance with industry standards. Lastly, ensure compliance with government regulations. Now, if you're wondering what types of job exist in this field, let's break it down. A career in cybersecurity is not just about working in a security operations center or doing ethical hacking all day. There are a range of exciting roles that could suit different skills and interests. First, we have the penetration tester. These are the people who get paid to hack. But don't worry, it's all ethical. The goal is to test vulnerabilities and fix them before the bad guys find them. Average salary? Around $100,000. Next comes the cybersecurity analyst. You will get to know everything about your organization's IT infrastructure, monitoring network traffic, identifying vulnerabilities, and ensuring protection. This role brings an average salary of $93,643. Next, we have ethical hacker, also known as white hat hacker. You'll hack into systems with the goal of finding weaknesses before criminals can. This one's not only exciting, but also pays well. An average around $120,000. Next comes digital forensics examiner. If you're into investigations, this role could be for you. You'll gather evidence, understand how attacks happened, and help identify the attackers. The average salary is $82,232. Last we have is network operations center technician. These are the people responsible for maintaining and troubleshooting network systems. The salary here averages around $76,964. Now, I know what you're thinking. That all sounds awesome. But is it really worth it? Let's dive into the pros and cons of cybersecurity career to get a clearer picture. First, let's talk about the pros. The first big pro is job availability. The US Bureau of Labor Statistics predicts that information security roles will grow by a whopping 32% over the next decade. That's way faster than most other industries. With the increasing frequency of cyber threats, businesses need cybersecurity professionals more than ever. The next pro is good compensation. Cybersecurity professionals are high in demand, which means they tend to get paid well. Cybercrime is costing businesses billions, and they are willing to pay top dollars for experts who can stop it. One of the cool things about cybersecurity is that it's not one size fits all. You can find a path that suits your interests and strength. From ethical hacking to security analysis, there is a role for everyone, and you can switch it up as you grow in your career. The next pro is future-proof career. We all know technology is rapidly evolving. With that, the need of cybersecurity experts will only keep growing. Cyber threats won't disappear as long as the internet exists. Cybersecurity professionals will be in demand. Sounds pretty future-proof, right? The next pro is continuous challenges. If you love challenges, then cybersecurity is for you. As technology evolves, so do the threats. You constantly be learning and adapting to new tools, technologies, and attack methods. Now that we have discussed the perks, let's consider the downsides. What are potential downsides of pursuing a career in cybersecurity? The first con we have is unrealistic expectations. Let's clarify something. Not every day is an action-packed mission. Sure, the movies make it seem like a hacker will come through the door anytime. But the reality is that a lot of work is routine and can be repetitive, especially early on your career. The next con we have is the constant changes. Technology doesn't stop evolving, and neither do cyber threats. This is great because it keeps things exciting, but it also means you will need to keep learning. If you're someone who prefers stability, this might feel a bit overwhelming at times. The next con is the element of unpredictability. This one's big. In cybersecurity, you might be monitoring networks or systems, and everything seems calm. But when an attack happens, it happens fast. Cybersecurity professionals have to be prepared to deal with surprises and rapidly adapt to new situations. Alright, so what do you need to succeed in this field? Let's go over the key skills you need for thriving cybersecurity career. To make it in cybersecurity, you'll need both technical and workplace skills. Let us talk about the technical skills first. It starts with system and software installation, then web application, endpoint and cloud security, knowledge of firewall, malware protection and digital forensics, then proficiency in programming and scripting, lastly, understanding of security protocols and frameworks. Now let's take a look at the workplace skills. Firstly, strong communication and leadership. Then, problem solving and analytical thinking. Lastly, attention to detail and a love for continuous learning. Now, how do you build these skills and stay ahead in this dynamic field? That's where we at Edureka come in. We offer comprehensive training programs to help you gain expertise and stand out in cybersecurity job market. Here's a quick overview of what we provide. The first we have is a cybersecurity certification course. This course is perfect for beginners looking to understand cybersecurity fundamentals. You'll learn tools, techniques, and essential concepts to kickstart your career. The next thing we have is Certified Ethical Hacking course. Want to think like a hacker and protect systems? This course dives into advanced hacking techniques and AI-powered insights to keep you ahead of the curve. The next we have is CompTIA Security Plus training. This globally recognized certification focuses on foundational security concepts like network security and risk management. At last, we have a CISSP certification training. If you're eyeing leadership roles, the CISSP certification is the gold standard. We'll help you master topics like risk management, access control, and security architecture. Now, if you're wondering if cybersecurity is worth pursuing, the answer depends on your interests. If you love technology, problem solving, and protecting businesses from cyber threats, then it's definitely a career worth exploring.
Let's examine the current job demand for cybersecurity experts. Cybersecurity is booming and the numbers speak for themselves. According to the graph, the demand size of cybersecurity in India is projected to grow from 4.7 billion in 2024 to 10.9 billion by 2029. Similarly, in the United States alone, There are thousands of job openings and these numbers are only going up. According to an article by Cybercrime magazine, there are projected to be around 3.5 million unfilled cybersecurity positions by 2025. Numerous reports highlight the growing job demand for cybersecurity professionals, but they also reveal a significant talent shortage and a huge skill gap in the industry. In fact, if you do a quick Google search for cybersecurity jobs, you will find leading companies looking for experts, often with impressive salary packages. These opportunities are out there and applying for them is easy, but filling the skill gaps to land these roles requires the right preparations and expertise. That's why we are here with these essential cybersecurity interview questions to help you build the skills and the confidence needed to succeed in this field. So, let's dive in and get started. Before we dive into the details, please subscribe to our YouTube channel and do not forget to hit the bell icon for the latest tech content from Edureka. Also, visit Edureka's website for various training and certification courses, the link to which is in the description box below. So first, let's get started with the beginner level interview questions. And the first question we often hear is, what is cybersecurity and why is it important? So here's an answer to this. Cybersecurity is the practice of protecting computer systems, networks, and the data from theft, damage, or unauthorized access. And it's crucial because it helps safeguard sensitive information, ensure privacy, prevent financial losses, and protect critical infrastructure from cyber threats. Next, a fundamental question in cybersecurity is understanding the differences between a threat and a vulnerability and a risk. So, let's break it down. A threat is any potential danger or harmful event that can exploit vulnerabilities and negatively impact security. Think of a threat as something that could cause damage like a hacker, a virus, or even a natural disaster. A vulnerability, on the other hand, is a weakness or a gap in our security measures that threats can exploit. Examples include an outdated firewall, weak passwords, or unpatched software. Finally, risk is the probability of a threat successfully exploiting a vulnerability combined with the potential consequences. It's about evaluating how likely it is that a vulnerability will be exploited and what the impact could be. So, in simple terms, threats are the dangers, vulnerabilities are the weaknesses, and risk is the likelihood and impact if the danger becomes reality. Another common question is, how do firewalls protect network security? So let's go over this. Firewalls act as protective barriers that monitor and control both incoming and outgoing network traffic based on predefined security rules. Firewalls work by filtering traffic and blocking any unauthorized access to prevent malicious data from entering or leaving the network. For example, they can detect and stop harmful connections like suspicious IP addresses or unsafe websites from communicating with your internal systems. Next, we have a question about VPNs. What is a VPN and why is it used? A VPN or virtual private network is a service that encrypts and secures your internet connections, making it more private and anonymous. VPNs are especially useful for three main reasons. First, they protect your data from eavesdropping, which is crucial if you're using public Wi-Fi networks. Second, they allow you to access content that might be restricted by location, like certain streaming services or websites. And the third, they provide an extra layer of security, especially when using untrusted networks, helping you avoid potential cyber threats. Now, let's talk about two-factor authentication or 2FA. A common question is, what is two-factor authentication and why is it important? Two-factor authentication enhances security by requiring two different types of verifications from the user. Usually, this involves something you know like a password and something you have such as a temporary code sent to your phone or generated by an app. So this additional layer is crucial because even if someone obtains your password, they still can't access your account without the second factor. 2FA significantly reduces the risk of unauthorized access and makes your accounts far more secure. Now, let's dive into two important terms in cybersecurity, that is encryption and decryption. Encryption is the process of converting plain text data, that is data in its original readable form, into a coded format to protect it from unauthorized access. Decryption, on the other hand, is the process of converting encrypted data back into its original readable form. This allows unauthorized users to view the data as intended. Next, let's talk about SSL encryption. The question is, what is SSL encryption? SSL, or Secure Sockets Layer, is a security protocol that encrypts data transmitted between a user's web browser and a website server. Essentially, SSL protects sensitive information like login credentials, credit card numbers, and personal data when it's sent over the internet. This encryption ensures that data stays secure during transit, preventing eavesdropping and tampering by unauthorized parties. You can tell a website has SSL encryption if you see HTTPS at the start of the URL with a padlock symbol next to it. Next, a common interview question is, what is the difference between IDS and IPS? IDS stands for Intrusion Detection System. It's designed to monitor network traffic and detect suspicious or unusual activities, generating alerts when it finds something that might be a threat. IPS, or Intrusion Prevention System, goes a step further. It not only detects potential threats but also takes immediate action to block or prevent suspicious activity. Now, another common question in cybersecurity interviews is, what are cookies in a web browser? Cookies are small data files that websites store on your device. These files hold information like your preferences, session details, and login status, which helps website remember you and provide a more personalized browsing experience. For example, when you add items to an online shopping cart and come back later to find them still there, it's because cookies have saved that information for you. They track your session information, so you don't have to start over. Similarly, cookies enable websites to keep you logged in or show content that's relevant to your interest. Next, an interesting term you might encounter in cybersecurity is honeypot. So, what exactly is honeypot? In cybersecurity, a honeypot is a decoy system or network set up specifically to attract cyber attackers. While attackers focus on the honeypot, security professionals can watch their every move and learn about their tactics, techniques, and goals. This setup helps organizations understand real-world attack strategies and vulnerabilities, enabling them to strengthen their defenses accordingly. Now, let's move on to the intermediate level interview questions. One fundamental concept in secure communication is public key infrastructure, or PKI. So, what is PKI and why is it important? PKI is a system of cryptographic techniques designed to enable secure communication over insecure networks like the internet. At the heart of PKI is a key pair, a public key which is shared openly and a private key which is kept confidential by the owner. So these keys are used in various operations such as encrypting and decrypting data, creating digital signatures, and verifying the authenticity of a message or document. PKI uses a certificate authority to ensure that a public key is legitimate and belongs to the correct entity. Certificate authorities validate public key by issuing digital certificates, giving users confidence that they are connecting to a trusted source. Another interview question you might face is about rootkits. So what exactly is a rootkit and how would you detect one? A rootkit is a malicious software designed to give attackers hidden, unauthorized access to a system. Unlike other malware, rootkits are particularly dangerous because they work in the background, often evading standard antivirus detection. Attackers use them to control a system remotely, monitor activities, and steal sensitive information, all while remaining hidden. Detecting a rootkit can be challenging due to its stealthy nature, but there are ways to spot one. First, specialized anti-rootkit tools are built to scan and detect this type of malware specifically. Additionally, monitoring the system for unusual behavior can help, such as unexplained system slowdowns, unexpected processes running, or changes to critical files. This can all be signs of a rootkit operating in the background. Now, you might also get asked about zero-day vulnerabilities in a cybersecurity interview. So, what exactly is a zero-day vulnerability? A zero-day vulnerability is a security flaw in software or hardware that has yet to be discovered or disclosed by the vendor. Because no patch or fix exists at the time of the discovery, these vulnerabilities are highly dangerous. Attackers can exploit the vulnerabilities immediately before developers have any chance to resolve it. For example, zero-day vulnerabilities have been used in major cyber incidents like the WannaCry ransomware attack causing widespread damage. Next, in cybersecurity, digital signatures are an essential concept, especially in securing communication and transactions. But what exactly is a digital signature? A digital signature is a cryptographic method for verifying the authenticity and integrity of a digital document or message. So here's how it works. When a sender signs a document digitally, a unique code known as a hash is generated based on the document's content. This hash, combined with the sender's private key, creates the digital signature. When the receiver gets the document, they can use the sender's public key to confirm both the sender's identity and that the document hasn't changed since it was signed. Now, moving on to our next question. Patch management is a key component of maintaining security in any organization. But what exactly is its role? Patch management is the process of regularly updating software and systems to address known vulnerabilities. When a software vendor identifies a security flaw, they release a patch, a small update designed to fix it. Applying these patches as soon as they are available is essential because attackers often look for these known vulnerabilities to exploit before systems are updated. Another essential tool in cybersecurity is the Security Information and Event Management System or SIEM. But what exactly does a SIEM do? A SIEM system is a centralized security solution that gathers and analyzes data from various sources, such as firewalls, servers, and endpoint devices. Its main job is to detect potential threats in a real time by correlating data from these sources and looking for unusual patterns or behaviors that could signal an attack. When the SIEM identifies a potential threat, it generates alerts that enable security teams to respond quickly. Additionally, SIEM systems assist with incident investigations by providing detailed logs and can also support compliance requirements by keeping track of security-related events and creating reports. Now, when it comes to disposing of sensitive data securely, there are several common methods used to ensure it can't be recovered. So let's go over each of this. First, data shredding is a method that breaks data down into smaller, unusual pieces similar to how paper shredding works. This makes it nearly impossible to reconstruct the original information. Next, overwriting is another method where we replace the old data with random characters multiple times. This technique is effective for preventing data recovery even with advanced forensic tools. For magnetic storage media like hard drives, we often use degaussing. This involves applying a strong magnetic field to erase data, which scrambles the magnetic field that stores information, making it unreadable. Finally, there is a physical destruction, where storage media are physically broken, drilled, or shredded. This is the most secure method, especially for highly sensitive data, as it ensures no data can ever be retrieved. Now, moving on to our next question. Endpoint security is a critical aspect of an organization's cybersecurity strategy. But what exactly does it involve? Endpoint security refers to protecting individual devices or endpoints like computers, smartphones, and even IoT devices that connect to a network. Each of these endpoints represents a potential entry point for attackers, so securing them is essential for preventing breaches. Endpoint security uses tools such as antivirus and anti-malware software to scan and remove harmful programs. Intrusion detection systems also monitor for unauthorized access attempts on these endpoints. Next, a Security Operations Center or SOC is often the frontline defense for an organization's cybersecurity efforts. So what exactly does a SOC do? Think of the SOC as a centralized team of cybersecurity professionals dedicated to monitoring, detecting, and responding to security incidents in real time. It's essentially the command center for an organization's digital security. One of the Security Operations Center's main function is continuous monitoring. Using tools like SIEM systems, the SOC team tracks network, system, and endpoint activities looking for anything unusual that could signal a potential threat. The Security Operations Center is also responsible for incident detection and response. When a threat is detected, the team acts quickly to contain and resolve it before it escalates. Beyond responding to incidents, the Security Operations Center also works on threat intelligence, gathering information on emerging threats and developing strategies to mitigate them. Additionally, they perform forensic analysis after incidents to understand the root cause, impact, and steps to prevent similar occurrence in the future. So, what's the difference between penetration testing and vulnerability assessments? When they both aim to improve security, they approach it from different angles. A vulnerability assessment is focused on scanning systems for known weaknesses. Vulnerability assessments are non-intrusive. They provide a report of vulnerabilities without attempting to exploit them. This assessment is ideal for getting a high-level overview of what needs to be patched or improved. Penetration testing, on the other hand, takes things a step further by simulating real-world attack scenarios. This test actively attempts to exploit identified vulnerabilities to see what a potential attackers could accomplish. Penetration testing is intrusive by design, as it needs to simulate the methods and tactics that an actual attacker might use. Now, moving on to the advanced level interview questions. And the question is, explain advanced persistent threats. The advanced persistent threats are long-term, highly targeted attacks carried out by the skilled adversaries, often with substantial resources. Unlike regular cyber attacks, which might be opportunistic, APTs are designed to maintain ongoing access to a network without detection. They are sophisticated, stealthy, and persistent. APTs have a few defining characters. First, they are stealthy and persistent. These attackers move slowly and carefully to avoid detection. Second, they use sophisticated techniques like zero-day exploits, phishing, and custom malware to bypass defenses. A typical APT attack progresses through several stages. First, initial intrusion. The attackers gain access, often through phishing or exploiting system vulnerabilities. Next, establish foothold. Malware or backdoors are deployed to ensure they can maintain access. Next, lateral movement. Once inside, they move across the network to find sensitive data. Next, data exfiltration. This is where data is stolen or systems are disrupted as per the attacker's objective. Then comes the maintained presence. Finally, they set up ways to return or continue undetected if they are removed. Now, moving on to the next question. How do you approach securing a large distributed network? So, when it comes to securing a large distributed network, multiple layers of strategies and tools are involved. First up is network segmentation. By dividing the network into smaller isolated segments, you can significantly reduce the risk of attackers moving laterally within your system if they gain access. Using VLANs, subnets, or firewalls to separate segments is common practice and helps limit unauthorized access. Next is strong access controls. This includes enforcing strict authentication methods like multi-factor authentication and ensuring users have only the access they need following the principles of least privilege. This minimizes exposure and reduces potential attack surfaces. Regular security audits and vulnerability scanning are also critical. This helps identify weak points before attackers can exploit them. Audits ensure your security policies are effective, and tools like vulnerability scanners and penetration testing keep you proactive against threats. Next, continuous network monitoring. Continuous network monitoring is essential for early threat detection. Deploy IDS or IPS systems and SIM tools to monitor network activity in real time, setting up alerts for suspicious behavior. This way, potential threats can be identified and mitigated quickly. Lastly, secure configuration management. Ensuring all network devices are configured with secured settings helps maintain a baseline of security across the network. Using configuration management tools can make this process easier and ensure compliance with security standards. And the next question is, what is the importance of forensics in cybersecurity? Digital forensics is a critical aspect of cybersecurity providing vital insights during and after a cyber incident. So, let's break down why forensic is so important. Firstly, forensics enable incident investigations. So, when a breach occurs, forensics specialists work to determine the root cause, the attack vector, and which systems or data were impacted. This information is essential for understanding the scope of the incident and ensuring all compromised areas are addressed. Another core aspect is evidence collection and preservation. Forensics follows stringent methods to gather digital evidence, making sure it's authentic and has integrity. This is especially crucial if the evidence is to be used in court or for regulatory compliance. Forensics also play a role in understanding attack vectors. By examining how an attacker gained access, forensics helps identify specific security gaps. This knowledge is invaluable for enhancing defenses and avoiding similar attacks in the future. Additionally, forensics supports legal actions. In cases where cyber criminals can be prosecuted, digital evidence collected through forensics can be crucial for legal proceedings, making it easier to hold attackers accountable. Lastly, forensics enhances incident response. The insights from forensic investigation provide the response team with actionable information, helping them contain and resolve incidents more effectively and efficiently. And the next question is, what are your strategies for managing supply chain risk in cybersecurity? So, when managing supply chain risk in cybersecurity, there are a few essential strategies to consider. First, start with a thorough vendor assessment. This means evaluating each third-party vendor's security practices to identify and potential vulnerabilities that could impact your organization. Next, it's crucial to enforce security standards with these vendors. By setting clear security policies that they must follow, you help minimize their risk. Another effective strategy is conducting regular audits and monitoring. Audits help confirm that vendors are adhering to the agreed security standards and that there is no lapse in compliance. Finally, having a supply chain risk management program is key. This program ensures a proactive approach to identifying and addressing any emerging risk in your supply chain. Next, explain the concept of container security. Containers allow applications to run consistently across different environments by packaging the app together with its necessary dependencies. However, container shares the underlying host OS. A vulnerability in one container can potentially affect the others. So, how do we secure containers? It boils down to several key stages. First, image scanning is one of the first lines of defense. Before deploying containers, we scan the container images for vulnerabilities, outdated libraries, and any misconfigurations that attackers could exploit. Next, access control is crucial. Implementing least privilege access ensures that users and services only have the minimal rights needed to operate, reducing the chances of unauthorized access. Next, once the containers are running, we need runtime protection. This involves monitoring the containers in real time to detect malicious activities like unusual system calls or unauthorized privilege escalation and responding to potential threats immediately. Then, network security between containers also need attention, ensuring that the communication between containers is encrypted and secure prevents attackers from intercepting or manipulating the data. Lastly, configuration management plays a big role. Secure configurations and policies, including proper handling of secrets like password and API keys, can prevent attackers from exploiting configuration weaknesses. And the next question is, what exactly is quantum cryptography and why should we care about it? Well, quantum cryptography is a new approach to securing communications that uses principles from quantum mechanics, the science that deals with the smallest particles like atoms and photons. In simple terms, it uses quantum bits or qubits to create encryption keys. These keys are super secure because any attempt to intercept them would immediately be detected. This makes quantum cryptography tough to hack. But what makes it really exciting is the future implications. As quantum computers advance, they might be able to break today's encryption methods. Quantum cryptography offers a way to stay ahead of that, ensuring our data stays safe in the long run. The next question is, how do you manage security in a hybrid cloud environment? In a hybrid cloud environment, security management means balancing both on-premises and cloud resources seamlessly. Here are a few ways to make that happen. First, consistent security policies are essential. Make sure that the rule applied to your on-premises setup also extend to your cloud. This way, you avoid gaps in your security framework. Next, use identity and access management to control who can access specific resources, ensuring the right users have the right access. Also, protect your data by encrypting it both at rest and in transit. This ensures that sensitive information is safe no matter where it's stored. Lastly, monitoring and regular audits are key. Monitor your system for unusual activity and conduct audits to ensure security. Next, explain the concept of threat intelligence and its application. So, what exactly is threat intelligence and why does it matter? In simple terms, threat intelligence is about gathering and analyzing data to recognize emerging threats before they cause harm. The main goal of threat intelligence is to help organizations stay ahead of cyber criminals. By analyzing trends and threat patterns, companies can predict potential attacks and take actions before the threat even reaches them. Now, where does threat intelligence apply? It's useful in detecting threats, responding to incidents, managing risk, and even assessing vulnerabilities. Essentially, it's like having an early warning system. Overall, threat intelligence improves security teams' decision-making, reduces risk, and strengthens an organization's security approach. Now, what strategies would you implement for securing mobile applications? So, when it comes to securing mobile applications, there are a few key strategies that can help protect your data and app functionality. First, encryption is essential. By encrypting sensitive data, you make sure that even if data is intercepted, it remains unreadable to unauthorized users. Second, always perform code reviews. Regularly reviewing your code helps you spot potential weaknesses early on so you can fix them before they are exploited. Next, use secure APIs. This controls how data is shared and accessed between applications, preventing unauthorized access. Another critical step is regular updates and patching. Technology evolves fast and so do vulnerabilities. Regular updates help protect against new threats and keep your app's defenses up to date. Finally, strong user authentication methods like two-factor authentication should be implemented. This adds an extra layer of security by ensuring that only authorized users can access the app. The last question of our day is, how do you ensure compliance with international data protection laws like GDPR? So, first, start with data protection policies. These policies guide the organization in handling personal data securely and responsibly. Next, privacy impact assessments are essential. PIAs helps us identify any risk to data privacy in new projects or processes and allow us to take action to reduce those risks. Another critical step is to ensure that we get consent from users when needed and respect their rights. This includes giving people control over their data, like the right to access or delete it. Next, strong data security measures also play a big role in compliance. Encryption, secure storage, and access controls help keep personal data safe from unauthorized access. Lastly, regular compliance audits help verify that all practices remain up to date with data laws. This not only ensures compliance but also demonstrates to regulators that we are serious about protecting user privacy. And with this, we have come to an end to this full course on penetration testing. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.